Welcome to our FTP lab. So we're going to back up a router file using the FTP protocol. So I'll just drag up an 1841, as usual most models will do. A server which we will enable FTP on. This can be our FTP server. Crossover cable. And we'll add an IP address on here, so obviously the IP traffic can pass. I'll put the router as the default gateway. So we'll obviously need an IP configuration on the router side. This will be 192.168.1.1. And then no shut the interface. We'll ping across the link. And that's all working nicely. Alright, so we scroll down and look at what we need to do here. So we need to run this command copy run start. This changes or copies what our running configuration is into a startup configuration. This is what the router will interrogate for when it reboots. And it's obviously a very good idea to save your configurations. You could have 20, 30, 40 lines. We'll go to the server and enable FTP. In fact, it's turned on. We'll create a username of 101 Labs and a password of hello. And we'll tick all of the boxes here: read, write, delete, rename and list, and add that. So we've got another account here that they can FTP, or a device can FTP to. We'll need to add the username and password from the router side. IP FTP, username. It's 101 Labs. IP FTP password. Hello. So this is how it's going to authenticate with the FTP server, or get an agreement to send the traffic. There's no encryption in this particular lab. Alright, so copy startup config to FTP and press enter. The destination file name, you can leave it as the default file name or you can change it. Just bear in mind when the router boots, it is looking for a file called router-confg. Okay, a tiny file, so it was copied very quickly. And I'll just come out of this window and back just so it refreshes the screen, and you can see our config is copied over. So that's proved off the lab. Thanks for watching. Welcome to our lab on SSH, Secure Shell. So we're going to learn how to enable SSH access to a device. In this case, it's going to be a Cisco router. Obviously, there's many other devices you could choose. We'll do it on this one just to practice. Never normally a good idea to permit Telnet access to your network devices, especially in corporate settings, because if you do a remote connection from a PC or whatever it is to your device using Telnet, it's insecure. You can easily have that traffic sniffed by hackers, and they can pull up usernames and passwords and then access your device. So best not do that. So we're going to use the following topology. Connecting a PC normally to a router, you would have a switch. We don't have a switch, so what we'll use is a crossover cable, which I'm sure you've read about in your theory books. So let's get this bit up first. I'm going to use a Cisco Packet Tracer. If you go to the resources section on 101labs.net, we've got tutorials on this, and you can see all the devices here that you can choose from. So I'll choose, it shows you here in the squared brackets, this is network devices. I know the router that has fast Ethernet interfaces is the 1841. Now, as long as it's got Ethernet or Gigabit Ethernet, it doesn't really matter. And you can see if you hover over it, it's actually out of shot, but it shows you which interfaces are connected. I don't know if it'll work here. Yeah, a bit better. Yeah, maybe you can see just on the far left some interface names. Alright, so this is my router, and then end devices. Let me grab a PC, could be a laptop or server. I'll just do a PC. And then click on connections. There's a bunch here. I'll get the crossover cable. Now obviously it's not going to go into my RS-232, my USB, I want my Ethernet. And in the lab diagram, it's the Ethernet 0/0. Again, it doesn't matter which you connect to, but obviously you need to configure the interface that you're connected to. So I'm going to click on the fast Ethernet 0/0. So back to the lab, configure a host name on the router. Routers come with generic host names on Cisco. However, to enable SSH, it actually needs one to be set by the administrator, which is quite easy to do. If you're not familiar with Cisco, I'll just walk you through. Again, this isn't a Cisco tutorial as such. So I'll click on my device and go through the video on 101labs.net resources for more information. I'll go to CLI, which is my command line interface. I'll just make it a bit bigger here. Alright, so you've basically been asked, do you want to enter configuration mode, and it's always no. There's never in your life an instance where you will go to yes, because it just causes you a lot of issues. So I'll go back to the lab. So I need to go into enable mode, which means I'm going to configure something, and then configure the terminal. And then I'm going to change the host name from the default host name, which is router, to R1. And you can see it's changed from router to R1. Add an IP address to each Ethernet interface and no shut the router. This is basically because they're default closed. Ensure you can ping across the link. Your router may have a gigabit interface. As I've mentioned, the other routers will have gigabit because they're newer models. So I'll add this IP address 192.168.1.2. Make sure you get the number right because we're going to be adding 1.1 to our PC, and then that's obviously going to cause a conflict. So we're already in config mode, so I'll go interface, fast. I can hit the tab key if you want to type it all out. You don't have to, you can just leave it as fast. And then 0/0, which is, remember, what we put the cable on. IP address, it's 192.168.1.2, and all IP addresses need a subnet mask, which we cover in a later lab, I think, and it's covered a lot more detail in the Network Plus. The other thing we need to do, because it's currently shut, is to say the opposite of shut. I know it's a bit strange, but you just type no shut, which actually means open. Yeah, don't ask me, I don't write these the codes that configure these devices, but it makes sense, I'm sure. So I'll hop over to my PC. This is really handy. This is why we use Packet Tracer for a lot of our labs for these books, because it's free and it's got all these other devices that we can configure. So 192.168.1.1. So my PC, I'm just going to click on it and just expand the window a bit. Don't need to worry about this. There's more ways than one of doing this, but I'm just going to click on my fast Ethernet interface and I'm going to type my IP address in here. And I'll click down here and it adds the default subnet mask for this range, this class of IP address. So I don't need to do anything else apart from jump back on my PC. I'll type I'll just type end. There's a few ways of getting out of there, but end will do. And I'll type ping 1.1, which is the PC interface. Our lab won't work until we've got some IP connectivity. So it sent 5 pings and we've got 4 replies. The first one is due to an ARP lookup, which I won't discuss in this lab, but it needs to establish the address mappings between layer 2 and 3. So back over to the lab, done the ping, that's worked. Secure router 1 so that it accepts incoming SSH connections. We need to set a domain name and generate keys in order to do this. As options, we've set retries for password to 2 attempts and a timeout of 60 seconds if there's no activity. So these are optional, these parts here, but I thought since we're here, I might as well show them to you. So let's go over and configure IP domain name 101labs.net, and we're going to be in config mode. CompTIA IP dom. I'm going to hit tab. 101labs.net. Okay, if you've typed anything wrong here, you'll just get some sort of error message. So just type it out again, and you can always hit IPD. So you can hit a question mark right after the letter, and it will say what commands have you got that begin with the letter D. So IP domain name 101labs.net, crypto key generate RSA. How many bits in the modulus? I'm going to put 1024. You can leave the default, it doesn't matter. So it's generating the keys. You may not have the exact same output. When I did it, I had this output. I haven't got it on this lab here for some reason. Ah, here it is, sorry. Yep, got it. Alright, so IP SSH timeout 60. Seconds. And IP SSH authentication retries 2. I've used the tab key, which is why it types so quickly. If it's the only command available with those letters, then it will finish it for you. Line VTY are the virtual lines that somebody could use to remotely connect. So this isn't a Cisco course, as I said, but any device you can remotely connect to via Telnet or SSH, and these are the amount of lines. So we've got 0 up to 15. So if you count the amount of numbers available, it's actually 16 ports available. Just check on your device if you're using a different one that there's more. So line, and then what we're going to say is we're going to permit input traffic, that is SSH, transport input SSH. If I do a question mark here, you can see the protocols that would be allowed. You can say nothing, you can say everything, SSH, or Telnet. If you've got a different model, you may have more options here. But we don't care about that at the moment. And then I think the last thing is a password, which I'll put Cisco. Whatever you put here, it doesn't have to be the same password, you just need to remember it. And then end and then show IP SSH. Alright, so just a little basic output here. Connect to router 1 from your PC using SSH. You should be prompted for the password, which, as you can see above, is Cisco. You can add a username for the connection, which I've done here by using the -L switch, the lowercase l. So SSH-L, I've put a username here, you don't have to, and then the IP address of the router. So I'm going to go to command prompt. IP address of my router. Sorry, SSH. This is a IPSSH is the Cisco command. So SSH -L. This is a problem when you go between Linux, Windows, and Cisco and a PC. So I'll put my password Cisco, and you can see I'm on the router prompt here. From now I could actually, if I wanted, or I haven't got an enable password, so I won't cover that now. But you can see I'm on the router, and I could configure it if I'd set the enable password on there. Alright, so I've closed the connection, and that's pretty much the end of the lab. There's a few notes, basically just reminding you to go through the free packet tracer tutorial if you don't know how to use it on 101labs.net. Thanks for watching. Welcome to our lab on Telnet. So Telnet is a way to remotely connect to network devices in order for you to manage or monitor them. You can also configure them. So this is the same as our previous lab, so I'm not going to go through all the steps of how to get it on packet tracer, add the IP addresses and the cables and stuff. Just refer to the last lab for that, which was SSH. So everything the same, adding IP addresses, and when you've done that, you ping across the link, and the ping should work. And then we're going to configure our router to permit incoming Telnet connections. By default, certainly on Cisco, they won't work. So we've got virtual terminal lines, VTY, and there's 16 on this particular model. So let me go to my router. So I'll go into configuration mode. Now I could do line VTY 0 space question mark, and it would tell me my last line number there, which is 15. Now remember this command, transport input, and we're going to say telnet. I'll get it right eventually. I'm going to put a password on here. Now there's more configurations you could do in order to access the router to actually configure it, but we're not really worried about that. So I think that's all we've got for this lab. Yep, and the last command if you want to come out is end. And then next we'll want to go onto our PC. We just go to our desktop, click on the command prompt. Oops. Alright, so I'm back at the PC prompt for the command line, and this time it's Telnet, and then our remote IP address 192.168.1.2. I'll be prompted for my password, so I'm on the router already. Cisco, all lowercase, and you can see I'm at the router prompt, so I'm connected to router 1. I can't go any further because there's more configurations I need to add, but we've proved off our Telnet connections. I don't know if it works on packet tracer. Show line. So these are your lines here, and you can see an asterisk here means the line's used. So this is one of our VTY lines. Hi, you don't need to worry too much about this. I just wanted to see if there was any other commands that would work on packet tracer. You can see we've got a remote connection for 35 seconds, and it's via my PC IP address. Not tested, it won't be tested in the exam. I just wanted to show you some extra bits. Alright, so we're at the end of the lab. Thanks for watching. Okay, welcome to our lab on SMTP. Learn to understand and how to enable SMTP on a small network. So normally you would do this on a specialized server. so Microsoft Exchange or on a Linux server running whatever mail program you wish. To make it easy, this lab we're going to use a mail server in Packet Tracer, and there's basically a server and you drag it over. I'll do it now. And then you look at services, and there's a whole bunch of things that you can configure on this server. Now obviously this isn't going to be anywhere near as complex as configuring email for Microsoft or Linux on an enterprise network, but you're going to get an idea of how it works, and certainly enough hopefully for the exam. So simple mail transfer protocol, protocol for electronic mail transmission, email. Please use the following topology. So we're going to have a switch, a couple of PCs, which will be our network PCs, a DNS server, and a mail server. I won't cover DNS much, only just to get this lab working, because the point of this is to concentrate on the email part. So we're going to get these devices up, and then we're going to configure the IP address on 2 servers and PCs as per the diagram. So over to Packet Tracer. So I've got one server here. I'll just put another server down here. This will be our DNS, a PC for sending and receiving emails, and then to connect everything together, I'll just drag a switch over. It could be any switch, or it could even be a hub. And then we just need to have our straight through cables. Obviously with Ethernet connections. On the switch it won't matter, because we're not going to do any configurations on our switch. There we go. Alright, so eventually the lights on the switch will become green because I've connected the correct cables, and all the interfaces are up by default for layer 2 traffic. And then we'll get our IP addresses on, and we'll be able to connect between each device if we wanted. So let me just check 192.168.1.3 and 4, 5 and 2. So 2, 3, 4 and 5. Might have to go back to the diagram for my memory. In fact, I'm going to do it now. Apologies. So we'll start off with number 3 for this top PC. There's a number of ways to get to this thing here, by the way, this option. I could just go here, or I could go to desktop and IP configuration. Don't need to do anything else. I can click down here, and that's that. So this is 3 and 4. This will be number 5. I'll come back to services later. And then finally 2. Alright, and if you wanted to, you could go to desktop, and this is 3, so you could ping the other devices. Uh, 1.2 and 1. This is 3, so 4 and 5. So I've got IP connectivity. Obviously nothing's going to work unless you've got IP connectivity. So we've done task 1. Next, configure the email settings on both PCs. Credentials are client 1, the email, the mail server, the username and the password. This is for client 1. So again, I'll come back to this lab here, and it's 101labs.net. So I'm under desktop. I'm going to go down to email, my email address. So this would be given to you by your administrator, obviously. So client 1 at 101labs.net, sorry. My username is client1. My password is, what is it, Cisco. And then save. Sorry, there's a name up here. I scroll too far down. We'll come to this screen later. I just want to go to the other PC. So desktop. This is my name's client 2. Obviously, it would be your name. So this will authenticate me on my mail server. Cisco is the password and save, and you can see it jumps to a screen so I can compose and receive emails. So that's that step. On the mail server, turn SMTP on and then add the domain name 101labs.net and the 2 clients and their passwords using the plus key. A little bit fiddly this, but it's only a limited capacity anyway, so we'll go over and fill in all these parts where you can see the arrows. So I just want to make sure I've got the right server. It's this one here. So services, emails are already on, SMTP is turned on, POP3 is turned on, but I'm not going to worry about that. So let me just check the lab, sorry, domain name, yeah. So 101labs.net, I'll set that. My user will be client1, password Cisco, add, and then user client 2. Make sure you spell this right, by the way. Add, so I've got client 1 and client 2. I can change my passwords, or I can click on them and click on the minus, which I don't want to do. So that should be that step. On the DNS server, we're going to set up the domain name for 101labs.net, so the DNS will work and it can send the emails. Using an A record, connect to router 1 from your PC. Oh, this is an old. Sorry, I'll get rid of that. I'm glad I saw that. So we're going to do our DNS settings now. So I click on the bottom one. This is 1.5 desktop, and sorry, services, DNS. It's turned off, so you've got to go on 101labs.net. Oops, net. A record. Add. Whoops, sorry, address. This is our mail server address. 1.2. Okay. On client 1, compose an email addressed to client 2. So you can say anything in here, it doesn't really matter. And then we're going to send, click on send. So compose to client 2 101labs.net. Hi, did it work at all? I'll click on send. Oh, let me just double check my config. Alright, so I typed to 101lab.net. You probably saw me do it when I... So let's try again. It took me a while to find that. I thought I'd configured something wrong in the client, so... But it's good for troubleshooting. So I've got my A record 101labs.net. Oops, sorry, add. Alright, so I'm going to go back to my PC now, compose an email to client2 101labs.net. Hello is the subject. Hi from me. Send. I'll go over to client 1. My email. Now you'll see there's nothing here. What you need to do is click on receive. And then you'll see a message. You can actually click on it. It's from client 1. Subject, received. And then hi from me, and then there's some more information down here. Alright, so that's all we need to do for this lab. Please obviously follow my lab and then make some up for yourself, change some settings and have some fun with it. That's the whole point, so you learn. This is just a springboard. And yep, so there's no notes for this lab. I'll see you on the next lab. Welcome to our lab on DNS. We're going to be looking at converting, or how DNS converts a symbolic host name, for example 101labs.net, to an IP address, and learn how the resolver process works. So open up Wireshark as usual. We'll choose the interface that's capturing traffic, and then go to a web browser and type 101labs.net and then hit return. The only thing to bear in mind is if you've already been to my website, then it will already have a resolver in the cache. So if you want, you could choose a different website. So when you've done that, what I want you to do is put DNS into the search bar, and then you could get some other traffic, but you'll see a standard query which is requesting who the IP address to match this domain name here, and then you should see a query response for 101labs.net. Now bear in mind you might see just a bit of different outputs compared to on the lab. I think I'm using different DNS servers. I'm using Google, and the other thing is since this lab was first done, this written part here, I may have made a change or moved the website onto a different part of the hosting site to use. So just note the query and responses here. There's more than one. All the DNS query and responses made during your PC will be displayed in the packets list, and we're obviously looking for 101labs.net. Select from the packet the first DNS query and look at the related details in the packet details pane. You can see first that DNS runs over UDP. Now it can use TCP, either because you've set it to do so locally, or if it's a zone transfer, or if it's a large amount of information that needs to be sent or received. The default is port 53. So this is what we have. This is what we're looking for first of all. So we go up here, you'll see the DNS here, response, or it could be the query, and you should be able to see if I just click on it. Source port 53, and then destination port is a random port here, and UDP is indeed being used. Typically DNS, and sorry, we'll get all the typos fixed when we come to get the book prepared for printing, is limited to 512 bytes over UDP. Check the RFC. And the number, this does get updated, by the way. At the moment it's 1035, and this length is often sufficient. In case the response requires a larger than 512 bytes, it will then swap to TCP. And we can see our length here is sufficient. A network name resolution DNS query and response process is pretty simple. Your client sends a DNS query to the DNS server, obviously if it's not in the local cache. DNS server responds directly, or it asks another DNS server to do a recursive lookup. Checking the first DNS query on the packet pane and inspect the packet in the details list. You can enable the tree view from item DNS flags and queries. Should be a record type A, as pointed out in the arrows below. So we've got a query here. Click on the flags, queries further down here. Should be type A, a class IN for internet. I've just scrolled down into the packet details here, the UDP, DNS, queries, 101labs.net, type A, class IN. The record A contains the host address for 101labs.net. DNS query was generated automatically when the user enters the host name in the browser URL. And again, you may see slightly different outputs. Select the first DNS response in the packet list and inspect the related info in the packet details pane. So this is our response here, our standard query and then standard response. Onto answers, and then our 101labs.net here. Canonical name, 101labs.net, class A, and then the IP address that the website is hosted on. So then the packet can be correctly encapsulated. Now, often you can put the IP address into your browser, and obviously it won't use DNS. You'll do this when you're troubleshooting DNS issues on your network. The only thing is, I think for my website, I'm hosting multiple domains within one IP address, so that wouldn't necessarily work for you in this particular instance. It's possible to observe the client name request inside this A name. In this case, an IP address has been directly returned for 101labs.net, and the address is here, ending in 104. I don't know if I've changed it. 134. 134, yeah. Alright, so it's the end of this lab. Do try with some other IP addresses. Welcome to our lab on everyone's favourite protocol, HTTP. Just our standard connection out to the internet. So HTTP is referred to as Distributed Hypermedia Information Distribution Application. It's the application you use when you browse in an unsecure way on the internet. There's different versions. Most current version is 1.1. Obviously, you can check your browser, whoever you're with, and see what they're using. Sometimes version 1 is used. Normal HTTP requires a request and response communication. Clients make requests to HTTP servers, and servers respond with status codes. Start Wireshark, and then we'll go to this website, http info.cern.ch. This is this domain is for Switzerland.ch. So we're capturing the traffic. Open up the web browser, info.cern.ch, HTTP, and then we'll inspect some links connected to that page. Stop the capture and save the file. And we're going to save it as CERN HTTP. Alright, so fill in the display filter with HTTP, and the result should be similar to the graphic here. Also got a whole bunch of captures. And we can see the protocol is matching our search term. In the above figure, only HTTP has been displayed. If we display the filter, IP address 188.184.64.53, the packet list pane will be displayed and all the packets exchanged with the remote server, in this case that IP address, can easily be retrieved. Okay, it looks like the address changed from when it was originally, the lab was originally done, which is fine. We can expect this sort of thing to happen, so I'll just make a note of this address. And there we go, we've got some output. From the figure below, it's possible to note that there's some packet loss and a poor response. Moreover, some TCP retransmissions occur before the communication starts. I'll see if that happened for my connection. No, mine didn't, but that's okay. If we look into more detail, you can observe the client makes a three-way TCP handshake from port 54338. This is going to be a random port, so it won't be the same for you, to port 80. This is frames 80, 85 and 86. On mine you can see it's 200. So there's a NAC, a SYNAC and then a NAC. Oh no, sorry, the port numbers, yeah, mine's 50715 By default, Wireshark is configured to dissect HTTP on 10 ports. These are the numbers, but HTTP communications can occur on others as well, as displayed in the figure below from the HTTP protocol preferences. Look at the preferences just at the bottom here. I don't think it's in the lab, but I thought I might as well while we're talking about it. So here's the ports here, just in case you need to make a change. There's 80 at the start. If you capture HTTP traffic running on another port, then just add it to the preferences. After TCP establishes the connection, the client makes a HTTP GET request for /. The server responds with the status code 200 OK and begins sending the client the contents of the main page. Here's mine. Yours will obviously be in a different order to mine, but there's a SYN/ACK ACK 197 so on. Get/HTTP. It's version 1.1 here. There can be a lot of possible status code registries. What was the code here actually? Status code 200, OK. Here's mine. There can be a lot of possible codes. We've grouped them by the type. I'm sure you can pause or do your own research here. Open again the HTTP preference window. Disable the preferences related to allow subdissector to reassemble TCP streams in order to make the HTTP view more clear. So these three parts for the reassemble. The result of the preference change is displayed below, where each individual HTTP message is displayed as a single packet. Got the favicon, HTTP OK, get hypertext, the project.html, and so on. Start again Wireshark and capture on the active interface, the same page. Stop the capture. In case a HTTP client has visited a page recently, that page is cached locally and the client may send the modified modified since parameter and provide a date and time of the previous page download. If the server responds with a not modified, the server will not resend that page, and that's already cached. We can see here HTTP 1.1, 304 not modified. Welcome to our lab, POP, packet structure and filtering. We're going to open up a capture file that we used for the earlier lab. You can get it from a securitysite.com, forensics, and then the PCAP in file here. This won't open it, you'll just click on the POP file to download it, to save it. So I've unzipped and it basically says here, fill in the display filter toolbar with the filter POP, and the result will be something like displayed below. So you can see we've got a load of TCP traffic and other stuff. So entering POP will give us all of the post office protocol in the protocol list here. It's immediately possible to observe that POP packet structures are very simple. POP request consists of a request command and a request parameter. Responses consists of a response indicator and response description. Click, for example, the packet number 30 in the packet list pane, a request from the client, and inspect the related content on the packet details pane. It's the auth request command issued from the client. As a response, the server sends packet number 32 with the response indicator ERR error and response description 1 argument required. It's possible to see in the figure below. Some of the possible request commands are listed below, worth making a note of these. For example, take into consideration packet 93, the RETR command. The request parameter is 1. This means the client wants to retrieve message number 1. See the figure below. The response begins with the response indicator and response description. There are only two response indicators used in POP communications, the OK and the error. The first one is a positive response, the second one indicating there's an error, in this case a response description to clarify the error details. In response to the RETR command, the server sends the OK message at packet 94. If you select the following packet 95 containing the email message and inspect the packet details, we can identify the path the packet took through the mail exchange servers. As shown in the previous task, the display filter used for POP is simply POP. In case it's necessary to use a capture filter, the appropriate filter would be TCP port 110. Because POP communication uses by default the TCP port 100, it's 110. In this case, POP returns traffic on a different port than the capture filter and should be changed accordingly. If we need to display in the packet list pane only some specific messages belonging to POP, then we can use one of the following filters. Fill in the display filter toolbar with the filter POP response indicator OK to select only the POP and OK responses. Or you can try the POP response indicator equals error and you'll see only the errors. If you need to select only a specific request command, for example RETR, we'll use the following filter, RETR. In case we need to select only the specific email message requested with the RTR command, we can create more composite display filters like POP request command RETR and POP request parameter 1. Welcome to our lab, HTTPS Communications. We're going to start Wireshark, select our interface, and then go to website 101labs.net, 101 labs. So we've got the capture going. Inspect some links connected to the main page and then stop the capture. Save the file https 101 labs. Fill in the display filter with the IP address 146.66.102.134. I don't know if the server's been updated. Let me check. In fact, we don't have much traffic here. Sorry about that. I thought there was some internal server change on my web address. I think there has been actually, but we're still keeping the correct IP address. So if I go back to my captcha, maybe I didn't type it in right. IP.ADDR equals 146.66.102.134. That's not saying it won't change in the future, so if it does, please go ahead. I also changed the view. I wanted to see the name resolution, so you might have a bit of a different display to me because it's showing my source here, my web address. So going back to the lab, the start of the secure HTTP conversation, we've obviously got the standard three-way TCP handshake that we've seen before. In the capture, it's packets 361 to 396 inclusive. SYN, SYNAC, ACK, etc. Followed by a secure handshake process for HTTP over TLS based on SSL version 3. So we're looking for the TLS 1.3 here. When analyzing HTTPS traffic, it's important to enable the option allow subdissector to reassemble TCP streams in order to better identify the TLS packets. It's clear from the packet list pane that the communications we're analysing uses standard HTTPS number 443. There are other possibilities. In that case, adding the port in the HTTP preferences will be enough. We can see 443 here. Source. Fill in the display filter toolbar by adding the filter SSL.record content type 22 in order to select only the TLS packets related to the initial handshake. The TLS handshake consists of a series of packets with a content type value of 22. It's possible to verify from the related fields in the packet details pane the use display filter is more appropriate to select only the handshaking packets. The TLS handshake enables peers to agree on security parameters for the exchange of data and to authenticate themselves. In addition, errors during the handshake process are displayed in the TLS handshake packets. The first packet in our handshake is a client hello as indicated in the info field, and the client denotes it's using TLS version 1.3. Select the first handshake packet in the packet list pane, unpack the TLS tree view in the packet details pane in order to identify the TLS fields. As it's possible to observe from the figure below, the random section in this packet contains the universal coordinated time and the client provided in the Unix format. The session ID field contains a non-zero value indicating that this is a resume session. In the case the session ID will be set to 0 for a new session. The client provides the list of cipher suites. Inside the cipher suites field, supported by the browser. In this case, the client supports 17 cipher suites and lists them all in the client hello packet. At the end, the server will make a decision which cipher suite to use, but the top cipher listed is the client's preference. At the end of the TLS packet, there's a series of extensions after compression, the compression methods field. These add functionality to TLS. One extension provides a server name, in this case 101labs.net. The server name extension enables a client to create a secure extension to a virtual server that may be hosted on a machine that supports numerous servers at a single IP address. In the first TLS packet from the server, it's 413 in the captcha, the server responds with a packet containing two functions: hello retry request and change cipher spec. In the random section, the server provides 28 random bytes and a 32-byte session ID value to allow the client to reconnect later. This set of random bytes will again be sent later in the handshake, but it will then be encrypted with the client's public key. These random bytes are used for key generation. Out of the 17 cipher suites offered, the server has selected the cipher suite TLS, ALS, AES 256 GCM. Welcome to our Remote Desktop Connection Lab, RDC for short. You'll need Windows 10 Pro or higher. I downloaded the ISO software versions into my virtual machines just as a sample version. I think you can do that for home use. So we need to turn RDC on. This is the machine I'm going to connect to. So this is my host. Use the control panel, or you can just type remote desktop connection and make sure it's turned on. And while you're there, how to connect, you need the host name. And you need to be in the same network, so you need to be in the same subnet to be able to ping between devices. Alright, so on the next step, on the controlling machine, so the one you're going to be using to remote control, a couple of ways to get to the RDC app. Quickest way is down to the search bar, and again you type the same thing, but you want to look for the app, not the settings. So remote desktop connection, and you'll see the app. So click on that. I've already done one connection, so it's going to show a username. If it's the first time you're doing it, then you won't have a username. You'll just put that in and the password. So put the computer name of your remote device. Your username may not show at the moment, as I said. So you click on connect. You'll need to put a username if you don't have one already. This is how you log into your remote device, and a password. So this will be whatever your account is on the other device. You could get a warning pop up. Click on that, and now you're connected to the remote device, and you can see this is the screen I had up on my host. So you can go and do whatever configuration changes you so wish, and then when you finish doing that, you'll click a little cross in the top bar to close your remote connection. Welcome to our NetBIOS lab. Hopefully you've read up on whatever your theory book is you've got or online about what it does. So we'll use the topology. I've connected two Windows machines. I'm using Windows Pro for all these labs because it supports more of the labs. I'm going to do a NAT network. So have a look through the resources page for setting up a virtual machine if you're using that. Issue the ipconfig command on both machines to confirm they've got separate IP addresses and they're in the same subnet. It's a bit tricky with VirtualBox because some of the settings will produce the same IP address, or you won't be able to communicate between hosts. Alright, so find your network adapter. Now, depending on which version of Windows you're using, you're going to have different ways of doing this. You can do it via the command line, control panel, or on Windows 10 it's through settings. And even there you've got multiple ways of getting to it. But get to your adapter options, right click and properties, and you're looking for TCP IP. And depending on the version you've got, it'll be enabled or disabled. Either way, it needs to be enabled. So you go down to Advanced, over to Wins. Now I've left mine at the default. I've heard other people say you should manually enable it. Again, it depends on your version of Windows. You can easily test this though when we go through the lab and you see if it works or not. So there's a as a whole bunch of switches for your commands on Windows, we're going to just go through one and then you can do the others in your own time. ipconfig all, and it's showing me the NetBIOS over TCP/IP is enabled. Obviously check this on both machines. So nbt stat -a and then the IP address of the remote machine that you wanted to pull the details from. So my remote is 10.0.2.13, I think it said. Just a little typo here, sorry. So the first time I put the command in, it won't work. So try again. It's nbt stat. Doesn't seem the right command to me, but I didn't code this in. So nbt stat space -a space the remote IP address. And it's pulled up the name of the remote device. You can actually, there's another switch with a capital A to look at the names. If I do an ipconfig /all, you'll see the name of your desktop device on the other side. Obviously yours will differ because these are auto-generated when you install Windows. So was that J4, GJ, etc. Here's some screen captures from a lab I did earlier on different machines, and then a little bit of a few notes on the API. So try the other commands also in your own time. Because it's a exam syllabus topic, I think you should know all of these switches. There's only about 8 of them to learn, and obviously try them for yourself. Welcome to our DHCP lab. We're going to learn how DHCP servers allocate IP information to hosts. We've got 2 PCs and a server here. The server will be our DHCP server. Obviously the PCs won't have an IP address yet because they'll need to be allocated one. I'll drag up a switch to connect the PCs to the server. So we've got a mini LAN. Use straight through cables. The interfaces don't really matter, to be honest, for this particular lab. And we'll connect up to the server there. You need to give it up to 20-30 seconds for all the link lights to go from red, then amber, then green. This is simulating what would actually happen on a live network. Alright, so first things first, we'll add an IP address onto our fast Ethernet interface on our switch. So it's 192.168.1.1. And then we're going to go to DHCP. There's already a pool on there. Sometimes it's a bit annoying actually because it causes a few issues, and it looks like it's already got some addresses in the range we want to use. But let's have a go anyway. We'll turn it on. We'll let's see, we'll scroll down here. Okay, the address start 192.168.1.2. The subnet mask is default. The pool name is 101 pool. We'll start with the number 2 because normally you could exclude addresses. I can't see the option here because it's not an actual DHCP server. And we've clicked on add and we can see our pool here. There's other settings which we could add, but I don't think we're going to worry about that too much for this particular lab. You can add them on later and I think they would be sent next time the PCs renew their address. So go to IP configuration, and instead of static I'll click on DHCP, and you can see that's been populated quite quickly with the first IP address in the pool. Click on the desktop IP configuration, DHCP, and hopefully .3 will appear, and there you can see that's all working fine. There's a whole bunch of debugs you could do and show commands on the server. I've issued the ipconfig command. You can see our IP address is allocated. So that's all working fine, and just click on the server. You would see more information if it was an actual live server. So thanks for watching. Very simple lab, LDAP. We won't be able to test this because it takes a lot more configuration for your client and server. So I just want to show you how to enable. You need Windows 10 Pro or higher. From the search bar, there's many ways to get there as usual. I think just the quickest way we'll do for this lab is to type group policy, and at the top you'll have a few options. You want to go to the top one, which is edit the group policy. There's a whole bunch of options here. For this lab, we're just going to look at one particular main setting on the left. If you've got the book, you can follow along, otherwise you can just watch me do it in the lab. So Windows settings, security settings, local policies, and then security options. So settings and then security settings. Let me just go back to the lab, sorry. Local policies and security options. Now just note, in case you get asked in the exam, I don't think you will, there's two different places to go. One place you'll go if you're configuring Windows Server, and the other one for client, which we're doing. So here's the server settings under domain controller, LDAP server signing. If you want to configure the client, you scroll all the way down to the network security, LDAP client signing requirements. Now we're going to click on require signing. So from the three drop down options, you click apply and then OK. So apply yes and then OK. You can read up further on it obviously, and then you can just exit out of the application and it's all been enabled. Welcome to our SNMP lab. Really powerful protocol, and normally most large networks will have a person or team doing the SNMP monitoring. Now behind SNMP is a series of complicated processes and mini programs, MIBs, that you would need to learn. There's entire books on that if you want to go into it in more detail. I know at Cisco System there was a fairly large SNMP management team for their version of software. Cisco Works, I'm not sure if they still sell it. So I'll do a configuration here. Routers connected to a server, and we'll have the server monitor events going on to the Cisco router here. Check that your whatever your manufacturer is supporting and providing the software. Say for example you're using SolarWinds SNMP software, that they supply the software that will allow you to manage your devices remotely. So 1.2 is the PC address, and the default gateway on the PC here is the router address. So I'll ping the PC from the router. So the PC will be your SNMP management station. I said server earlier, I meant to PC, sorry. And what we're going to do, this is a real basic test. We're going to create a SNMP server community, and then we'll make a change remotely onto the router, but from the PC. So the SNMP server community comes with rights, and these rights will enable us to read or write, read only, and make changes to the device, or just look at outputs. Now, you've got to put the community lab name in. I actually did it the wrong way around. I should have just left it at read write. So I'm going to have to come back and fix this in a moment, and just put the one command in, the 101 labs read write. So I'll come back and fix that in a moment. But on the PC, you go to desktops and then the MIB browser, management informational base. And then we're going to have to do some configurations. The remote address is 192.168.1.1. You can see the advanced settings here. Read community and then the write community we configured on the router, so just copy that name. There's different versions offering security and enhanced features. Obviously, version 3 would be ideal to run on your network, but I'm just going to use version 1. Now we've got to drill down and find the MIB that's going to allow us to make a change on the router. Each MIB is written for each device, and then you'll have a separate MIB for the model of the device, and then each interface or each different feature. For example, the power supply you can manage, the interfaces you can manage. So we'll go to router standard ISO org. I have to keep looking because we've got to drill down a long way here into submenus. This is why I guess people use graphical. Internet management, MIB2, and then system, it looks like, and then system name. So this will allow us to set a host name on the remote device. In your own time, please look at the other options you have. Do some research on Cisco's website or Google and see what you can change. So sysname, I've clicked on go. The current value you can see is router, which is the default on Cisco routers. The default name is router. We have to go in and change the host name through the command line. We're going to want to set it. And then we scroll down, instead of bits, the octet string. We're going to change the name of the router, the host name, to 101 labs. I'll go to a simulation mode, and then hopefully we can find, I thought SNMP might be here, but just scroll through to the miscellaneous SNMP. Alright, well, so we can see that there. If you want to check the SNMP debugs, I'm not sure what level you'll get in the simulator for this, because obviously live traffic isn't sent across the network emulator. So in a moment, I'll just look up through here, and you can see it's the last command that took here, the read only. So I'll repeat the command that I had in first. That gives me the read write access. Go back again. This time I'll set the value to 101 labs. Press OK. You can see the value table in there. Click on go. Alright, so the value's changed now. And you can see log into the router, press enter, and then the 101 labs has appeared. Thanks for watching. Welcome to our lab on UDP. Learn how UDP works and why it's used. Understand the main purpose of UDP. So we've just got one device through to our network router. So UDP is one of the most common protocols used in networking. Start Wireshark, capture, options, select an interface, and then we'll look to see if any UDP traffic is passes along the interface. We're going to do a search on IP DST and then a broadcast. So let's have a go. This has been booted up a while, so we might not actually CNE very quickly. Alright, so if we do a search for IP destination, then the broadcast. Looks like I've got one here then. Now this is DHCP, which is fine. If you want to prompt a DNS lookup, you can actually disable and then enable your network interface in the settings. Where are we? Settings. You can just disable and then re-enable it, or there's a command to flush your DNS. I don't have it to hand because you could be using Windows, which is ipconfig / flush DNS, I think, or sorry, ipconfig / release and then ipconfig / renew. Now for on Ubuntu, sorry. Either way, we've got DHCP, and if we go back to the lab here, we've done a search for the broadcast. The UDP header port fields identify the application using the transport layer. Considering the fact that UDP uses a simple 8-byte header that consists of 4 fields, UDP itself rarely experiences much trouble during the communication. Fully display the filter toolbar with UDP, inspect a packet of choice, selecting UDP in the packet details. Now, as I said, we've actually got DNS request by the looks of it, yeah, but this obviously works inside UDP. So we've got a simple source port, destination port, so this will be requesting an IP address. And you can see if we go up here, the source address, it's actually a broadcast. So protocol UDP is protocol 17. It's time to live, we've generated it, so it's set to 255. And then the destination here. Automatically, the 8 bytes composing the UDP header are highlighted in the packet bytes pane. They consist of source and destination port, length and checksum. Source, destination port, length and checksum. The most common applications that use UDP are THCP, a DHCP /bootp, which is what we've got here. This is a DHCP ACK packet. SIP, RTP, DNS and TFTP. So you can do some more testing on this and generate some other types of traffic. You have to download the TFTP package for Ubuntu. Start the capture again and type from the shell DHCP client EN0. I think mine's EN3, which I'll check. This way your network card is forced to send a DHCP request to the server. Stop the capture and use DHCP as the display filter. So here's mine. I'm just going to write this down because it's a bit harder for me to remember. So ENP0S3 and then DHCP client before your interface. So we can go back and just change that to sudo because we have to do it as admin. Stop the capture and we'll use DHCP as our filter. Now we've got in the lab, I need to check on this. We did a filter on DHCP record in the lab. That's not working. So it could be the version the lab was originally recorded on, because in the protocol field here you can see DHCP, but that isn't actually accepted. It doesn't go green. So boot P does, which we know is involved in the DHCP process. So I will look into that, and then I'll update the book if you have the book. Now it's possible to confirm that DHCP uses destination port 67 for the DHCP server, inspecting the UDP header details in the packets pane. Source port 68, destination port 67. So there's a request, and then you'll see it swapped when you get an acknowledgement from the server. On the client side, the source port is a temporary port. Instead, it can be different each time. Start a capture from Wireshark and type DNS lookup google.com in order to send a DNS request towards the server. Now I might have this cached. I can't remember if I've actually gone to google.com or not recently. So on Wireshark, it's possible to see DNS packets filtering with the display filter DNS shown in the figure below. Right, looks like we might have actually already had that stored as a thought. Could be my default home page. Let's see if we need to do a search for another website. It's possible to observe that the destination port 53 is fixed for DNS requests. So let's just have a look. Yeah. Alright, so we don't need to look at a new website. We can see the source port is a random port, but the destination port is 53. So repeat for different types of UDP messages, DHCP, DNS, or find a way of sending a TFTP or SIP requests. As I said, you can actually Google that and install the TFTP software to drop a file and request a file off your neighbour device. Welcome to our lab on TCP. We're going to learn a bit about the TCP protocol, Transmission Control Protocol. It's used for connection-oriented communication. It begins with a handshake between two devices. All data is in sequential order. Each packet is acknowledged. So we're going to open up our Wireshark as usual, and we'll capture traffic from our standard interface. Mine's ENP0S3. And all things being equal, it will start capturing some generic traffic. And then we'll telnet to a free online telnet server, telehack.com. Hopefully this will be available for some time to come. If not, I'll just find another one online. So when we telnet, we should see some outputs. I'll press enter here. You stop the capture for a while so we can stop traffic scrolling through the interface. Now you can filter on a few things. You could start off using telnet in the packet filter here, the display filter, sorry. So this will just show our Telnet traffic. We want to look at something a bit more specific, i.e. the three-way handshake, which hopefully you've read about in whichever guide, study guide. Now the IP address could change of this Telnet server, but for now it's matching what we have in the written lab, 64.13.139.230. So I'll filter on the TCP and IP address, and I'll put the IP address of our Telnet server here. From the packets listed by the filter, it's clear the establishment of the TCP connection is based on the first three packets. Every TCP connection starts with a SYN, then a SYN-ACK, followed by an ACK. So you should see this on your CAPTCHA. On mine you can see SYN in the squared brackets, SYN-ACK, followed by the ACK is the third one down. Your packet numbers will obviously be different to mine, as is different when we first wrote the lab. I've gone to the down to the TCP section in the CAPTCHA. The SYN packet synchronises the sequence numbers to ensure both sides know each of the starting numbers. In the following figure, it's possible to observe the host establishes a TCP connection, and our packet contains the SYN marker. See the window size has been agreed between the two devices. The Telnet data here, I can see next sequence number is 28 and it's acknowledging number 28, the relative acknowledgement number. So you can dig into more and hopefully, like I said, refer to any theory book you have. We'll start capturing some packets, and we'll end the session with the exit command. So I'll type exit. Now your output may differ to mine depending on your operating system and your local settings. TCP connections are terminated in several ways. Explicit termination uses TCP RST resets. It's possible to see the server sends a RST message, the client sends an ACK frame accepting. Now you may see a FIN bit as well, FIN bit. I didn't on my CAPTCHA. The output from the lab book was on a different type of machine. That was on a Mac. So these all use the stacker slightly differently. So you can see the RST and ACK bit here. So it's resetting the connection. So don't worry too much if you don't have exactly the same output. As I said, the original CAPTCHA, I think we had a FIN bit. We'll start again a CAPTCHA and we're going to Telnet, but we're going to change the default port to 69, which, as I'm sure you know, is a TFTP port. So I'll just go to Wireshark, sorry, and make sure it's capturing. Now I've done the Telnet to telehack on port 69. I had to pause the video because this will take a while. Depending on your operating system, it will try several attempts and keep trying, and you may have just a slightly different output to me. So this took about 2 minutes, so I had to pause the video. My capture was a bit different to the original one, which was, as I said, done on a Mac. The Mac had a ICMP destination unreachable message. This could be because of the firewall on my local machine, my ISP, or a change remotely on the other side. So here's the figure. The was originally caught, and we had an ICMP packet capture, which I didn't have. So if you see the message, it means there's a firewall block. Type 3 code 9 was originally captured. And you should be familiar with the possible code messages to tell you what exactly the issue was. If TCP doesn't receive any response, we must assume our SYN packet did not arrive. Welcome to our lab. We're going to do a brief configuration of a router. So we use Cisco Packet Tracer because it's free and we can drag all the network equipment onto a canvas and do some configurations. The 2911 is actually end of life. Not that it matters, but I'll drag a current one on. So 4331 model. Here's the lab book, obviously, but we'll go through it for real. So I've opened Packet Tracer. The far left is network devices. And in my version, the furthest left router is the 4331. As time goes on, obviously, this will change and they'll have different models. So I'll click on physical. I'll click on zoom in. So this is a image of what the router would look like if you'd bought it. Obviously, we're just running a virtual router here in Packet Tracer. I recommend you go through the documentation for that model of router. Just Google the term Cisco 4331, and there's some at-a-glance documentation. I just want you to look through the sales stuff and just see what it's capable of. You won't be tested in the exam. I just want you to see what you would do if you were going to buy one for your company. So this is the at a glance, and you'll obviously need to work out if it's going to fulfill your particular needs, if it's got enough modules, how much it costs, and that kind of stuff. Then you might have to present a case to your business owner. So on the Packet Tracer graphic, switch off the power button and we'll drag a module into the empty slot. These are modular routers. So some of the ports are actually built into the circuit board on the upper far left. You can see some Ethernet there. So I'll click on NM2T after turning the router off. I'll turn it back on by clicking the button, and then the router will boot. Now what we'll do is a very basic configuration. This isn't tested in the A+ exam. It's just for you to just get familiar with the command line interface. This is only for Cisco routers, so if you were using a Juniper or a Aruba router, it would have a different environment. So I'll press no for initial configuration. I'll type enable to go into a more powerful mode. And then what I'll do is put a IP address onto the interface. What I think I'll do is one of the serial interfaces. So I'll do show IP interface brief, and that tells me the interfaces I've got configured or physically attached to the router. 3 gigabit Ethernet, and I've got 2 serials. And if you remember, we've dragged these 2 serial interfaces on a card into the blank slot. So here's the configuration for adding an IP address to a Cisco router at the very least. So if you copy along with me, and we'll do this serial 0/1/0 interface. So config T, conf T, press enter, interface serial 0/1/0, enter, IP address 192.168.1.1, 255.255.255.0. This is your IP address and then subnet mask. I'm going to add a clock rate. Don't worry about it too much. It's just clocking between the other device that we're going to connect to so they can synchronize the data. I want you to drag another router onto the canvas to the right. Everything's exactly the same. The module you need to add, powering off and that kind of stuff. And then we'll go to the command line and we'll add an IP address, but it needs to be a different IP address. We can only have one unique IP address per device. So just let the device boot. I actually forgot to drag the module on, so I'll try and do the IP address and quickly drop into troubleshooting mode when I realise what I've done. So you can just click on the physical tab on the top, turn the power off, drag the module over, and then turn it back on, and just give it a moment to reboot. So no to initial mode, enable CompTIA, short for config terminal. The interface name and number, S is short for serial. The IP address is 192.168.1.2 on this side, the other one was 1.1. I need to enter no shut. I won't need a clock rate on this side because I'll add a special cable to the left-hand router. So under cables, I'm going to go all the way across to the one with the little clock on, and I'll click on the left-hand router. I'll click on the correct interface that I've configured, and then drag it to the same interface on the right-hand router. And then the final thing I need to do is issue a ping from the left-hand router .1 to the right-hand router, which is .2. So ping 192.168.1.2, we cover ping in another lab, and you can see the ping has been a success. Welcome to our lab on network switches. There's many different varieties and models, but the easiest way is to use a switch from Packet Tracer. We'll drag a 2960 model onto the canvas. So click on Network Devices and then Switches underneath that, and then drag it to the top. You can double click it. I think I connect it up now, but you don't need to do that quite yet. So you can see the interfaces. Have a look through the documentation. Basically the next step is just to Google the Cisco 2960. Have a look through the type of ports, what you can and can't do with it, what it features in terms of IP services and protocols. This is just for your information, you won't be tested on any particular vendor. Then go to devices and drag two PCs to the desktop. Up to you, you can connect them now with a crossover cable, or you can wait till later on, as long as you remember to do it before we do a ping. So it takes about 30 seconds for these switch interfaces to go from red to orange and then green. If you hover over any device, you can see a brief summary of the interfaces. That's in Packet Tracer. So we'll go to our host. On the left-hand one, I'll configure the 192.168.1.1 IP address. And on the right-hand one, it'll be the .2 address. Couple of ways to get to the IP address in. I'll click on the interface name under config for the PC. If you click on subnet mask, it auto completes it with the default one. And over to the right hand side PC. So 192.168.1.2, and then click down. There's a whole bunch of stuff you can do with switches. I'm just going to show you one feature. So switches store the mapping of which ports have which MAC address attached in a CAM table, certainly on Cisco switches. So show MAC address table in enable mode, and there's nothing there, so the switch hasn't learned any addresses yet. So what we need to do is send some traffic through, so it sends the traffic and then creates a mapping. The addresses will stay in the table for a certain period of time depending on your switch model and manufacturer, and then it will clear the table and wait for more traffic. So I'll ping .2 from the .1 host to send some traffic. That's all worked. Now I'll go back to my switch and I'll check the MAC address table again. I'll just hit the up arrow to save time. You can see it's stored a MAC address, it's dynamically learned it, and it's telling you which port the MAC address has been learned from. If you issue ipconfig/all in a command prompt, you'll see the MAC address is D569, that's what it ends in, and it matches exactly what's been learned on our switch. Welcome to our Installer Hub presentation, lab, video, whatever we are. We've got a simple hub with 4 devices connected, and as you probably know from your theory, the hub has just got no way of knowing which device is connected where. All it does is take in a frame, it can boost it if it needs to, and it then forwards it out of all ports which has a device connected. So I've added, it looks like I've added IP addresses 192.168.1, then 2, then 3, then 4 to all of these PCs. You've done it a few times now. I've dragged up a hub onto the desktop and then just used an Ethernet cable to connect them all. So this is our hub. There's no configuration you can do. It's just got ports. So basically it's a multi-port repeater. And what we'll do is we'll go to simulation mode. Just move this across and we'll do a ping. I mean, mini switches are so cheap now, it just makes sense for you. You could have just invested in one of those even for your home network. So I'll ping 1.4, I'll press enter. I'll just come out and press the play button. I should have done the show or none actually. Edit filters. I'll just have a look at. I could have just cleared everything to be honest, but I've left ICMP on. Alright, so press play, and I'm sure you know what's going to happen next. The frame will go into the hub, and then it'll be sent out to all other 3 devices, 2 of which will have to stop what they're doing, process the frame and drop it. One of them, the bottom right PC there, you can see, realizes it's the correct recipient, sends a reply back. The reply goes to all 3 interfaces apart from the one, well, it goes to all interfaces apart from the one it came in on, and obviously 2 of them can't process the packet because it isn't intended for them. So pretty redundant to be honest using hubs now, but I just want to prove off what you've probably read in your theory about the fact that they can't store addresses. Alright, this is just going to carry on and on for the all 4 or 5 ping packets. So seen enough of that, I think. Come to the end of the lab. Thanks for watching. Welcome to our Configure Layer 7 firewall. We'll go to meraki.cisco.com where we can actually access a trial demo version. You click on Get a Demo. You can put in an email address and a password and that kind of stuff, and they'll email you a authentication link. You can request actually trialing the gear, but for most of us obviously that's not going to be feasible. So you can start the demo. You just need to put in whatever details here in the registration page. Now this is just going to be a bit of a tour really, and then we'll just probably add a line of configuration because it's such a complicated process, and you could go away in a training course to actually learn how to install and manage and configure all of this. So I'll just put in my details here, make up a phone number. Now I found the registration links actually took a while to come through, so you might have to register and then wait to go do another lab and then eventually it'll come through the email that you click on. I think you can access it instantly once you've logged in, but you get limited access to some of the features. Alright, so this is the page you're taken to. A dashboard is the best place to go, but I recommend you click on all the links to see what's available. I go to configure and then firewall for the appliance. Alright, the firewall opens. You can see we've got layer 3 rules here. Outbound rules, failover rules. Just click on, just press on the information radio button. It will tell you exactly what each line does. But layer 7 further down, you can say there's no layer 7 rules defined. This device does a whole ton of stuff. You can see there's NAT and IP source spoofing protection. But this is where we want to be. The port forwarding, the layer 7 rules. I'm just showing you all the stuff that's available down the bottom here. Click add a layer 7 rule. Now there's a whole bunch of stuff you can do here for layer 7, websites and services, file sharing, gaming, productivity, and the mind actually boggles. But we'll find something that's going to work for us. We'll go to online backups, and what we'll do is stop any backups to Backblaze, which is an online service I use, because this actually runs 24/7 and it constantly backs up to the cloud server, so it's going to clog up a lot of your bandwidth. And the other thing we'll deny is, let's have a look, video and music, and we'll deny them surfing, let's see, YouTube, because we want to spoil all their fun. You can actually use the crosshairs to drag to different priorities if you want, because it will go from top to bottom. We'll deny a certain host name, and I'll just say 101labs.net. So that's a website that's actually blocked. When you're happy with that, you can save changes. Now you'll go back over to clients through your dashboard and find there'll be a list of clients. If you can click on any of these. You might as well just click on the top one. You might have a different list of devices when you're doing your trial. But you can see this person's got a MacBook Air. There's a whole bunch of statistics, IP addresses, and you can see further down here there's device policies. You can block someone if you think their device has been stolen, and you can show details of their firewall rules. Layer 7 firewall rule shows you that the device is blocking the 3 things that we configured for layer 7. So just a little play. You can have some more time yourself, but this is the end of the lab. Thanks for watching. Welcome to our lab on the network interface card. So many different cards in different devices, so I just thought we'd use a packet tracer server, which you can get from under devices. Just drag a generic server to the desktop and a switch. Any switch will do actually. So I'll drag a 2960, I think it is. Now on the left hand server we won't connect anything yet. We'll drag a second network card, just so I wanted you to have a little go on virtually installing one. So I just need to drag the image a bit bigger, and then we need to hit the off button. Obviously you'd power off your device when you're doing it. We'll drag it NM1CFE, which is just a fast Ethernet network card. if you press on any of the devices, you can see a description in the bottom there. It tells you what the device is. There's lots of different types of cards you can add. Now on the left server, you'll see instead of one option for connecting to the Fast Ethernet card, we've now got two. We'll connect to the bottom one and to port 01 on the switch, and then on the right hand one, all straight through cables, one card to the second available interface on the switch, which is Fast Ethernet 0/2. So when you come to configure the left hand server now, server 0, you'll have two cards. We'll have a look for Fast Ethernet 1, sorry. There's a couple of ways to get here. So I'll go into the interface, the config, sorry, then in the interface, and you can click on the interface number. But there's a couple of other settings I want to do, so I'll actually click on the name in the left bar. I'll add the IP address 192.168.1.1. Now in the top we can change the settings, so I'll turn off auto negotiate and I'll leave the default settings as full duplex and 100. So I won't actually change anything, but I've disabled auto negotiation. And you can see on the left there it's gone red, which means the connection's down. On the right hand switch, I'll add the 192.168.1.2 address. And you can see on the left that it stayed up. So something's happened here, and this is the kind of thing you'll experience in the real world. So I'm glad it happened. So I'll click on the switch, I'll go to the command line interface, CLI. And the left hand one's gone down, so it's just a little bit of a strange thing happened here. I'll issue show interface is Fast Ethernet 0/1. Now I don't know why, but the switch has set itself to half duplex and the speed is correct, 100 meg. Now I'd have to check the documentation because it should auto to full duplex. So I'll go to interface Fast Ethernet 0/1 and I'm going to hard set the speed to 100. I'll set the duplex to full. That should bring the interface up. Now, the reasons why it set itself to half, I don't know. As I said, you'd have to read the documentation, or it could be a bug in the software for Packet Tracer. So you will normally have to wait 30 seconds for the interface to recycle. You can see it's orange at the moment, and eventually it will change to green, and then you should be able to ping from one end to the other. So in the right-hand server, server 1, I'll get a command prompt up, and I'll ping 192.168.1.1, and the ping is successful. So this is a super quick lab on Power over Ethernet basics. I think the quickest way is just to connect a Cisco IP telephone to a switch that supports Power over Ethernet. So again, you have to look at the documentation, but to save you time, we'll drag a layer 3 switch. In this instance, it's a 3560, which does support Power over Ethernet. Again, have a quick flick through the Cisco website if you want to check which switches do what. And I've dragged an IP phone and a straight through cable. I'll need to choose the correct interface, so it's the one that connects to a switch on the phone. You can connect to a PC, and the important thing is to drag a power cable onto the power interface on your phone, otherwise it won't boot up. It's a bit of a strange thing to get you to do, but just so you know, it won't work until you do that. Now we'll try a few commands. The command that does work in Packet Tracer, we're a little bit limited, is the show power inline. So this shows you your power over Ethernet settings. I'll show you some other commands in a minute, but unfortunately they're not supported on Packet Tracer, but I just wanted to show you anyway. So enable, show power inline, and you can see our interface. It's auto, it's on. It's drawing 10 watts of power, and down here you can see that matches, so how many you've got left, and it's telling you you've got an IP phone, a 7960 model. There's a class of device also which we don't need to worry about. I'll show you a couple of the commands just down here in case you do have access to a live switch. Otherwise don't worry, it won't be tested in the exam, it's just for your information. And the other thing, if I just go further down, I just wanted to show you that you can disable Power over Ethernet if you want with the following commands on your switch. So CompTIA and then interface, whatever it is, fast Ethernet 0/1, power space question mark, and then I can see my next one is in line, and then I've got the two choices here. Welcome to the motion detection lab. We're going to use the Internet of Things to set up our motion detection, and this is one of several security steps you can take according to the Network Plus syllabus. So we'll go to end devices, and you can go down to home here, and you can see all the Internet of Things. We're going to drag up a motion sensor, and also this is a webcam, but it's also a you can use it as a security camera, obviously. For a device, we'll use a switch so we can connect all these devices together. And an end device, we'll use our server. These are to register our devices that we're going to manage and also to set behaviors. We can configure any, connect to any ports on the switch, just use straight through cables. So all our ports are all connected. And you might have done the Internet of Things lab earlier, so some of this will look familiar to you. Firstly, we need to add IP configurations to our devices. Make sure the IoT is turned on the server. So you go to Services, IoT, on. Next thing, we need to configure an account on the registration server. All we need to do on the server is open up a web interface. Here, the web browser. We'll put our own IP address in. This will load the IoT server, the GUI, and then we can register. Now, we don't have an account. We just need to go to the bottom left here and create an account. I've created one before, but it doesn't get stored. Alright, so we've got no devices showing in our list, so we'll need to register some devices. First thing I like to do is change the name of the devices to something that's going to be a bit easier for us to remember. So I'll go to this global settings and change it to motion, and the webcam, you can change that. Webcam. Set the IP address of the motion sensor to 192.168.1.2 and the webcam to .3. Next thing we need to do is set the registration server IP address and add in the credentials that will authenticate our devices onto the server. So it's going to be a remote server, 192.168.1.1 is the address, username 101 labs, and password's hello. And we'll click on connect. We'll check over on the server in a minute. Now we're over on our webcam, and it's all the same steps. We go back to our server now. We can see 2 devices are registered. The webcam screen is blank at the moment. It's not recording anything, as you can see on the server. Alright, so go to conditions now. We'll need to say what happens. If something happens, what's the action? So let's say webcam on. What will trigger the webcam? We'll say motion. That's one of the devices. Motion on is true. Then what will happen? Webcam on true. So if the motion detector is activated, the webcam will be activated. The other thing is if the motion detection isn't active, like nothing's happening, then we need to disable the webcam. So webcam off is the new condition. If the motion on is set to false, then set webcam, a bit confusing, the webcam on status to false. This and/or logic can be a bit difficult to understand. Alright, now if you want to activate the webcam, you need to, obviously we can't walk in front of it because it's not really there, so we just need to hold down the Alt key and wave our mouse in front of it. I'll just open up the webcam here, and we need to resize our windows. Find packet tracer, and then we'll see if we can set the webcam off. So this would be as if somebody had triggered it at our house or office or wherever. Alright, so I'll hold down the Alt key and I'll wave my pointer in front of it. And we should see the light go on, and then the picture shows us that some person has triggered it off. If it stops working, then the webcam turns off, and then you can activate it again if you want. So that's proved off the lab. Alright, so we're all done. Thanks for watching. Welcome to our lab on IPv6 addressing. So we'll look at a couple of different ways of doing it. We'll manually add this address here on the left and use auto address configuration on the right. This you may have different features available in different routers, but a big selling point for IPv6 is the fact that it can partially or completely configure its own addressing system. So we'll go over to the left-hand router and call it R0 as usual. We'll enable IPv6 with the IPv6 unicast -routing command, and then go straight to our gigabit Ethernet interface. IPv6 will add the address here from the diagram, which is they're a bit of a pain to type out, obviously, because they're so long. You can skip some of the leading zeros, and there's some of the ways you can use to shorten it, as you can see the double. So IPv6 address, bit of a pain to configure these. And you'll see some of these short link methods available. I've got B14 there, so you can see I can miss off the leading 0. I've missed off 3 leading zeros for the 2, and then the double colon you can use also, which will fill in the remaining parts with zeros. But read your study guide for more information on that part there. Over to router 1 now. I'll configure the host name so we don't get mixed up. IPv6 unicast routing, the gigabit interface. Now IPv6 address, And there's a few different choices we have here. I'm going to say auto configure your own address. We're going to come back to this again later in another lab, but it's going to use the MAC address to pad out the address that we need, and also add some of the auto configuration parameters. Show IPv6 interface gigabit 0/0, and if we scroll up, we'll say what is your address here. It's added the link local address. There's no global unicast address on here at the moment. Show IPv6 interface gigabit 0/0, and we can see we've got our link local address, but we also hard configured an address on the interface here. There's compulsory multicast groups that the interface must join in order to work with IPv6. Show IPv6 interface brief, and you can see my gigabit Ethernet is up. You can see the link local address, so it can communicate to the local router, send neighbor discovery information and routing protocols. And I want to ping IPv6. The quickest thing to do is cut and paste the address off the other interface, otherwise you're going to be forever typing out addresses there. Output interface, because it's a link local address, you have to say what interface are you going to leave via. It's just a foible of the command. So I'll say go via gigabit Ethernet 0/0, and you can see that's worked. So just a short lab, but I think we're all done for now. Thanks for watching. Welcome to our lab on RAID. I'm doing this in Windows 10 using VirtualBox. I've got Windows Pro because I think that's what you need for RAID. I clicked on storage and I added a new virtual disk. There's a lot of videos online showing you how to do that, but I just wanted to point out that you can't do the lab without it. So storage, and there'll be a little green square disk inside here, just up here. You can add that, create a new disk, and it's a VDI VirtualBox disk image. As I said, there's videos on that. I just went through the wizard and just clicked on create, and it created one for me. You can delete it later on. Then I booted that machine. As I said, I think you need Windows 10 Pro or higher. And then one of the quickest ways is storage spaces. You type in storage spaces in the little search box. Click on the manage storage spaces. Now you do need to check Windows documentation because it doesn't say RAID. There's the disk there, by the way. I just went into Disk Manager. It doesn't say RAID 0, 1, 5, 10. It's got its own name. Click on create a new pool. You might get a warning, so click on it. And I've only got one disk, so my options are going to be limited. You'll see some are grayed out. You'll need to add, I think, maybe 3 or more, depending on the type of RAID that you wanted to configure. So I'll click on create pool because this will automatically tick to my drive. Now you can see create storage space is grayed out on the bottom. I can't choose some of these. I think I can only have the simple with no resiliency. So your others, check the documentation for what matches RAID 1 and 5, etc. So I'll just have the simple one, and as you can see I can't create anything until I've put a size in, and even then it's just this simple I get to choose. So I go to the simple and then click on create. Obviously you can play with this and check your different settings. Name, optimize, create more backups or RAID. Welcome to our hot swap lab. There's other terms instead of hot swappable, so it just depends on which vendor you're working from or working with. You can check the documentation depending on your vendor. I've obviously got some Cisco equipment here. This could work with servers also. So the idea of hot swapping is you can add, remove or replace modules or power supplies in-network devices without powering them down. So if you've got an outage or some big issue and you've got two power supplies, hot swapping means you can take one out and fix it with a known good power supply without having to power down your device and potentially affect hundreds or thousands of customers and obviously your own company if you're not supporting different customers. So we're going to use a topology, a layer 3 switch. Technically this is an icon for an ATM switch, but a multi-layer switch and a router. I'm suggesting, looking at my version of Packet Tracer, to use an ISR 4331 router and a 3560 multi-layer switch. So for switches, 3650, and on all of them you can click on physical view and zoom in and just move your window enough so you can view what the front, this is the front of the device and this is the back, it's just the way they show it. So obviously if you were working at the front you'd be plugging your cables in here. And the other one was the ISR router. So I'll click on routers, 4331, this is an ISR. And if I click on physical, it's already open for that, and zoom in. So what I want to do is you'll find out from your vendor which ones do or don't support hot swapping, and just check for any bugs as well, because sometimes it says they do support and it turns out it doesn't work, as I found out when I worked for Cisco. Alright, so on the ISR, drag a network module to an empty slot and you should see a warning about having to power off the device first. So I'll use the NIM2T and I'll drag it to one of the network slots. Cannot add a module when the power is on, so basically you'd have to power off your device, which if this is a production unit you would have to schedule downtime, which is a bit annoying. Now the multi-layer switch is a bit different, so you can either click on here and drag, or I'll just drag this power supply here. So I've got one power supply and the green's on, another power supply and the green's on. This is booting at the moment. I'll just put in a no. You don't really need to do this part, but I just thought I'd show you. Now go back to physical and say one of these power supplies failed. What you could do would be take it out, and when a new one comes in from the vendor, whatever your contract is, you would add the other one, and the device would then have a redundant power supply. And you can see you got an informational message: power supply A removed, power supply A inserted. So I think that's all we need to look at. You can also do the same actually with network modules on the multi-layer switch. So if I go back to physical view, there's some empty slots here. Read the documentation to see what they do and don't do, but you can click on here and the description appears just down here, and you can drag modules without having to power the device off. Again, very handy, but you're probably going to have to pay more for a device that supports this feature. I did check on the servers for Packet Tracer. None of these support hot swappable. I haven't checked the other devices, but you can have a look in your own time. Welcome to our first lab. Little nice easy starter. We've got a class C network address. The host is 1.1. However, we've got a /26-bit mask, so we need to work out how to use our cheat chart here in order to work out which subnet is host .1 in on the 192.168.1 subnet or network. So you may well have worked this out already because it's going to be the first host if you've read any subnetting books, but I wanted to just show you how we go ahead ticking the chart and work out how to get all of this working, so we can apply the question to the chart and then use the chart to get the answer. Now normally for class C our mask is 255.255.255, and obviously each octet here has got 8 binary bits in, so 8 plus 8 plus 8 equals 24, We need to get to 26 as per the question, so we need to add 2 to 24 to get to 26. So all we do is tick down 2 places in the subnets column. That gives us the answer for the last octet. If they asked us, by the way, they might not ask us to write it out in longhand. It was in CIDR. So if we tick down 2 places, say that's step 1, this will be step 2. If we tick down 2, we need to tick across the same amount. That will tell us the increment that our subnets go up in, because we've borrowed 2 bits from the last octet. So I'll just write this down. Increment equals 64. We're allowed, we never used to be, but I won't confuse matters, we are allowed to start off with subnet 0. So it would be 192.168.1.0 is our first subnet, because this is the way the binary mathematics works. Our next one will be .64. Our next one will be 64 plus 64, 128. Our next one will be 128 plus 64. Is 192. This has to be our last subnet because our subnet mask ends in 192. That's the rule, and we got that from just up here. So looks like we've got the answer. Host.1 is in 192.168.1.0 subnet. So we've answered the first question, and that would be what you tick in the exam. Thanks for watching. I'll see you on the next one. Welcome to our next lab. We're looking for host 100, same as our previous lab 192.168.1, but host 100. I want us to just get used to the process, so the first few labs will be easy, and don't worry, they're going to get really hard as we go along. So this is our subnetting cheat chart, the top part, and I just want to get our heads around what's happening behind the scenes, which when we have a subnet mask, it's in binary. The computers don't see the decimal, and they don't see the periods either between the bits. But to make things easier, we're going to write 255.255.255. That is 24 binary bits. We've got 28 for our mask, so we need to add 2. So we'll tick down 2 places to give us the last increment, which is 192. I'll tick across 2 at the top. That tells us the subnet increment, and we're allowed to start off with 0. So we'll go 0, 64, and keep counting up in increments of 64 until we get to the, in fact you could stop at the subnet where you know your host is in, which I will do in the future, but because there's only 4, it's quite easy for me to just write them all out. And remember, we're looking for host 100, and if I write out the next subnet, you'll see I've gone past host 100. So you'll immediately know from this point onwards that host 100 is in subnet 192.168.1.64. Just go back to the question just to double check. Yes, we've got host 100, and I'll just circle this. In the exam you'll have several answers like .32, .8, .60 or whatever, and you'll know, having worked out, it'll only take you a few seconds, that it's in host 64. Alright, thanks for watching. Welcome to our VLS1 example, or VLSM, Variable Length Subnet Masking. So this is about chopping a network down in order to create smaller networks or subnetworks or subnets, which I'm sure you're familiar with. Subnets is just short for subnetworks. So at the moment our boss has given us 172.16/16, and they've basically some growth in the company or a new department or something's happened, and we need 2 networks, and we're not allowed to add any more. Like we can't use 172.20, we can only use what we've got. So at the moment 172.16 is one network, and if you tick down 16 host bits, which is what we've got, you'd find we've got 32,766 hosts. That in and of itself is ridiculous, because you'd never have that many hosts off one interface. So where on our design chart at the bottom, where would we go in order to find out where the two networks are? Well, we've already done it in the design section. We just tick down until we get to the number 2. That's 2 subnets. So we go up and we see which mask we need to apply, and it would be 255.255.128.0 or in CIDR/17. Now you could tick across the top and you could see what your subnets are. So on one side of your router you could apply one subnet mask, and the other subnet and mask. So your first would be 172.16.0.0, and then on the other side of your router it would be 172.16.128.0. So hopefully this is tying in with all the stuff we've covered already, and it's all making sense. So I'll just scroll down to see what our final result is, and there's two interfaces off our router. Welcome to our backups stroke incremental backups lab. I've got a virtual Windows Server 2012 on my virtual box. So this is a new install, so you're going to be asked to do various installs here. I'm going to add roles and features wizard. Server selection, features. We're going to have to enable a few things, unfortunately. But let's scroll down here. It's strange it isn't automatically enabled, but Windows Server Backup. Otherwise we won't be able to do our backups. And click Next. So that was under Server Manager, which is via the home page. Click and install, and it will install that feature. Alright, so installation succeeded. I'll go to Windows now. Click on Administrative Tools. I'll scroll down, you can see Windows Server Backup just here, right at the bottom. Go to a command prompt now. The command also to get to where we need to go, wb admin.msc. So I'll just type that in here, wb-admin.msc, press enter. I'm just trying to show you some of the different ways you can access the backup systems. So we've had no backup configured on this computer, as you can see. Alright, so the settings, Windows Server 2012, storage. And what you need to do is when you've stopped the machine, click on the add new virtual disk, and then you can add a virtual disk and back up to the virtual disk. So just scroll down here now. You'll see that I added a virtual disk in VirtualBox, new simple volume. What I just need to do now is format that. Just use all the defaults here, and then finish, and you see it's quickly formatted. So this will be the place where we would send our backup file. Obviously you wouldn't probably back it up onto your hard drive in the real world, but it just allows us to go through the backup steps. So double click Windows Server Backup. Click Backup Schedule. Next. I'll do a custom backup because I don't want to back everything up. Then we'll add items. and I'll find something that hopefully won't take up too much space. I'll just tick something here just so I can illustrate how it all works. And go to next. So it's mine is program files. Once a day is fine. So where we're going to back up, I think what we'll be able to do now is back up to a volume. Click next and then add, and we'll see the new volume that we created. Click on next. And then finish. We're creating our backup schedule. So then what we can do is close that. Now we can go to up here, configure performance. You can see full backup is the standard configuration. What we need to do is go up and click on custom, and then we can decide what type of backup. We're going to choose incremental. Check your study guide for more information on differential, incremental and full. Click on OK. You can view details anytime you want to see what's been configured. And OK. Alright, so we've come to the end of the lab. Thanks for watching. Welcome to the TFTP lab. You won't often use this because it's insecure, but it's a very handy protocol to use for backing up files on your local network. And it's in the syllabus, obviously, which is why we're covering it now. So we'll drag up a server onto our desktop, a router. I'm going to use a 1841, sorry. Crossover cable, just to be lazy, we're not going to bother with the switch. As per usual, we need to put an IP configuration on either side. I'll do 192.168.1.2 here. So this will be our server that files can be uploaded to, downloaded from, and we could put backups on here. When I say backups, I don't mean server backups, I mean the small to medium-sized files that you will have on your router. So we'll go into enable config and then interface fast0/0, and I'll put an IP address 192.168.1.1 and then our standard subnet mask. As always, no shut it. And then I'll ping across the link. Alright, so that's the IP part taken care of. Now we'll look at our flash memory, which is where our router operating systems are stored. The command is dir for directory flash : and you can see 1841 advanced services is our image, 12.4.15.t1.bin. Bin means a binary file. So you can see the size in bytes, and what we're going to do is download a different image to our router, and you might want to do it because there's security or some other enhancements. So I'll click on TFTP under services. Now the name of the file, it's a real pain. I've written it out by hand because I put it into Notepad because you'd actually need to name the file exactly, and you can't copy and paste the file name from the server list. It'd be nice if you could do it, but you can't. So you need to get the file name exactly right. There's no intelligence built in, and you can't navigate through directories with TFTP. So the command is copy TFTP : flash : press enter if you want there, just to make it easier, and put the IP address of the remote host and press enter. Source file name you can paste now, unless you've got a really good memory. So this is what, 12.314.t7. press enter and enter. That copied over in just a split second. As you can see, each colon is a part of the file that's been transferred. If there's a dot, it means it failed. dir flash is the command we want to use again, and we can see we now have 2 files in our flash memory. Now you could upload as well if you wanted, so have a play with the lab, have some fun, but we've come to the end and proved off the TFTP. Thanks for watching. Welcome to our lab on VLANs, Virtual Local Area Networks. You can pause the video at this part just to look through the requirements if you don't have the book. We're going to separate 4 PCs into 2 VLANs, VLAN 10 and VLAN 20. Obviously, having read your notes, you'll know that VLANs need to be in different subnets or networks. They can't be in the same one. So I'll choose a switch and drag that to the canvas, and then we'll need 4 PCs. They could plug into any ports because you can have any ports into any VLANs, but I thought I'd keep it simple. I'm quite a visual person, so VLAN on the 2 left PCs and another VLAN on the 2 right PCs. Obviously straight through cables, PC to switch, fast Ethernet 1, and then we'll go 2 and then 3 and 4 I think. So to 2. And then 3 and 4. Just for my own smoking, I can click on show port labels in the workspace. You set this up as you wish. Obviously you'll want to see different things and not see other things, but sometimes it's handy to see which ports are where. Now we need to go through the laborious task of configuring IP addresses on each device. I'll do 192.168.10.1. I'll do this numbering because this will be VLAN 10, so it's just easier for us to remember if we've got 192.168.10. And I'll do the same down here, 10.2 this time. And the subnet mask will fill for us. Now 192.168.20.1, so this is a different network to the first 2, and then be 20.2 down here. Alright, so we need to go to the switch. The PCs, there'll be no further configuration on these. You can colorize the canvas if you so wish. I'm just trying to find my way around here. It's handy. Again, if you're a visual person, which is what I am, you can choose different colors and select fill colors. Especially if you're sending this diagram over to somebody else to troubleshoot, or you're doing it as a challenge lab for them, it's quite nice to do this sort of stuff. So it's a little bit fiddly. You kind of need to pick the color before you do the fill. So it looks like one side I didn't do a color, and then the other side I did. Finally worked out to do it for the second side. So I'll redo this box on the left. So we've got VLAN 10 on our left, 20 on our right. You can add text as well if you so wish, add lines and notes. For a simple topology you probably wouldn't bother, but for something like this it's handy for us to all see what's going on and where it's going on. So VLAN 20 on the right. 192.168.20 network. Obviously you'd have more than 2 hosts either side. So we'll go to our switch and we'll just resize the command line here. EN for enable mode, and then we'll need to go to CompTIA for configuration mode. VLAN 10. This actually creates VLAN 10 for us on Cisco switches. And then I'll go to interface, fast 0/1, switch port mode access, which is saying you are a layer 2 interface. And then I need to say switch port access VLAN 10. I'm putting you into VLAN 10. So you're a layer 2 interface and you're in VLAN 10. And I'm going to do the same for fast Ethernet 0/2. Same two commands. You could actually do this with an interface range command, which we'll cover in another lab. VLAN 20. Interface fast 0/3, switch port mode access, and now you can see me shortening all the commands, which this the configuration, the iOS lets you do that. So we've got our 3 and 4 interfaces put into switch port access VLAN 20. Now these two devices should be able to communicate with each other. Show VLAN brief. You can see all the interfaces in the default VLAN, and we should have 2 in 10 and 2 in 20. The default name is just VLAN and then the VLAN name. You can rename the VLANs if you so wish. If you've got HR or some other team. Alright, so we've got our IP addresses. We'll go to our command line, our command prompt, and I'll ping 192.168.10.2, which is the other neighbor. Now, without a layer 3 device, a router, you won't be able to ping the other network. You need to add some routing capacity, which this lab isn't about. And you can see that ping's failed. And you can do the same on the other two PCs if you want to test pinging between them. But we've proved off the lab. Thanks for watching. Welcome to our lab, Manage Printers and Printing. In this lab we'll learn how about managing print queues and jobs using CUPS and the LPD compatibility interface. To eliminate variability around printer hardware and all the problems it brings, and believe me it will do if you try and connect to your home printer, this lab will assume printing to a PDF file instead, which will make our life a lot easier. If you'd like to print to a real printer, you can ignore this step, but the lab will presume that we're going to be doing some PDF printing. So sudo apt install printer driver CUPS PDF. Verify with LPS stat -T, and you should see the device for our PDF printer. It should be auto-detected. If not, oh sorry, that's for the real printer, should be auto-detected. If not, easier to print to PDF. Finally, check where your file should be printed with the following command. You may choose something like Home PDF as a directory where your printed files will end up. You can change this if you like. If you do, finalize with the following command. Alright, so you can probably guess what happens next. We'll echo hello world to the line printer, locate the file in the directory we identified above. It may have an odd name, by the way, for example, something like this and then .pdf. We'll open it in a PDF viewer or web browser. Can't remember if I've actually got a PDF viewer, on this device, but hopefully my browser will support PDFs. We'll check in a moment. So let's go ahead to the next part of the lab. So I'll have a look now. The files, PDF folder has been created. Here's the job. Now, let's see if this works. Open with document viewer. A bit small here. Hello world. Quite tiny. Let's see, get it up here, something like that. There we go. Hello world. Nothing exciting. Okay, so we found the nondescript PDF file with our text printed in the top left corner. If we didn't change anything, it'll be under PDF. Now some helpful commands. We'll issue this command here. So I type some gibberish, Control C to cancel. T flag also includes a file name after printing. LPQ, previous command should tell you the job number of the queued job. LPRM, job number 2. Alright, so we cancelled the job if we did it quick enough. There's a timeout, but it will show up as completed via lpstat-w completed. Welcome to our lab about wireless network interface cards. We're going to install a wireless network card onto a laptop. Easiest way to do this is with Packet Tracer. So we'll have a laptop here, a laptop over here, and this is a wireless access point. There's going to be no configuration on this. All it's going to do is basically enable a wireless connection between the two devices. So we'll drag two laptops and an access point onto the canvas. So we'll go over to Cisco Packet Tracer. End devices, there's a laptop here, and I'll put one over here. Network devices, whatever you hover over appears. There's a title up here. So wireless devices, it's APPT, access point for Packet Tracer. And then the next part of the lab is we need to drag a wireless card onto the laptop plate here. Now if you click on the laptop, and zoom in, you'll see there's a card here. There's only one slot on this laptop. What you can do is drag it away. Oops, power off the laptop. Drag it over to the far left here, and then down here. You can go up here, actually there's a wireless card I think somewhere, a Linksys, but I'll just drag this one over here. And then make sure you turn the laptop back on. Now while I'm here, I might as well put the IP address in. So I don't want DHCP because there's no DHCP server on this network. So I'll manually add the IP. So that's enough for this side. Go to the other side and I'll do the same. Now you can see I've enabled the laptop, so there's a link. This shows a wireless link. So I'll zoom in, power off, drag on, power on, desktop, static, and it's .2 address. And then all things being equal, if I go back here, you should see a connection is now working. So I'll go to the right hand laptop. So I'm on the right hand laptop and I want to ping .1. And I've got a reply from my 4 ping packets. I've got 4 replies here. So pretty simple lab. It was just installing. We're going to be doing some more advanced wireless configuration as we go through the later labs. Welcome to our lab on wireless encryption. This is the same as the previous lab. So inserting wireless network cards. So I'm going to skip past all of this stuff here, and we're going to jump through to the configuration for the access point. So task 4, configure WPA2 on the access point, and we're going to set the passphrase. So I'll click on the access point. Now this is quite a simple device. The wireless LAN controller, the WLC, that Cisco offer is more advanced, but we can go to the wireless interface here. You can see it's disabled, which is why the last lab worked. WEP is not of no use. WPA, we're going to use WPA2 with a passphrase. 101labs.net. You can choose AES or TKIP. I'll leave it as AES. You don't need to press anything else. There's no submit button or change. You'll see the connection lines between the laptop and the access points have now disappeared. So what I'll need to do is I'll go to the wireless interface and I'll basically choose the same settings, WPA2 PSK. I'll just put in the passphrase 101labs.net, leave it as AES, and you can see that connection appeared. And the connection appeared. And if you want, you can ping now between the 2 devices as we did in the last lab. So 192.168.1.2 to 192.168.1.1. Welcome to installing a wireless LAN controller, WLC lab. It's quite a hard on this, so don't worry too much if you can't get it right first time. Just come back to it later. Absolutely fine. It's just a little bit tricky. On devices, I've clicked on wireless devices. I drag up a WLC. There's a few different ones there, so just make sure you pick the one I chose, and then 2 LAPs, lightweight access points. Cisco have got some of the models available there, which just has different configurations. They bought Linksys some time ago. So got our lightweight access points here. We have to drag the power physically into the port, otherwise nothing much happens there. So just drag that up, and then that will that will power them up, and we can do some alterations later to those. We'll change the display names. I always recommend you do this on the display names. They're just not very user friendly until you go into the display names and just something that's going to be more memorable to you. And you do this in your office as well when you're installing wireless points. When you're doing a site survey, you would hopefully make it something more meaningful for troubleshooting and maybe for the users, or certainly the SSID, so the users could make more sense of it. Alright, so there's quite a few pages on this particular lab. If you've got the book, we're going to connect our devices up, Ethernet cables. I don't think we're configuring the switch in this lab, we're just leaving it as is, so don't worry about which interfaces you're connecting to on the switch. And I'll connect to the gigabit Ethernet on the wireless LAN controller there on the right. You have to wait for the interfaces to come up, which can take a 20-30 seconds roughly. And they obviously want you to understand that this would happen in real life and not panic if your interfaces don't suddenly come to life. So I've clicked on the wireless LAN controller, config, and then management, and here we can use the graphical interface to configure the management IP address 192.168.1.5. Default gateway I'll just check as 192.168.1.1. And same for the DNS server. We haven't actually added these onto the topology. It isn't really part of what we're trying to achieve with this lab. Alright, so we need to do some configurations to create our access points. Or actually, I had no security, but the lab doesn't work with no security. Again, this is just something with Packet Tracer. I just couldn't get it to work, although it should. Obviously, AP groups, I'm going to create a name of, just get the window moved here. Wireless LANs AP1, sorry, first, and then AP1. I didn't put any spaces in there. WEP, just make a note of what I'm putting here. This is AP1 0 to 9. The reason is I have a set of numbers for the other access points, which is in a different order. So I've got wireless, I've got WEP configured. I've got the WEP key, and I've clicked on save. Now I'm going to create WEP access point 2, sorry. SSID is AP2, and this time it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Just remember that, because you'll have to put the WEP key in when you're getting your devices connected. Just didn't click on save for the last one, so I'll just add it again, sorry. All the same stuff there, WEP, and then 0 to 9. Save, and then I should have on the drop down box there my AP2 and AP1 I can choose from, and make some changes if I so wish. Alright, check under AP groups that both are present. So we'll go back to our AP groups tag here, and you can see AP1 and AP2 are there. So we'll come back to this in a bit. We need to configure DHCP on the wireless LAN controller. So this will allocate IP addresses to our hosts, our wireless hosts that are joining through the access points. Pool name 101 labs, default gateway 192.168.1.1. We'll add our start IP address. The tab key doesn't work annoyingly, so we have to use our mouse. Start off with 1.10. I'll have 100 users available. You can change all this later on when you come to do some more config. You must put the wireless LAN controller address in. I forgot to do this when I was first configuring the lab, and yeah, it caused me all sorts of problems. Turn on DHCP. A small matter, but we need to click that little on radio button. Okay, so that all looks okay. I'll refer back to the book if you've got it for the screen print, or you can pause the video. Alright, so AP1 here. I'm just going to edit the mode, DHCP and ARP. So we did this in earlier labs. So you can see simulation mode as to what's happening. Hopefully it should connect to the wireless LAN controller. Still got more configuration to do, but what we want is some layer 2 packets to hit the wireless LAN controller, so it can actually register them, and then we can do more configuration. As I've written here, this could take ages. This is a real problem. I thought there was actually a fault, but it just takes a long time for the devices to be recognized by the wireless LAN controller. And yes, I'll just go back. I forgot the subnet mask for the DHCP. And even me, with all these years of experience, I make mistakes sometimes too. Click on the pool and then add the subnet mask. I'm sure you saw I missed this earlier when I was configuring it. But there we go. So that'll be a lot better now. You can force some packets to traverse the network by clicking static and then back on DHCP. And boom, I fixed my mistake, so that worked. That worked well. Okay, you can hover over the access points and see that the addresses have been allocated, and just hover over here again. You can see it's connected to the wireless access point 192.168.1.5, and they're providing wireless LANs are AP1 and 2. Alright, so if we go back to AP groups now, we can see that we've got a default group and we want to create a new group. So the group name will be AP1 for the first group, and I'll tick AP1 and AP1 and save. That will belong to group 1. Then I'll do a new group which is going to be AP2, and I'll tick AP group 2. Do some more reading around the Cisco WEPs if you want to learn more about how all of this is working and what happens. Alright, and you can see now each different access point, if you hover over it, is in its own access point group. So what we need to do now is add our wireless devices. I've tried with smartphones again, they just didn't seem to work well. Should have worked, so I'm going to drag up a smart wireless tablet instead. And this seems to these seem to work better. So let's get the SSID in. AP1 WEP key 0 1 2 3 4 5 6 7 8 9. And I'm going to force a DHCP packet by just clicking static and then DHCP. It probably would have worked anyway, but it just makes it a bit quicker, I found in my experience. Click on desktop and then config wireless AP2. I'm going to choose. You normally see this on a display of available wireless networks. 1 up to 0, static, and then back to DHCP, and poof, an address should appear. He says, there we go, 1.15. So that's from our pool. Alright, so all our devices are connected. I'll go to the simulation mode, click on play, and you'll see device packets leaving our devices and traversing the network when you click on play. So everything looks like it's working fine. We've proved off the lab here, and we've connected to our wireless LAN controller. It's the end of the lab. Thanks for watching. Welcome to our lab on installing a voice endpoint, a voice over IP. This is just a little taster lab. Obviously things wouldn't be this simple in the real world. A router, a switch and a couple of IP phones as provided by Packet Tracer. We can click on end devices and drag up, I'll drag up a 2811 and go down to switches and the Cisco switch, that's a 2960. And then click on devices and an IP phone to the left and one to the right. Now you'd obviously have PCs and all sorts connected to this topology, but I just want to keep it simple just to illustrate the point. Fast Ethernet between the PC and the switch, and then I'll connect Ethernet to the switch, to the phone and to the other phone. So Fast Ethernet 2 and then 3. You can see the phones have got ports to connect your PC to, but we won't be doing that for this lab. Alright, I've got the actual lab from the book there, just to remind myself what we need to do. You have to drag the power to the port on the phone, otherwise nothing will work. I'm not quite sure why they get you to do that. Maybe, I don't think in the real world you'd forget to plug it in, but maybe somebody somewhere has. So the router, we need a brief configuration. I'll just click on the router there and just drag the window to a nice size. Okay, we want no for initial configuration, enable and then CompTIA. Interface fast 0/0. We'll add an IP address to this interface, 192.168.10.1 with 24-bit mask, and then no shut it, as we always have to do. And let's look at the requirement again. We've got configuration for DHCP. We need to add on to the switch as well, add the router, so it's adding allocating IP addresses. IP DHCP pool voice, network 192.168.10.0, 255.255.255.0. Press enter. Default router, we'll allocate that to 192.168.10.1. So that's us, our router. Now we need to add a particular option in order to allow the voice to work. Option 150, IP 192.168.10.1. Hopefully covered in whatever study guides, otherwise you can do some more research on option 150 on Google. We need to exclude the IP address belonging to ourselves, so the router doesn't try to allocate that to a host, because that will cause a lot of problems. Alright, I explain more in the book if you've got a copy of that also. Alright, configure the switch, the ports here. So we'll go to the command line on the switch. Okay, enable CompTIA interface range, which will make things a little bit easier for us. F0/125. I know we haven't got 5 interfaces working, but I'll put the first 5 in case we added another phone later. Switch port mode access. Switch port voice VLAN 1. So everything for the voice will be going through VLAN 1. You probably wouldn't do this in the real world, as I've said. We're just doing this to in practice configuring the voice endpoints. Alright, so there's a voice configuration required for the router in order for the voice to work. I don't get too worried about this, by the way, because the voice course could take weeks to study for and pass if you're doing Cisco or other devices, other vendors. telephony service, the max dialer network will be 10. Max electronic phones is 10. I've tried with a smaller number, by the way, and it just didn't work, so this is why I've chosen 10 as the number. IP source address 192.168.10.0, port 2000. We'll auto assign 4 to 6. Don't worry too much about the commands, this is just the way Cisco do it. Other vendors may well get you to do a GUI or different commands. So these are the possible numbers that are going to be assigned. The next thing we need to do is add the dialer number, directory number, sorry, to our phones. So we've got a maximum directory number of 10, and then we're going to actually assign directory numbers. So the first one, DN1, the number is 54001. The ePhone 2, okay, ePhone DN2, dialer number is 54002. So this is the extension number we would call in order to get this IP telephone to ring. Alright, so you can see the various informational messages popping up on your screen. Devices registered. Okay, you can hover your mouse over and you can see the settings without clicking anything. Just hover over the devices and you see the gateway, the line number, and the address for the VLAN there. Again, you can see the extension numbers being allocated. So click on the GUI, just make it a bit bigger, and the same on the other side. So we're going to actually ring one device, and you can see on the top there, if you can, 54002 is shown on the top on the digital display. Click on the headset, and it will move off the handset. Sorry. To call the number 54002, and you can see the other side is ringing. You can press on it or click on it to answer the phone. Well, I'm just going to click on the left one just to hang the call up, so we've proved the lab off. Welcome to our lab on modem connections. This is for DSL. The syllabus mentions cable modems also. Obviously check because they can change the syllabus whenever they want. So cable DSL modem configuration. What we'll do is we'll pull up a DSL modem in Packet Tracer. If you have modems at home, everyone's got a different environment, so a graphical interface. They don't test you on certain vendors in the exam, as I've said several times. So I'll have a PC, DSL modem. We need to pull up a specific type of cloud service in Packet Tracer and then over to a router. I've used a 1941. I tried with other routers and looking at the operating system, it didn't support DHCP, and I'm going to add some DHCP, so basically the router can act as a DHCP server and send an IP address when the PC requests one. So let's pull all this up in Packet Tracer now. So end devices, you could use a laptop if you want. So there's the PC, the DSL modem is next. I'm going to find, here we go, so under network devices and then the cloud, DSL modem, there's obviously cable modem there. And then PT Cloud, I think it is. Let me just check the diagram. Cloud PT. Here, and then the model of router I used was a 1941. If you don't have a 1941, just find one with an Ethernet interface. I think I tried a 2911 and it didn't support the commands that we need for DHCP. So you can click on the connection arrow. You can actually use the automatically choose connection type. Here you can connect your port here to here. Actually, I do need to go into the... Oh no, it's not on here, sorry. There's no configuration you'll actually be doing on this. There's no GUI, no command line interface. But on the cloud, so this would be your internet service provider. For DSL, we'll need to connect a couple of modem ports to our Ethernet interface. We've only got one here. If you look at the physical, there's just one Ethernet interface somewhere. Just here. There's other modules you can drag across, but we're not going to do that for this lab. So scroll down through the lab. We need to go to, I think this part first actually, DSL, and then connect the Ethernet to modem 4 and 5 ports. So modem 4 to Ethernet 6, add. Modem 5 port to Ethernet 6, add. And then we'll go to Ethernet 6 and just make sure DSL is ticked. We're not doing a cable connection for this lab. So it's all on there. So this is basically just forwarding traffic, no IP configuration. On the router, we need to set an IP address because this is our internet service provider. So you'll have an IP address on your Ethernet port. This is obviously a gigabit Ethernet port. I'll try and move this around so you can see. So fast Ethernet to the DSL, DSL to modem 4, Ethernet 6 to the gigabit Ethernet. If you hover over the router, you'll see it's out of frame here because of the screen resolution. You'll see there's no IP addresses configured. We've done this before in earlier labs, but you can just follow along with me. So we want no, press return, enable. CompTIA is short for configure terminal. I want interface gigabit 0/0 because this router has one, as you can see from the packet tracer canvas. No shut down will bring the connection up between the two devices. Now the only other problem we have now to overcome is to send IP information. Configure the DHCP pool so it can allocate IP information. I'll just change the pool name to DSL, sorry. So IP DHCP pool, DSL, and then we configure a network, which is our pool of addresses. And then we need to exclude an address so it doesn't try and allocate it. You'll always exclude the interface address and any other addresses for servers. There are other commands you can add, but we don't need to do it for this lab. I'll exit and then IP DHCP. I'll type EX and then hit the tab key, which fills in the rest for me. Excluded address. I'll exclude my Ethernet interface. And that's all I need to do for this part of the lab. And then finally, we're going to go to our PC and we're going to say, obtain the address via DHCP, which I'm guessing this is what you have at work and on your home equipment. So click on this, config, So at the moment it's got static here. You can also do it over here if you wish, doesn't really matter. I'll click on DHCP, it'll send a request to the router, and then you should, in a short order of time, get an IP address. Well, I can see it hasn't allocated the IP address, so I just need to troubleshoot. I went back to the, don't know why, the cloud, and it didn't add my 2 modems. I don't know why it didn't do that. I'm pretty sure you saw me do it. I might have done it under cable. No, I didn't do it under cable. So I'll try again anyway. That was just a little bit strange. Oh, you can see it's reallocated the IP address now. So 192.168.1.2. If you wish, you can go to a command prompt and ping the router. And you can see we've got a reply. Welcome to our Wi-Fi Analyzer lab. We're going to use netspot.app.com. It's a free to download Wi-Fi Analyzer. You can use it for troubleshooting and quite a few other things. I've got a free version. You can see they're the free edition, and I've downloaded it here. I don't have neighbours too near, so if you were using this, it'd be ideal if you had this on your laptop and you were in a shopping centre or in quite a built-up area, and you can see your the SSID here, the graph, the signal strength, percentage of the current signal, and then the minimum, maximum, obviously over a period of time, the average value, level of the current signal. So this is very good for you analysing the strength, weaknesses of a Wi-Fi signal wherever you are. You could do this as part of an assessment if you're going in to do some contracting at a business, the vendor type and also the security type. Hackers would use this type of tool to test for vulnerabilities and security types. Now you can double click and you can get more information, the graphs over the 5, 30 and 60 minutes or so. And again, you can break down all of the signal over a period of time. Obviously, the longer you run it, the more information you get and the more accurate it is. You can look at the channels in use also. So this is one of the syllabus subjects. I recommend you just download it and have a play. There's a survey option as well. I can't really see much from where I am, unfortunately, because there's only my router available. But have a play and just get familiar with it because it's, as I said, one of the syllabus subjects. So pretty much come to the end. That's all there is to see. I'll see you on the next lab. Welcome to our lab on Bluetooth. There's a whole bunch of Bluetooth connections available in Packet Tracer. For example, if I get a PC here, where is it? So somewhere in here will be the ability to set up Bluetooth. I won't use that. What I thought we might do instead, if I just delete that, is we'll go through a lab and do a home setup, but it's down to you to use the other Bluetooth features. For Bluetooth, I think Packet Tracer is the easiest. I haven't looked online for any of the tools. So we'll get a couple of devices, we'll drag up a Bluetooth home speaker under the home devices and the portable music player. Under home, and then if I hover over Bluetooth speaker, you don't want this one here, which is a home speaker. And if you hover over this device here, it says portable music player. So I'll drag that up as well. And then we go, what we want to do is go into the config of both and turn off fast Ethernet. So I'll just click on it as usual, config. Oh, by the way, it's worth reading and the features here. You can do that in your own time. So I'll go to fast Ethernet and I'll turn it off. And then the other device here, just the same thing basically. Fast Ethernet and just turn it off. On the portable music player, go to Bluetooth, discover, and then click on the found device and then pair. Just check it's the right one. So Bluetooth, so nothing's here at the moment. We'll click on discover. Now we've found IoT 0. Now what you can do if you prefer is rename this device. I'm not sure if there's anywhere else. Oh yeah, here. You don't want to change the serial number. So I'll just I'll hit discover again. Yeah, and it says speaker. Not that it matters, but if you've got more than one device, you know which one's which. So it's not very clear really, but what you actually do need to do is click on it. You don't normally do this in Packet Tracer, but in this instance, click on the found device and then click on pair. Pair connected. So what you'll now see is a line connecting the two devices. Now you want to create some sort of noise. I'm not sure if I've got system sound turned on for my recording software, but what you'll do is you'll see a message appear on here, or the icon will change. So you hold down the Alt key, left mouse click, and you'll see this has changed here. And I'm not sure if you can hear, there's a white noise generated, but if you don't have sound for any reason, you'll see the speaker pretend sound waves coming out. Alright, so do try other devices. You can set up a whole home using Bluetooth, and obviously there's PCs as well. I haven't tried a PC to PC connection, etc., but it's something you can play with. Welcome to our lab on the Internet of Things thermostat, which is in the syllabus for the A+. So obviously we need to address it in our lab. So we're going to use Packet Tracer as we do for many of these labs because it actually offers Internet of Things devices. So we can connect our smartphone and do our controlling. Say we're out at work and we want to have a cold house or a warm house when we get home, or something else configured, we can do this via our smart device. So first things first, we'll get Packet Tracer opened, we'll drag the devices onto the desktop, and then we'll start our configurations. So under Home, there's a fan. There's also a thermostat. You can find these under maybe Smart City as well, and Industrial. Same devices though. We need a thermostat. The other thing we need is a end device. It says smart device, but when you drag it up, it actually says smartphone. And then the other thing we'll need is a gateway. Yeah, the home gateway is under wireless devices just here. Now, you'll find out later, it says fan IoT 0 and thermostat IoT 1. Maybe would be a good idea to change the name of the device. You can call it anything with fan in the name. And the thermostat, same thing. Just because when we do a configuration, IoT 0 and IoT 1 won't mean much. You don't have to do it because in the actual written lab I didn't do it, but I just learned the hard way, unfortunately. So we got these devices. Now on the fan is the first thing we'll configure. We need to go to Advanced, IO config, and we need to change the adapter to the Packet Tracer IoT Network Module 1W. Under config, we need to set the server to connect to the home gateway, which is our wireless device. So wireless 0, SSID says home gateway, which is exactly what we want. So what I did was I clicked on advanced again, config, IoT server, I clicked on home gateway. And we do the same thing for our thermostat. So you can see the two devices are now connected to our home gateway. The other thing to note is the fan. Let's try and find it. Maybe it's under advanced. There. So these are the icons. It's this icon shows that it's off. This icon is low, and this icon would be high. I only say that because the idea of the lab is we configure it so it actually goes on to low setting. So at the moment it's shown as off. So same step for the thermostats. Now for the smartphone, we'll set the SSID. We need to match the letters and the upper and lowercase letters, so capital H and capital G for gateway. So the SSID, press enter, and that should connect, there we go, to the home gateway. Now we need to go on to our Internet of Things. So from the smartphone, we can now connect to the home gateway, and we're going to set some parameters that will set the fan to activate when a certain temperature is reached. So click on Devices and then the IoT Monitor icon. So IoT Monitor. It's auto filled in for you, but basically this would be the server IP address for the IoT and our username and password. So all we're going to do is click on Login. Now you can see we've got home fan here, and this is why it's better to do a name instead of IoT 0 and IoT 1. If you didn't do it, it doesn't matter, you can go back and do it later. And you click on the bar and you can see whatever settings that are on by default. Now we're going to need to set some conditions here. You could manually obviously turn your fan on and off, but we wanted to do it with the temperature settings. So we'll do a setting, conditions. We'll activate the fan if the temperature exceeds 10 degrees Celsius. It would help if you rename the devices, which we did. You can see from the steps below, the start by clicking on conditions and then set the rule. We're going to call it fan on. So conditions, add a rule, we'll call it fan-on. If the home thermostat temperature is equal to, let me just check, sorry. If it's greater than 10 degrees, I'm glad I checked now. So if it's, these are obviously the parameters, greater than, less than. So if it reaches this, we need to set an action. So then we're going to set the home fan to status low. Obviously there's three settings, low, high, off. So we'll have low. We'll click OK. Now we'll do a fan off because we don't want it to stay on all day. Fan off. If the thermostat temperature is greater than or equal to, sorry, let me check. is less than or equal to, 10 degrees, then we'll set it to off. So set the fan to status off. We'll click on OK. We can now hit the home text and to turn the thermostat onto heating. Packet trace is very limited, so let me go back to my smartphone. So we'll click on home. Now the thermostat is currently turned off. What we're going to do is turn it onto heating. Now this is not very advanced, so it's, for example, set to 3 degrees here or 2.9. There's no way to control this because it's all been done artificially. There's no actual thermometer here. So what I'll do is I'll set it to heating. It should turn some heating on. I wouldn't worry too much about what the outputs are. What we're looking to see is that the home fan gets activated. Alright, so in my packet tracer the fan won't go on. Unfortunately, it's a really annoying feature. The thermostat drops temperature. As you monitor it, you can see it going down. So a bit frustrating. On your smart device you can see the status, it's onto heating but it's at 0. But if you're quick enough and if you can find a way around it, you should see the fan turn into on. The configurations are all correct, it's just a little bit limited at the moment, and the fan should spin. If you want, you can play with the settings and have it come on at 1 degree, and then you might be able to catch the temperature quickly enough before it goes back to 0. Welcome to our lab. We're looking at boot methods for Windows. In the syllabus, obviously this can change, so please check. You can boot from CDs, external drives, your network boot, internal drives. You could have more than one, obviously. Partitions. There's a whole bunch of options, so all we can do is just cover a little bit of the basics. And bear in mind that each version of Windows has a different way of getting to the menu systems, and they've got control panels and settings, etc. So you should be familiar with all of them. I'm going to use Windows 10 because it's the latest version. So I'll just use a single Windows 10 machine. Just note that I'm using a virtual machine, so it's not going to work in the same way as a live machine. If you've got a spare machine at home, you can certainly follow these steps, but just probably don't make any changes because you could render your machine unusable if you do the wrong thing. So it's always handy to have just an old PC. You can buy a spare one off eBay that's really cheap and just put your operating system on it. So we're going to go to settings, update and recovery, and then recovery advanced startup. Obviously more than one way of getting here. We just need to scroll down. So to update and security, this is how you do it on Windows 10. There's a recovery option here, and you can see the options here change. We're looking for the advanced startup. Startup from a device or disk such as USB drive or DVD. Change Windows startup settings or restore Windows from a system image. So click on Restart now. You'll want to go to Troubleshoot, and then you'll go to Advanced Options here. Now here's where we get to the problem, because you're going to see different options if you're using a virtual machine. So this image belongs to windowscentral.com, and they've grabbed an image, UEFI firmware settings. You would click on that, and then you'll have an option to reboot. So if I just click on something here, you'll have a restart option once you go down here. And then the next thing that would happen, so this is from groovypost.com. Obviously I can't record while I'm in BIOS, and you're not going to have the BIOS option in VirtualBox, so a little bit stuck there. So you'll have a different menu depending on who's manufactured your BIOS, but you'll have a boot menu, and then it basically you've got a limited GUI experience where you can use plus or minus keys and function keys. So it says keys used to view or configure devices. The plus or minus moves the device up or down. So what you've got to basically do is plus or minus when you're on here, and you can move it. For example, if you wanted the hard drive at the top or the CD-ROM drive at the top, or vice versa. And then at the bottom you will see a whatever key you need to press to save and exit. So for here it would be F10. Your machine would boot as normal then, and it would boot in the order that you've set it. Now if you've got a machine at home and you just wanted to try it out and say tell it to boot from the CD-ROM drive even though it's empty, it would boot there, and then if it can't boot it would move on to the hard drive looking for a bootable image. Alright, so like I said, we're a bit limited, and I can't record off another machine in BIOS because it doesn't run the recording software obviously when it's in that mode. Welcome to the lab on Boot the System, Boot Sequence. You probably won't want to do this lab if you actually have a Linux machine at home. Definitely don't do it at work, because we're affecting the boot process. And if anything goes wrong, if you've just got a virtual machine like I have here, then it won't really matter. You could just install another machine. I think I've got one down here that I run GNS3 off. So I'll go through the lab. You can either follow along with me if you've got a virtual machine, or just watch and look at what we do. I'll just move this here. So a little bit of preamble. In this lab you'll practice issuing commands to the bootloader and gain a deeper understanding of the Linux boot process from BIOS to UEFI to completion. So this is a bit tricky now, because what you have to do really to start with is enter this command but type it to prevent any issues. I actually tried to, I copied all of this, pasted it into Notepad, and still couldn't get it to work. So eventually, basically all in one line, I entered this command, and then it finally worked. So what I'll do is I'll add this to the resources and also under the video if you're a member, and then you can try it for yourself. So this is the command. I'll just copy it. Obviously please look through it yourself so you can see all the parameters. I may change this because what I found when I actually, if you look here, timeout 10 / and then a backslash, when it's actually in in Windows, sorry, it's missing one of the characters. So I'll try and get this fixed for when the book's ready to print, but otherwise I will put it underneath the lab and in the resources section for you. So anyway, I've copied it, and I'll just go to get my screen all set up. So easiest thing for me to do now would be paste. So you can see it's entered the carriage returns here, and I've got 3 separate commands referencing grub, and then it's prompted me for my password, which I'll enter here, and then the other command you've been asked to enter is sudo update -grub. So we go here. So what you're doing here is modifying the grub bootloader so that you can see the boot menu and various logs. Now the next step is if you run dmesg pipe grep ATA, and we're looking for a line indicating your hard disk beginning with something like ATA 2.0 or ATA 3.0, and then you'll make a note of this number for later. Now, I'm using a virtual machine, so if I remember rightly, when I went through this lab first time, I saw both. dmesg pipe grep ATA. So yeah, I've got ATA 2.003.00. I actually, I don't have it here. Earlier on I put one of these numbers in and it didn't actually give me the result that I was looking for, so I'll try again this time round. So you make a note of whichever number you have, ATA 2.00 or 3.00. The next step is saying reboot your computer or virtual machine. Upon boot, you should be greeted with a grub menu. Hit C to enter the grub prompt, and here you can run various bootloader commands. I won't blame you, to be honest, if you just want to watch the video through before you have a go, or just stick with watching the video because you'll just need the information rather than actually configuring these commands. So I'll go to restart. Sorry, the screen isn't the right size, so I'm not getting the prompt. Alright, so I struggled because of the size of the screen, but I just basically clicked on the power button and then restarted the machine. And if you go back to the lab here, you've been greeted with the grub menu. I just pressed C at the prompt that you just saw. Here you can run various bootloader commands. You can use ls to explore partitions. The format looks a bit different, for example HD0 MS-DOS1. There are also commands like lsmod, lspci and parttool. Do these look familiar? And then run help for a full list. So you can look through all the various commands here. So I will let you carry on and do that. And if you want to go to the boot menu, you can press escape. And then you can press E to enter a screen where you can modify the boot commands. So this is where we're looking, and the mouse won't work for me. We're looking for a line that starts with a Linux, which I can see here. So etc, etc, etc. And then I've scrolled over here to the end of this line. So just at the end here, you've been prompted to add a number in the lab. So hit an E to enter the screen. At the end of that line, append libata dot force equals, and then in here the number, where the number is the number you notice, which is 3.00. Then you can press Control and X to boot your computer. Now you can see I had two values, so I can't tell you what's going to happen, but you may. The idea behind the lab is that you'll see it looks like the device is booting, but it actually doesn't boot. So if we go back here, this is what should happen, and again, we're not sure what results we're going to get. So after a few minutes, you may notice that something has gone wrong. You've disabled your primary hard disk, causing Linux to be unable to boot. It may have looked like it was booting. That's because the next step of the boot process is to load the initial RAM disk prior to loading the kernel. The init RD was successful, whereas the kernel step failed. This is why you should have ended up at a prompt as here. Now, I'm not sure it's going to happen. If it works for you, you can reboot, and then if you'd like to undo the changes, you just run the following command here. So I'm going to hit Control and X. And then we'll see what happens. And again, you may get different results to me. Looks like mine may well be booting correctly. I could go through it again and add the command 3.00 because that may be the virtual hard drive that this machine is booting from. But I will let you do that. You can read the notes through for yourself if you so wish. Just important that you know how to do this and what part of the booting process this is actually pertaining to. We're going to look at partitioning our hard drive in Windows. Great way to organize your files, folders and applications. Obviously most people will be just buying, now they're so cheap, solid state extra internal drive, or you could just use a pluggable USB hard drive or whatever. But because it's in the syllabus, we just need a single PC. I'm using a virtual machine. Note you may have just some differences from a live machine to a virtual machine, depending on how you've actually created the machine in VirtualBox, if you're using VirtualBox. A few ways to get to where we want to go. The way I'll do, please check for other ways, is I'll type disk management into the search bar in Windows, so just down here. Now it won't say disk management up here, it will say create and format hard disk partitions, and this is via your control panel. So I'll click on that. Now what you'll see is different for me as it will be for you. Obviously, I'll explain this only just in case there's some beginners watching. I've set, for another lab, I set up a second hard disk inside my virtual machine. So inside the Oracle, I can't remember, settings, storage, yeah, I installed another virtual disk. So when I come to actually use my machine, it looks like there's another hard disk installed, which is what I wanted. Now I actually went through this lab earlier, so I've even got this extra partition here because I was just practicing some of these steps. So back to the lab, create your hard disk partitions and you'll have something appear. You can see this was before I made my change, this is after. You'll then need to create some allocated space before you can create the partition. Choose the shrink volume option. So I'll use this one here maybe, shrink volume. So now it's saying this is the amount of total space, the size of available shrink space in megabytes, total size after shrink. So you can change this value if you wish. So say you changed it to 100. I'll click on next. So now I've got this unallocated section here of my disk. I'll just follow the lab so we can all stay together. Right click in the unallocated space and select new simple volume. And then there's like a bit of a wizard that we'll go through. So new simple volume, that's the only thing that you can choose actually, apart from obviously properties and help. There's RAID, which is discussed elsewhere, so this is for your backups. So a nice handy wizard here. So you can change this again, or you can leave it at the default value that is suggested. We can choose a drive letter, or you can leave it as the one. In a lot of corporate environments, this is obviously on the server side. Say where I used to work, the entire sales team had access to the Z drive. This is just a letter, so a lot of people thought there was a drive somewhere, physical drive that was just given the letters Z, but it was probably just a partition somewhere on a server. I'll call this the Z drive, sure. I won't choose any of the other options. Format this with the following settings, or you can not format. We recommend you do format and perform a quick format. You can change these, you can give it another name if you want. You could call it the sales team or whatever. So this is a confirmation of what you've configured so far. Just check that it's exactly as you want it. Okay, and then because it's Windows 10, we get this annoying little pop-up here. But basically, you can see now we've got the new volume created. We didn't give it a name. It's NTFS. So I think that's all we need to know. It's the same process for Windows 8.1. Windows 7 is a bit different. As of writing the videos and book, Windows 7 is still in the syllabus. So check also how to do it under a Windows 7 machine. Welcome to our lab. Design hard disk layout. So we're going to learn how to design a disk partitioning scheme. In this lab, we're going to learn about disk partitioning, partition types, and how to set up partitioning using tools such as fdisk. Now, just be careful. Obviously, I do say at the start, I think, don't do this on live equipment. So it's always worth cloning your machine and doing the tasks on the clone of your machine. You can do that in your virtual machine manager. So there's just a warning I'd like you to read through. Obviously, if you're working on a home machine that has Linux as its main OS, then I'll encourage you not to follow along this lab on that machine. So all you need is your single Ubuntu machine. First task, we're going to open up a terminal and run sudo fdisk dev sda. Now you'll substitute whatever disk you have for the correct device. I don't know how you've actually got your device set up at home. We've covered finding out your installed hardware earlier on. Just I did note this in the lab, but the changes are going to remain in memory until you decide to write them, which we will not be doing. We're not going to write our changes. So I'll enter P to see the current partition layout. If you've selected your main disk, you should see at least one partition along with its size, type, whether it's a boot partition. And I've put an example output below. Don't worry if yours doesn't match mine. And if we can see our device, the asterisk, the start and end sectors, and the type. You can see we've got Linux here, extended, Linux swap. So we'll delete any pre-existing partitions, and this is only going on in memory. It's not going on our actual device until we write the changes. And again, just to reiterate, we're not going to be doing that. So D, delete partition 5. Number 1. End-to-end add a new partition should be primary. Number 1, 100 meg in size. It would be mounted at boot. So P for primary, it's going to be partition number 1. Just want to keep coming back to the lab so we're all on the same part of the lab together. You can enter the default. You could also enter the last sector. Sorry, I haven't got numlock turned on there. So specify 100 meg. You've got a few options there you can obviously play with. Repeat this for these swap partition, make it 4 gig or double the system RAM. You can play with whatever relevant settings you have on your setup and experiment, because this is all happening in memory. So partition number 2, and again you can specify the partitions or just specify the size: kilo, megabytes, gigabytes, terabytes, petabytes, as you can see the KM GTP. L to list all types, capital L. And what were we looking for? 82. Always worth making a note of the main types you can see here. You wouldn't be expected to know them all for the exam. So we're going to head for 82, which is our Linux swap. Repeat this for the var, make it 4 gig in size. Create an extended partition that fills up the rest of the disk. With this extended partition, you'll create partitions for home and /. So E for extended. We're going to enter A to toggle to bootable flag on partition 1. And we're going to enter P again to see what our results would be. So compare this to the first time you issued this command. You can obviously then write this, which we're not going to do. Enter Q to quit without writing to the partition table. And the last thing is just to go through some notes that I've put in here, which you can pause the video and read through. Welcome to our lab, Create Partitions and File Systems. We're going to learn about partitioning disks using tools such as Parted and creating file systems with tools such as MKFS. FDIS was covered extensively in an earlier lab, so we're not going to cover it here. It's recommended to redo the lab. I may swap the lab numbers, so just be careful, but you'll find it under FDISC. I only say that because we do tweak the order just sometimes for improvements or syllabus changes. So, task 1. First step is to create a dummy block device to be used for the rest of the lab, so we don't erase any of our machine's actual data. So open up a terminal and run the following command. This file is only 1 gig in size. It doesn't need to be large, but if you have more space you can make it larger for more flexibility. Now run the following commands. This should print a device name such as dev/loop0. This is the loopback block device and what should be substituted everywhere when you see dev for the rest of this lab. Now you'll partition this new block device. GDisk is a useful tool for creating GPD partition tables. It's based off FDisk and the syntax is nearly identical. You can reference our earlier lab on FDisk to learn about GDisk. For now, use Parted instead, and we can see we've got dev here, so we're going to swap our loop 22 dev or dev/loop 22 when we see this here. Should have said earlier actually, you're going to see some warnings, but they're not important because we're just going to respond in the affirmative, which is the ignore. It's worth noting that, unlike fdisk and gdisk, Party does not store all changes in memory and write them at the end, but writes every change as you make it. Thus it might be considered less safe than the previous two. Now we're going to create an ext4 file system on the first partition of our block device. The name should end in P1, for example. So if your block device is /dev loop 0, the first partition should be /dev /loop 0 P1, etc. Finally, create a swap partition as well, sudo mkswap dev with p2. If you're actually setting up a new system, you will then activate the swap partition with swap on, but in this case you should not do that. You could also mount and start using it as a normal ext4 file system if you so wish. Now we'll do our cleanup. Welcome to our lab, Maintain the Integrity of File Systems. We're going to learn how to verify file system integrity and repair basic problems. So in this lab we'll use tools such as FSCK, XFS Repair to search for file system problems, as well as learn how to monitor free space and inodes. So task 1. First we'll set up a dummy block device as we did for the previous lab. We'll follow through the commands, which you can do also. This should print a device name such as /dev loop 0. This is a loopback block device. This is what should be substituted everywhere when we see dev in the rest of the lab, such as down here. In the last lab mine was /dev /loop 22. Yours could well be different to mine, so obviously just replace what I have with what you have on your device. So you can see mine is loop 22, sorry. Now we'll continue with some of these, or all of these commands, sorry, here. And what we'll have just done is create two file systems on a block device and fill them up with a file containing random data. Then they obtain the MD5 hash of each file. which we should save for later. Alright, so I've already mentioned this part here. We've obtained the MD5 hash of each file in which we've saved in a text editor there. Now we'll do something that you would never normally do. We're actually going to intentionally cause damage. So we're going to cause significant corruption of both file systems, though unfortunately because of the nature of such corruption, the results can't be predicted. What you should then attempt to do is remount both systems and get the MD5 sums again, and then we'll compare them. Well, as you can see, it's possible that MD5 sum or even mount will fail for one or both file systems. Make sure they're both unmounted again, and then we can run the following two commands, and then you should be able to mount the file systems again. You should then be able to mount the file systems again. You may notice the MD5 sums of your important data have been permanently altered. This is the unfortunate factor of file system corruption. Not everything can be saved. Check the disk space on both file systems with the following commands. Are they still full, or were both your files actually deleted because of the corruption? And then we'll do the cleanup as well at the same time. Welcome to Microsoft Command Line Interface number 1. I'm going to end up doing a few labs for this. As of recording, I'm not sure how many because I thought I'd do multiple commands in each lab, but it just turns out there's a few too many steps. I've got a Windows 10 virtual PC running in VirtualBox, so I'm sure you've seen this by now if you've followed the lab sequentially. And I want to try one particular command. So we need to get to the command line interface, the command prompt, CLI, depends on what you want to refer to it, but it's a CLI tool, and CLI basically means you're typing out physically commands rather than using the GUI. So this is the graphical user interface environment. So what we normally type is CMD, and normally, in fact always, all things being equal, your choice for the command prompt and the little icon here with the C backslash and what's it called, colon, is there. So I'll just click on that and we'll get a nice little window up. Now if you don't have great eyesight or you prefer to change the way things look, you can right click up here, you can it's properties, I think, yep, and then you can change the colors. Some people like some funky colors for their backgrounds, the text. especially if you're used to working with other vendor tools like PuTTY, etc. You might want it to match, or you might want it different, just so you can remember which environment you're working in. So you can decrease the font. What often happens is people click on bold, so they keep everything the same. They click on OK, and then so that hasn't changed. You can do this in your own time anyway. Click on bold, make it a bit bigger. There we go. That's a bit better. So anyway, I just wanted you to see that. So you can do it for yourself, and in case you're asked, you never know. So we're going to be looking at the dir command, which is short for directory. The command lists all the files and subdirectories contained in a specific directory. So wherever you are, it will list what's inside that particular directory. So just bear in mind you're going to have different files and folders to me, obviously. I only say that because I always get a question like why can't I see such and such. So dir, I'll press enter, and this is everything within the Paul W, the C users Paul W directory. So what's here? 3G objects, desktop, downloads, favorites, all my stuff that I've got for my particular setup on Windows. So one of mine is downloads. You'll probably have that also. In order to navigate to that directory, use the command cd and then downloads. I'll actually change. The CD doesn't have to be in capitals. So CD downloads, and then it should change the prompt from Paul W into the downloads folder. So CD downloads, and you can see it's changed to downloads here. Now, if you want, you can, on any command, in fact, you can do the following. So dir space / question mark to see what your options are. I don't think you'd be expected to know all of these, maybe some of the common ones, but you can list them in lowercase. Same as wide files, you can list everything in a big long line or individually. Pause after each screen full of information. Press any key to continue. So have a look at those. I don't think you'll need to remember those certainly for the CompTIA exam anyway. Alright, so issue the dir command again to see the contents of your downloads folder. So dir. Alright, so I've got, looks like one file in here, a Manage Engine mid-browser tool that I use for another lab. Now, what I want you to do is go to your, press on the folder, or you can just go to your desktop if it's on there, downloads, and you can see the tool here matches what we've got listed down here. So this is just a confirmation, your Manage Engine mid-browser. I just wanted you to see that. Right click on your desktop, new folder, create a folder called Fun, and then in the folder we'll create a document called 101 Labs, a text document. So I'll go to the desktop, right click, new folder, Fun. If you mistype whatever reason, you can right click and rename. I'll double click in here. I'll right click, new text document, and it was, what was it, 101 Labs. Alright, so I've got my new folder, and inside the folder I've got my text document. Navigate back to the command line in your desktop, type cd and press the space bar, and then drag your new folder you created to the command line window. So I just need to move this up here, and what I'll do is I'll drag this folder down to the bottom. I've just got a limited window size here, which is why I'm having to do this. Sorry, I'll get this right in a minute. to move this even further down. Okay, so CD to change directory. What I'll do is I'll grab this folder. Rather than me typing out the whole path or right-clicking and reading it all out, I'll drag here, and you can see it's auto-completed for me the full path. And because I'm not in the directory, I've got to type out the full path. Otherwise, I'd have to go back up to Paul W and then go back down again. So users Paul W desktop phone is the path to here. Press enter. Now I can type dir and see what's in there, and you can see 101labs.txt is in there, which is the file inside here. And there's one other step for this lab. I wanted to just look at one more command, which is move. So you will type move the file name and then the path to where you want to move it to. Just bear in mind my user account here is Paul W. Yours will obviously say something different, so you need to just change that part here. So then move to wherever you want it to and press the enter key. So move 101 labs.txt, and I'm going to move it to here, so this user's desktop. So that's the back. So move 101labs.txt to C users, Paul W / desktop. Alright, and then if I just move this across, you should somewhere in the desktop be able to see that the file's been moved. Can look at some more CLI commands. So all the same as before, we'll get a command prompt open. What I want you to do is issue the ipconfig space / and see what your available options are. So the first set here, and then here's where you'll be using the most common commands. The thing to note is if you want to do anything with IPv6, you use the standard IPv4 command, but you have to add 6 on the end, and the same here and down here. So a few examples of IP information that's printed: show detail, show information. So case in point, ipconfig shows you some very basic information. Your link local IPv6 address, your IPv4, your subnet mask, and your gateway. If you wanted to see some more information, it's / all, and now you can see the host name of your computer. And depending on how you've got your DHCP set up, you may have more information here. Your desktop adapter, this is your MAC address. It says physical address, which I'm sure you'll know is your MAC address. Your link local IPv6 address. Your IPv4 subnet mask, when you got your lease, when it expires. Default gateway, DHCP, version 6, your DNS server address. This is actually my home router that I'm pulling DNS information from. Alright, so that's covered in those steps. Make a note of your IP address. You may need to request a change of IP address from your DHCP server for troubleshooting reasons. So most network engineers for this would use the command line interface. You can use the GUI. You can just click onto static and then back onto DHCP, but generally we would release and then renew. So that would release your IP address, and then type renew. Contacts the DNS the DHCP server, sorry. Now you might be given the same address, don't worry too much. For most home networks that would be the case. Could be different if you're in a corporate environment. Next thing is display DNS. This displays the DNS cache that maps the IP address to host names. Or the other way around, sorry. Display DNS. So there's a whole bunch of websites that I've visited over time. What I'll do is IP config flush DNS, clear it, and then I will ping 101labs.net. I should get 4 or 5 ping packets sent. IP config display DNS, and you can see there's only one entry in here, and that's for my 101labs.net. Read up on your theory book as to the record types, what this means here. We also cover that in the Wireshark if you're on the 101 Labs website. And then finally, we'll do the flush DNS again, and then we'll display the DNS, and it should be empty. Okay, we're going to look at some more Microsoft CLI commands. So the usual PC, I've got Windows 10 running. The commands should all be standard through any version of Windows. So we'll open up our command prompt with the CMD command. Other ways to get there, I think you can get there through the control panel. And then we'll do some commands. So the first command I want to look at is the tracert. The thing they try and catch you out with in exams I found, it's a bit silly, but what do you type? Do you type trace route? Do you type trace? Well, on Windows it's tracert. I don't know why whoever's coding this stuff just decides what you're going to put in. If you're configuring Cisco devices and then you're coming onto Microsoft, you can get caught out or just get a bit confused in the exam. Tracert, there's obviously switches. I'm just going to put the standard tracert. .101labs.net. What I'll do is I'll press the enter key and then I'll have to pause the video because it goes over a number of steps. Alright, so that takes a while. So what I did was I grabbed the screen here, traced to 101labs.net. It does a DNS search and finds the server IP address. So there's 3 packets sent, and you can judge the 3 different times to see if there's any variation. You'll notice when you get to large ISP gateways, then you're going to see a dramatic increase in time, and this is what you do when you're doing your troubleshooting. You can see, for example, here chiba.as6453.net. This is a call router somewhere, and there's a large increase, and then there's a timeout, and then a shorter period of time. So this will all be part of your troubleshooting. Obviously request times out also. Now this is all out of your control, but what it can do is prove that there isn't an issue with your side of the network. So for example, line 2, the first try took 61 milliseconds, second 57, third took 51, and then I've already mentioned the long delay on the gateway. Now the standard is over 30 hops. You can use one of the switches to reduce that if you so wish. Next command I want to look at is NSLOOKUP, short for name server lookup. It's a powerful command line tool. available on it's my operating system, which used to query domain names or IP address mappings. You'd use it to troubleshoot DNS issues. So just bear in mind in the exam what you're going to use these tools for. This is for DNS issues. So 72.163, I'll probably not remember this, to be honest. 72.163.4.185. And these can change over time, by the way. If a company moves their server, then the address might not work. I checked mine because I'm using a cloud server and I think it's shared, then it doesn't bring me back a specific result. Issue the same command but query a Google DNS server is 8.8.8.8 or 8.8.4.4 of the commonly known Google DNS servers. Okay, so we've pulled up our Cisco, the DNS Google server, the IPv6 address, the IPv4 address. Obviously look up, because we're not teaching theory in the labs books, we're just showing you what commands you can use and where you can use them. Please obviously look at the documentation for all these commands. NetStat, short for network statistics, is another command line tool used to display network connections for TCP, routing tables, interface statistics. It's available on Linux, Solaris, Windows and BSD. So netstat -a is the command I'll use, which is going to look for my TCP active connections. Again, all these commands, please look at all the available switches. So netstat space /?. Check the current routing table of the PC. You can use the netstat-r command, or you can use route print on Windows. Okay, so my IPv4 routing table here, and then my IPv6 routing table down here. And finally, set your PC to shut down in 1 minute by using the shutdown command, shutdown -s-t, and then how many seconds you want. If you don't want your PC to shut down because you've got unsaved work on it, then obviously don't press the enter key, or you can just use the switch to find all your available switches. So you can see the Windows machine will be shut down in 1 minute. We're going to take a look at some operating tools for Microsoft. So these are easily accessible via the GUI that you can perform different tasks, so they've been grouped together. We're going to use the search bar and we're going to search for msconfig, and then the system configuration utility should appear as an option. So here we go. Alright, for some reason the virtual machine is a bit slow, or you can't select the same thing twice. So if I've gone through this and then closed it and then opened it again, but I typed down here just in case it comes up in the exam, msconfig.exe, and it just executed the command for me and opened up the system configuration utility. So I'll just track along with my written lab, just so we get the order. So we've got the first tab here is general. So you'd use the diagnostic startup to troubleshoot system problems. In this mode, your computer loads only the basic device drivers and services, and it just says here, obviously normal is everything. If you've made changes to any of the settings in the boot tab, or if you've disabled any programs or services from starting up, the selective startup will be selected. So if we go back here, I could choose this for the moment, but I'm not going to because I haven't made any changes. I don't want to do any diagnostic, so I'll leave this as it is. Over to boot. So this tab allows you to make adjustments, so you can make Windows, you can make in the Windows boot.ini file without having to manually edit the file. So that would obviously be a bit more advanced than you would need for the A+, I'm pretty sure. Check Windows documentation for each option. For example, if you tick on the OS boot information, as drivers are being loaded during the boot up process, their names will be shown in the output. So this is for more advanced troubleshooting, maybe more than A+ level. You just need to know it's there, I would imagine. Again, check the syllabus in case they decide to add it. Advanced options are usually reserved by system programmers. So the advanced options here we probably wouldn't touch unless you're speaking to Microsoft support. So safe mode, you boot with the limited drivers. Boots without the GUI, you want a boot log. Base video for troubleshooting video problems. Your OS boot information for your operating system. You can tick multiple boxes, as you can see. I've just got my one default OS here. You can have multiple ways to boot your machine. You can boot off other operating systems or other versions of Windows. Make all boot settings permanent. Timeout 30 seconds. Since we've got the timeout, so this is the amount of time you'll have the default setting or any available settings show before it boots to the default. So you could have like Windows 10 here, 8, 7, etc. Have one as the default, and if you don't choose anything, it would revert to the default. Services tab, you wouldn't usually disable Windows services, so you've got to be careful what you actually disable here. I think on my machine, I think everything here I've got is Microsoft Corporation. I would have to download something else. So this is my actual physical PC, and then behind is the virtual machine, and you can see there's other vendors, other manufacturers. So if I wanted to hide all Microsoft services, then I could choose something that may be causing me boot problems, less likely to be the Microsoft ones. You can enable all or disable all, which I'm not going to press because this is my actual machine. And then you could say, for example, you've got a problem with Adobe Flash Player, you could disable this here. And then obviously apply. Click on the Startup tab. In Windows 10 you may be presented with a box below asking you to move to Task Manager. So Startup on Windows 10. My Windows 7 I can actually manage it inside Windows 7. So these are your startup programs. I don't have much here on the virtual machine because I haven't really enabled much software. There's just a mid browser here. So Windows 10 I can click on anything I want, and I can then select the disable button. If I go back to my Windows 7, I can just directly tick or untick here, and you can see where the location is in the registry if I hover over or I expand the menu here. So for example, Tunnel Bear, my if I'm having problems with my firewall, it's causing issues on startup or too much memory. And a lot of the time you install these programs and they you don't notice, but they add themselves to the startup menu. So there's a few things I've disabled here. For example, Apple, Persh, iTunes was all loaded on startup and it was just sitting there taking up resources. So these are all things I didn't want to start unless I specifically do it. The Tools tab lets you have quick access to a number of Windows tools. So over here, for example, you'd click on whatever you want basically. I'll do system information and then click on launch. And then I can look at whatever the information is for my virtual machine here. Welcome to the lab, Microsoft Operating System Tools number 2. You use some of the OS tools to perform maintenance tasks. You need to know the most common ones. Windows Task Manager is packed with useful information, including your system's overall resource usage and detailed statistics about each running process. Now it's going to look different depending on which operating system you're using. I'm using a Windows 10 virtual machine. So just bear in mind if you're doing this on Windows 8 or Windows 7. First thing we're going to do is right click the taskbar and select Task Manager. As always, there's more than one way to find the Task Manager. You can also search for it to name but 2. So I'll go down to my taskbar, I right click. Here's my Task Manager. Virtual machines are running a bit slow today. Alright, so you can see the Task Manager is opened. I'll just go through the lab. So this will open up the Task Manager utility. Already mentioned different versions. This is the Windows 7 version, which looks a little bit more basic. We'll start with a simple view, clicking on fewer details and a smaller window will then appear. So there's a fewer details tab here. So this will just give you a floating window. I haven't got any running apps, so I could start something. My malware scanner that I downloaded in another lab. In fact, no, that's later on. I've gone back and done these labs later. I had a malware program which started when the Windows started up that would normally be running here, but that's not showing. So no, there's no programs running at the moment. Open up a program such as Notepad and it should appear as a running app. You can right click on the app and choose several options, including switch to end task. I selected open file location as an example. So I'll open up Notepad. And you can see my Notepad has appeared here. So I'll right click on the task here, switch to, so you could have several tasks obviously, and if there's one you wanted to have open or switch to active, then you could do that. You could end the task, run new task, always on top, open file location, just as an example of one to click on, that is. And eventually the location of the Notepad program, which you can see here, is in my PC, my local disk, Windows, and then System 32. So we'll click on our More Details tab and we'll continue on. So note all of the options available. So the Processes tab, this shows you a comprehensive list of all the processes running on your system. You can see from the above screenshot that you can sort by name, status, CPU usage and other values. If you sort by name, the processes are arranged into apps, background processes and window processes. So apps, background processes, then if you scroll further down, Windows processes, and obviously you can see how many are running in the brackets. Right click a Windows process and note your options. Some may be grayed out if they are unavailable. Avoid ending any task if you're unsure about what it does. There's a green leaf symbol that may appear next to some. This represents eco mode or battery saver. You can see just here, here and here. If you right click in the name status row, you can see other options you can enable or disable current views. So these are the kind of things you can add. If you wanted a process ID to appear, you can see the column. I'll untick that. Just try these yourself, obviously. Each option, look at the sub options. Click on the top menu, items, and note your options. You can run new tasks, minimize on use, and more. Click in the Performance tab. Here in real time you can see graphs displaying system resource usage. It says CPU, memory, disk, network and GPU as your graphics processing unit. If you have multiple disks, then the network devices or GPUs can see them all separately. I've got another disk here I think I did for another lab. It's not used, it's a one I think I just used for BitLocker maybe. In CPU view you can view your CPU speed and model, make, of a number of cores, speed and if virtualization is enabled. Note that you can also see a report of utilization speed, processes as well as a graph of utilization over a 60-second period. So mine's obviously running high. I've got, I'm not sure what's running on this actually at the moment. This would obviously be part of your troubleshooting to see why it's running so high. Note that you can turn this graph into a smaller window by right clicking in the white space to the right and click on Graph Summary View. In the App History tab, it only applies to the Universal Windows Platform UWP apps. You won't find information about traditional Windows desktop apps here, so most people won't find it too useful. UWP apps can be used across all compatible Microsoft devices, such as PCs, tablets, smart boxes, Xbox One, etc. We've covered startup in an earlier lab. In the Users tab, it displays a list of signed-in users and their running processes. It will just show you if you're using a home PC. For each user account, you will see CPU, memory, disk network, and other system resources used. You can disconnect any user by right-clicking their account. Details tab is the most detailed one available, hence the name. It's similar to the Processes tab, but you have more information, and it shows processes from all user accounts on your system. Right-click one of the processes and note your options. I've got nothing running here at the moment for some reason, or it might take a while to fill up. Oh, here we go. Just choose something random, right click it. I'm not going to end anything. The Services tab shows you the list of background tasks that Windows runs. They're controlled by the Windows operating system. You can right-click any task and view the options. Avoid making any changes unless you know exactly what the service does. Microsoft Operating System Tools number 3. You'll use the operating system tools to perform maintenance tasks. You need to know the most common ones. System information is included with Microsoft Windows. It allows users to view information about the computer, its hardware, drivers, and software-related data. We use a single virtual machine running Windows 10. Type system information into the search bar and then click on the result. You can also search for MS Info or MS Info 32. Please check your documentation for how to open in Windows 7, 8 and 10. Note your system summary. You can see a lot of information including your OS, system name, BIOS, etc. You can also search for a value if you need to. Click on the Hardware Resources button. There's no summary available, so you choose one of the options. Below you can see a list of IRQs. This is a numbered hardware line used by device to interrupt the normal flow of data to the processor, thus allowing the device to function. Obviously click on all of these. So I think IRQs are a feature. They always used to be, not sure about anymore, for the A+. Click on Components, select Storage and then Problem Devices and note if there's any problems. Click on Software Environment, System Drives. Note the name, description, location type, and if it's started or not. You can't start or stop them from here. Look at the Microsoft Control Panel. You'll use the Control Panel to access security, networking, hardware, programs, and some other Windows features. I'll just cover some bits. Obviously, there's a whole bunch of options on there you can go into. Type Control Panel into the search bar and then click on the result. Note that other versions of Windows offer different ways to open and access the Control Panel. Use the search facility to search for user accounts and you should see the options appear. Click on the arrow with the Control Panel text and you will see more options appear. Click on all Control Panel items. Click on Power Options. To change your power settings to power saver, you can change it back later if you want. Obviously read all the documentation and you can go to the Microsoft site if you click on any of the links here, the hyperlinks, and also you can change the plan settings that are set by the operating system by default. Use the File Explorer to navigate to your C drive and Users folder. Return to the Control Panel and click on File Explorer Options, click on the View tab and click on the Show Hidden Files, Folders and Drives. So we can see here there's Paul and Public. And you can see a greyed out, well not greyed out, a light yellow folder which was hidden before. I'll turn that off now because I don't really want that to show. Too much information, as they say. Download the VLC video player and once installed click on Default Programs. There's a VLC media player. I think I might actually have it in my downloads to save me some time. No, I must be with the machine. Alright, it's from videolan.org anyway. All these programs you can delete later on if you don't want to use them. I'll just pause the video while I do the download and installation. So that installs, so I'm going to go to Default Programs, set your default programs, and then change my video player. So if I click on it, I would have just had the default Windows Media Player, maybe these two, but now I've got the choice of the VLC Media Player. I'm going to switch anyway. So now this shows as my player. Download any MP4 video. You'll find some on sample videos, sample-videos.com. I want to download an MP4 video. You can see the VLC icons here. It's recognized it as an MP4. And feel free to play it if you wish. I'll click on Open File. And you can see it's playing the video in the VLC video player. I don't really fit in my screen very easily. Welcome to our lab on Microsoft Display Settings. You'll use the display settings to change your screen resolution layout and manage multiple monitors if you have more than one at home or work. Using a virtual machine running Windows 10. Type display settings into the search bar and click on the result. Note that you can also right click on the display area and select it there. Under Scale and Layout, change the size of the text, apps and other items to 125%. You can see they changed in the background here. You may be asked to sign out and back in. Note that some icons now appear larger, as you saw. Change the orientation to portrait and you will see the screen flip. Don't press anything, it will revert in a few seconds. And your mouse orientation moves also. I'm moving it left and right, but it's obviously going vertically because of the way the screen's positioned. So after a few seconds, it will go back. Click on Graphic Settings. Windows 10 users and administrators can assign graphics performance and preferences to specific programs on the operating system. Universal refers to apps installed from the Microsoft Store, classic apps or traditional Windows desktop programs. Select the type from the drop-down menu which appears. Select Universal App and then Microsoft Edge, and then change the graphic specifications to power saving. There is another setting. If you wish, you can change the screen resolution, which is a common one to change also. I won't change it on my virtual machine because it causes me a few display problems. Welcome to our lab on Microsoft printer sharing. Learn how to share a printer over a network using printer sharing. She'll enable this if you want other devices on your LAN to print to a printer connected to a different machine. So this is different from a network printer, which will have its own IP address and have its own LAN port. So I've got two machines. You could do this if you've got two at home, otherwise you can use a virtual box. I've basically got two machines running Windows 10, and they're both connected to the same NAT network, so they've both got the same LAN IP address. They're in the same subnet. Ensure your PCs can ping each other and are in the same subnet. I have a NAT network, as I've said, so do your IP config and ping your machines. On one device, we're going to download a printer. Okay, it's like a virtual printer. You can use it when you click on the print icon and it prints a document into a PDF. So instead of actually sending it to a physical printer, it's recognized on your hardware as a printer, but it's actually just a software program that prints. Now you've got to go to pdf995.com, and there's two files, your printer driver and then your free converter. So download both of those, go through the installation. Normally if it asks you to add any other free virus scanners and other things, you untick those, you don't want them. So I'll just go to the page so you can see it. Alright, so it's these two that you need. I won't go through the downloads on the video, I'll just pause it because you can download and install yourself. So when you've installed it, we'll go to Settings, Devices, Printers and Scanners, and the printer icon, and then we're going to manage it. Click on printer properties and then sharing, and then share this printer. What we'll do is we'll change the name to HR printer, and then we'll click on OK. Now on your other PC, create a notepad file with any text. Go to File and then Print, and then we'll find the printer. You may have network discovery and file sharing turned off. I can't remember if I turned this off in another lab. Alright, so I clicked on network. There's a few devices here. I'll just go back to the original one. We'll check our device name. I don't know why it's showing 3 because I've only got 2 booted up. Control panel, system and security. See the name of this computer. Alright, this one's called home. A bit confusing actually, but doesn't matter. So click on home. I have to log in. Okay, I logged in and it's showing the shared printer here with the shared little old-fashioned connector here. What's it called? BNC connector. By the way, you can then select the device and then print to it if you wish. Now, because it's a PDF, I'll just install the driver. Because it's a PDF printer, it won't actually print out anywhere. It would just print to a PDF. Welcome to our next lab, Microsoft Workgroups. A workgroup is a collection of computers on a local area network. They are how Windows organizes resources and allows each to access to each on an internal network. Windows 10 by default creates a workgroup when it's installed. Occasionally you may need to make a change and it's added as a syllabus item. So obviously while we're covering it, we've got an internal NAT network as we've had earlier. So these two devices are in the same local area network and they can ping each other. And this is the setting in VirtualBox. So we'll type control panel into the search bar. We're going to go to System and Security, see the name of this computer, note your computer name. I can't remember if I changed this, it's normally got a tag of random characters on it, so I might have changed it when I was doing an earlier lab. Your workgroup name is all capitals, workgroup. So what we're going to want to do is change these settings. The computer name I'm going to call 101-1. To rename this computer or change its domain or a domain or workgroup, click change. Sorry, it's 101-1 here. The workgroup I'm going to change to 101 group. Click on OK. Make a note or do a screen capture if you're doing this for real, because if you're like me, you'll forget what you typed, or if it was capitals, or if it was a dash or an underscore. That's a dash up there, that's an underscore down there. Now you can click OK, and then you're going to be asked to reboot the machine. So you must restart your computer to apply any changes before restarting, save any files. So I'll pause the video while the computer restarts. So it's rebooted. I'll click on the File Explorer and I'll go down to Network. And you'll see we're the only device on this network at the moment. So I'll click on my other machine and we're going to go through the same steps, but we obviously need to change the name. We can't have the same name. So the moment the machine rebooted, on my original one, I just clicked on the refresh network here, and my other devices appeared. Learn how to map a network drive. Windows lets you create a shortcut to another drive or folder shared in your network by mapping to that location. When you map a network drive, it shows up as a new drive under this PC in File Explorer. You can easily access the shared files you need to access just like you would your local hard drive. On the 1012 PC that you created earlier, go to the Windows File Explorer by typing File Explorer in the search bar. Click on this PC, computer, and then map a network drive. You can access a drop-down list of the available drive letters. Choose the letter Z or any other letter you wish. Browse to the folder you created in a previous lab on the 101-PC and click OK and finish. I think what we'll do is just map to a local one to make it easier actually. Actually, I'll take it back just to make it more interesting. So I've clicked on the network. I'll find a folder. Document should be fine. No. The OneDrive. Alright, so I clicked on finish and you can see, if I just go back, this PC, I've now got a Z drive and it's mapped to the videos on the network. I've got no videos in there at the moment. So using directories and listing files, we'll learn how to create, delete and list files. First thing we'll do is open the terminal and enter the command touch space foo. So touch is an easy way to create an empty file. Now you can actually print the contents. However, in this instance, that we haven't put anything in it, so it won't show us anything. But at least you'll get to see the command there. You can list more details with the ls command. You can also issue ls space dash and then help. You can do -h or -- help ? And there's a a relatively large amount of contents, and you can see all the switches upper and lowercase. So we had the L, use the long listing format, human readable. What was the other part? Oh yeah, the size, so S. So we're going to show us the size as we go along. You'll see other outputs which hopefully are covered in any study guide, the read write, read, read, the file name, created by me, it's 0 because there's nothing in it. Now create another empty file. We'll use the touch space dot bar. So this means it's actually hidden. And if we use the ls command, which will list everything in the current directory where we are now, which should be our home directory by default, it shouldn't show our .bar. You can see the foo file. There's another one I created earlier called Paul, just while I was doing some testing. So to see it, we'll use the ls space -a switch. And if we refer to our earlier help command, you can see the .bar here. There's some other hidden as well. If we go all the way up, it should be the first letter, the lowercase a. So do not ignore entries starting with the dot, which are hidden. So that's what the A means. We can clean up now, RM for remove, and then you can list with spaces various files that you've created. Obviously you have to be careful because it's not going to ask you, are you sure? And then the ls space -a, you can see our two files are gone. Using directories and listing files, directories, how to create, delete, enumerate and navigate directories. As with all the labs, I'm presuming you've read your theory book or watched your video course, and we'll just go through the practical part. So we'll go through make directory, -p, and then foo, and then /bar to create a directory of foo, and then inside that one called bar. Now remember, I put the question mark. I've just done a Cisco lab where we use the question mark. Sorry, but you can use the help functionality at any time, and I recommend you do, just so you get used to looking at all the different outputs over and above the ones we cover for the particular lab. So mkdir. And you can see the P command there, lowercase p for parents, foo, and then inside that bar. And then we'll use the cd command. Sorry again, just in a Cisco lab, silly me, so I'm going to be doing question marks instead of the help. So change directory to foo, list the contents of the directory. We can see we've got bar inside, which we just created here. We'll make a hidden directory called .baz or called baz. When we list, remember from an earlier lab, it won't show the hidden directories. So we'll need to list the hidden. And we can see in there, we can also see a period and a double period. PWD shows where we are, print working directory. So the -ALH lists all the details that we can see here. And this is explained more in the slide, part of the video you can see, and pause it if you so wish. So we can see our parent directories under the period and the double period. This is the home directory. Please use the follow the commands, pause the video and run the commands as shown here, the cd, pwd, pushd, etc. And look at how these affect your directory structures. I presume you change your directory back to your home directory. So I did a CD, double period, pressed enter. Change to the foo directory. So we enter this command here, foo/.baz_qux. So A is all files, R is a recursive lookup, capital R. I explain more details about what the commands mean here. So please pause the video, and again, hopefully you've referred to a theory guide before you've tried this command out, or you can do the commands and then go back to your theory guide. CD, back to the home directory. We can remove everything, our foo directory and everything in it. Also, please check the help output here. And we can see what the R stands for. Welcome to the next lab, your computer on the network. In this lab, we'll learn how to query important network configurations and gather information connecting the Linux computer to your local area network. So I'm running a virtual machine and it can be a bit tricky. I'll just show you what settings I've got. So this is VirtualBox that I'm using, and I'll go to settings, network. Now this took a while, and to be honest, it may work differently if you're using a wireless connector. I don't have a wired network at home, it's wireless, so it just made it even more awkward. But I'll show you my settings anyway. So adapter 1 I've got connected to NAT, advanced, I don't think there's anything else. I think this was default. I've got cable connected port forwarding. Adapter 2, host only adapter, advanced, I've got promiscuous mode deny, cable connected. Alright, so I had to hunt around and check videos online and that kind of stuff. So that's how I set all mine up, and obviously I started the machine. So Ubuntu, I've got my a terminal window open, and it'll talk you through some commands here in the lab. So there's 4 commands to go through. IP address show, IP route show, socket statistics, and then 2 switches, cat, this file here, the host file, and then our resolve.conf. And it's asking, does our local network support IPv4 or IPv6? Obviously, unless you've configured anything, then it's going to be at the default settings. So let's do the first command that was in the lab. IP address show, and depending on how you got things set up, you'll have a different address. Well, you'll almost certainly have different addresses to me. This is my internal address, which gets natted, as you saw in the configuration, to a routable address by my router. We don't really care what happens out on that side for the purposes of this course. I can see I've got this IPv6 address here, which is going to be my link local address. Don't think they cover that in any detail in this course. You can enable it or disable it through your settings, your network settings on Linux. IP route show, you may or may not have anything depending on if you've connected anything out, but this is my Ethernet connection here at 03. So I've got a self-configured IP address here. Again, don't worry too much about the output. The main thing we're looking for is the knowing which command to put in here. You can use the help switch here if you want to see what all your switches do. We're going to use A and P, lowercase. So we go up here, A all, and then P process, show processes using the socket. So these are our current connections, and I've got something going out to Wikipedia, which could be that or that. Nothing much else happening up here. Again, the important thing is you know the command to enter, and just learn the various switches. Next was our host file. Got our loopback here by the looks of it. VirtualBox, you may or may not have this depending on how you've set things up. And this is a note telling us, giving us some information about IPv6. These are default IPv6 addresses for listening to all hosts, all routers, and multicast here, our local network here. You can read up on IPv6 in your own time. This file is managed here. Do not edit. It's a dynamic file for connecting local clients to the internal DNS stub. So you can read up on this also in your own time. The question in the lab was, does your network support IPv4 or IPv6 or both? Well, you can see mine supported both there, which you can enable or disable one or both of those. Now turn off your Wi-Fi or disconnect your Ethernet cable, disable your network connection to your VM, and run the first three of these commands again. I'm not going to go through that, mainly because it took me so long to set it up that I don't really want to tempt fate, and I've got more labs to film. But you can do so if you so choose, and then what changes occurred and why. Next thing, reconnect your network and gather some information. So we're going to do a lookup for 101labs.net. If I go back here, there's a whole bunch of switches. We're using the verbose output. Then we're going to put our domain in. .101labs.net. This is my server for the website. See where it's been hosted. Not sure there's any other interesting information here really. IPv6. So there you go, you can do the same. Your output again may differ if I've moved the server or if you've got it cached somewhere if you're at work. Can you ping 101labs.net? If not, how might you diagnose the problem? Alright, so you can see the ping. You hold down the Control and C button to stop the ping. I'm so used to doing Cisco that it just issues 5 by default. So the ping size, this was the IP address, the ICMP, your sequence numbers here, your time to live, milliseconds, and then how long it took to get a reply. You'll use this as part of your troubleshooting toolkit, and this will give you some information along with trace route, etc. So can you ping it? If not, so we're going to run the IP route show and then grep default, and we'll copy the output to be used later. So you can highlight all of this, make sure you get it all, and then copy. And then we're going to delete it as an administrator, sudo IP route delete default. This will break our internet connection in theory. Again, you may have different results depending on how you've set up your networking for your labs here. Now, okay, so the network's unreachable this time. So what we need to do is add the route back. So if you just follow along, I'll just show you down here. So congratulations, you broke it. You fix it by running the command IP route show. In fact, we'll do that first. No default route here. And then what we'll do is add the IP route. Sudo IP route add, paste, enter, IP route show, and we've got a default route added again. We should be able to ping. Yeah, so our ping's working now. Okay, so that's enough for now. Alt Control and C. And then there's just a note at the bottom here. The NetTools package containing NetStat, ifconfig and route among other tools is considered depreciated. Yeah, just be careful because some commands will work. However, they're considered no longer applicable, have been renewed. So you would need to check on the commands and see which command has replaced them. So you're answering the correct question in the exam with the correct answer. All right, so that's enough for this lab. I'll see you in the next one. Welcome to our lab, Managing File Permissions and Ownership. Hopefully this is reinforcing whatever you've read in your study guide or watched some videos. You know, we've got all the videos for these commands on howtonetwork.com. Otherwise, you can easily just Google the commands for Linux, chmod and chown, and just read upon them and then just use the labs to reinforce what you've read. So we're going to open up a terminal and run the following command, echo hello world foo. And then we're going to ls-l the foo directory so we can see the permissions here. And there's a key here explaining what the permissions actually mean. Alright, so we can see we've got characters here. You could have a D if it's a directory, just at the start. If it was an L, you'd have an L here. You've got 9 values here that represent the file permissions. If I go back to the document, it explains it here. Read-write indicates read-write but not execute permissions for the user who owns the file. R indicates read-only permissions for the group that owns the file. R indicates read-only permissions for all non-owners. So this is the world. Mention the first character. In this case, it's a regular file. Directories actually begin with the D. Who are the user and group owners of this file? The third and fourth fields of ls tell us that. By default, it should be your own user and primary group. So yours will look different to mine, obviously, because I've got a different account. This is any hard links. And yes, just mention the owner and group. This is the date as shown. Now we're going to run the command sudo chown root foo, ls-l foo, and then cat foo. We'll have just changed the user ownership to root while keeping the group ownership. As the file is group and world read permissions, you can still see its contents. So that's important to note. So we can still see when we do the cat command, and we can see we've got a change here. Oops, apologies, we haven't changed the permissions yet. That's the next step. But we have changed here. It's got root and then Paul. And we've gone from Paul to root Paul. So we're referencing the lab. We've just changed the user ownership to root, kept the group and the file permissions. It's fine, and you can still see its contents. Now we'll make another change. Sudo chmod o-r foo, and then the ls and cat commands. This will remove the read permissions from the other. As we've still got group ownership, we can still see the file contents. And now you can see the change from there to there. And if we cat, we can see the file. So there's another step to take, which I'm sure you can guess. So we'll run the chmod sudo chmod 600 foo. This chmod command sets the permissions explicitly to read-write for the owning user only. As that is the root, we can no longer read the file, because our account will be set to our name. So let's go through the second last step. We see the change on the permissions and permission denied here. So this last step, which I won't show you on the lab, we'll remove foo. There we go, removed. Note on the file at the end, or the lab, sorry, execute permissions come into play on executable files as well as directories. If a user or group cannot execute a directory, it cannot view the contents of said directory or any subdirectories. So that's the end of the lab. Thanks for watching. Welcome to our lab on the MacOS GUI. So you need to know where to find the IP address settings for the Mac. I've used a virtual machine on onworks.net. Hopefully you'll find it available. Now for making the lab guide, there's a different version, so mine will look slightly different to the actual book if you've got the book. In the lab guide we've got, you can click on the Apple icon here and we can access our network settings, but can't do it on this virtual machine. I think maybe due to the version possibly, or it could be privileges. But you can click on the system settings, double click it, and you won't be surprised to hear that it's the network icon here. Double click on that. Again, if you've got the book, the appearance will be a little bit different, but it's really easy to find. I'll click on options. You can see your general settings, layer 2, security, and IPv4 and IPv6. To obviously get to your IPv4 address, you click on IPv4. We've got DHCP, and all you need to do is click on the drop down arrow. There's a few choices we'll want to manually configure. Then click on add. You can add your IP address, your network mask, your default gateway, and it will turn from red to green when you've entered the correct syntax. So when you've done that, you can click on add. You can obviously delete it as well there and add some more if you so wish. Add a DNS server if you so wish also. You can add some routes to your routing table, which I won't do, but if you've got access to this virtual machine, you can add a route. IPv6 settings also, you can do exactly the same process. So please have a look at each tag, make a note of what your options are. Just bear in mind different versions will have a different presentation, including if you're following the lab on a different version of macOS. Welcome to the lab. Turning commands into a script, shell scripting. We'll learn how to write a simple shell script containing multiple commands. Scripting with Bash is a daily task by many professional Linux admins. When the task is repetitive, you don't want to be typing the same list of commands over and over. You want to create a script and perhaps also schedule a script to run automatically. Open up the terminal application, run your favourite text editor such as V or Nano. If you've never used V or Vim, then Nano is strongly recommended. Then we'll create this file with the following contents, and then we'll go over to task 2. So I'll type Nano to bring up my editor here, and then I'll go through the configuration. So you can save this, Control and then 0, and then give it a name. File name to write, I'll call it Paul test file, whatever you want to call it. Just remember what you've named the file as. And then to exit, Control and X. I'll just issue an ls Paul file just here. I've got a few of the test files that I've run, but don't worry about those. Make the file executable with the chmod +x file name, and then we'll run it. Alright, so sorry, I was doing a test earlier and there were some errors on it, so I got confused with the name. So Paul test file 10, you should see the numbers 0 to 9 inclusive, so 10 characters printed out one at a time. Knowing what the script does now, can you understand it in its entirety? What happens if you fail to pass an argument, or if you pass gibberish like letters instead of a number. Next task is run your script without an argument, then run the echo $question mark. So we'll go back here. So I'll just hit the up arrow. So we've obviously got an error here. And we've got the output here, which hopefully yours matches mine. So we go back to our lab. This is a special variable that references the exit status. In a successful program, the exit status would be 0. This script fails without an argument, returning a different exit status. So we've got some more description here. If you just want to pause the video, or if you've got the book, you can read through. That's all for now. I will see you on the next lab. Welcome to our smart card reader and locks lab. We're going to use the Internet of Things because this is that's the only way to test it, to be honest, unless you want to install them in your own house. So we'll use our server that will register devices. We'll pull up a switch so we can connect the devices together and get them all registered. For devices and home, let's pull up a door. Under industrial or offices, sorry, we'll get a card reader there, which is the blue square, and then we'll pull up the card reader. So as you can see, what we'll do, we'll connect everything, is the card will be shown to the card reader, and then if it's authenticated, then that should trigger the door lock there. And the door lock you can see is green, and it should be locked when the card reader hasn't been shown. Now, I didn't actually test this in the lab. I think you can get the door to open. There's a picture of the door opening and closing in other labs I've seen. So you can try that for yourself. The server we're going to set to 192.168.1.1. IoT turn on. Okay, I go to a web browser and put my own IP address in. We need to register an account because every time we reboot Packet Tracer or use a new server, it forgets the details. So 101 Labs, password hello. Just go down through the lab now. And we'll need to rename our devices to something more memorable. So at the moment it's called RFID Reader, I think, something like that. IoT2 is the display name. So we'll call it Reader. IoT1 we'll call Card. And then IoT0 at the bottom will rename, call it Door. Now we need to get IP addresses on all these devices next and register them with the server. I don't think the card reader we register though. We do have to change a setting on that. I was just looking for IP address, but we don't actually use them on these. So the reader we can do a configuration. The fast Ethernet. Just check on here. 192.168.3 for the reader, 2 for the door. One 192.168.3 is the other address, and then we'll just need to get them registered. Press connect to both the devices after we've put in the information that we need to. One-on-one labs and hello. Alright, so the door and the reader are now registered. We need to set some conditions so that if the card is recognized, then the door will open. So the open door match the reader card ID is equal to. It's actually got a card ID already, but I think we go in and change that in a moment. I'll put it as 1005. Then set door lock to unlock. Okay. So you can go back and edit that later if you so wish. Now the reader you can, if you want, in fact, you can actually leave it to what the default is, which I think is 1005. We'll see in a minute. We can actually go through to the properties of the card. 1001 is what it's set to, and we can change it to 1005. Probably not much point in doing this, to be honest, but it shows you how you can change the number or add a number of cards if you so wish. Alright, so what you can do is use the Alt key and drag the reader in front of the card. Then that should register the door. You can see the status here, lock is red. So it's currently locked. You can manually lock it and unlock it. You can add a condition later that if the card isn't shown, then it locks again. So you're going to need to wave the card in front of the reader. So actually grab the card there, drag it up, you don't need the Alt key, sorry. And you should see the key go green, and you can see the status of the door lock went from locked to unlocked. And the card has been read as 1005 on your status ID there. You can change the settings to get it to lock, but I'll leave you to do that. That's the end of the lab. Thanks for watching. Welcome to our port security lab. Real essential feature that you enable on your switches, whoever the vendor is. You can plug a hub onto your desktop. Two PCs will go into the hub, and then the hub will connect to the switch. And we're going to do this because we're going to test only permitting one device to connect through a switch port. And you do this for the very reason we got here, for somebody to stop somebody bringing in a hub from home and plugging in a few of their devices and having some fun. There's other things you can restrict, such as specific MAC addresses and that, but this lab will just connect the two PCs to any fast Ethernet on the hub here. And then the port we're interested in on the switch is fast Ethernet 0/1. So we'll configure port security on the switch first. Pretty easy to do actually. I know you can see a few commands there. on the lab diagram and the lab commands. First thing is interface fast 0/1. You need to set it to access mode. You can do security on trunk ports, but we won't do that yet. Switch port dash security and press enter. That enables security. I hit the up arrow and here are your choices. I'm going to choose maximum addresses learned on this port. I can have up to 132 by the looks of it. I'm going to choose 1 just so we can easily trigger an issue. Right, show port security. There's some default settings. The default action you can see on the far right is shut down. You can see the max secure addresses is 1, and you can issue the show port security interface fast Ethernet 0/1 if you want more detail. You can see it's secure up at the moment, which is basically up and passing traffic as far as security is concerned. Now I'll add an IP address to this device here. It should send some traffic out automatically, even if it's just to keep alive, which will be registered by the switch port. So still up, I press the up arrow and you can see this switch port has learned a MAC address, A3, or just missed it, sorry. So it's learned one MAC address. I'm going to add another IP address. If nothing happens on the switch, what you can do is ping from this PC to 192.168.1.1, but you can see a keep alive was sent. It's caused the interface to shut down. The last MAC address was 38C, and you can see the new MAC address learned ends in 6402. This has triggered the shutdown on the port, which is what we wanted to happen. If you want, you can go into the devices and check the MAC addresses to confirm that's what actually triggered it, which device. But we've proved this port security is working. Thanks for watching. Welcome to our lab on MAC filtering, MAC address filtering. There's many ways to do this. You could use a Cisco switch, which we got in our Network Plus course, but I thought we'd do it with a wireless router this time. So it's a MAC filtering security method based on access control. Every device has a 48-bit hardware address, which I'm sure you know, and MAC filtering uses this to determine whether the MAC address that is attached to a device can access the network. We're going to use Packet Tracer because it's free and got lots of utilities, and we're going to use the following topology. So I've got Packet Tracer open. I'll click on Network Devices and Wireless Devices, and I'm going to drag this device here, WRT300N, which is a Linksys router, and I'm just going to grab a couple of laptops and just add them here. So left laptop, right laptop. So the first thing to do is install a wireless card into the laptops. We did this in an earlier lab, so I showed you how to do that and find out the IP address and the MAC address, but we'll just go through it now. So if you click on it and you can see physical, this is a physical representation of the device. You can see there's an Ethernet card here, so I'll turn the laptop off and drag it out, and I'll drag in this wireless card here. The wireless card's also up here if you wanted to drag it from here. And I just need to do that on the other side. So turn off, remove card, insert wireless, turn on, and then automatically you should have a layer 2 connection between the laptops. Now there's no IP addressing, so you can't ping anything, but the wireless connection is established. So the next part of the lab, we need to go to the GUI for the wireless router, the Linksys. We need to go to wireless and then wireless MAC filter, which is just here. So click on this, and this is what it would look like if you got it out of the box. So wireless, and then you've got a few options here. We're looking for wireless MAC filter. So this is a list of MAC addresses that are denied or permitted onto your network. At the moment, the disabled radio button's clicked, so we need to click on enabled. Note that you can have a list of denied MAC addresses or permitted. You can't mix it. because it's only a basic capability here. So for the moment we'll stick with the prevent MAC addresses, and then the left hand laptop here will need to work out the MAC address. You could actually click on wireless here and you could copy the MAC address. You could just highlight it and copy. Obviously you can go to a terminal also and type ipconfig all and you'll get the same address, 14C1 14C1. So same address. Just be careful, because when you go to your wireless router you can see we've got 8 separate values separated by colons, so we need to just adjust how the PC, the laptop, stores the MAC address or represents it. So we get rid of the full stop, so replace it with colons, and then we put a colon between each 2 characters. So this is the full MAC address here of the device we want to block. The only thing we need to do now is click on the save settings. If I move this across here, I want you to see the connection between the devices, because it re-establishes a connection very quickly. So I'll click on save settings. You'll see the connections gone down between both, but only one's come back up. So what's happened is this device now has been blocked on its MAC address. If I click on the desktop and go to PC wireless and connect, there's no information here for the site or the network. If I go to the right hand laptop, go to PC wireless, connect, you can see the information's in here. I'll put them side by side. There. So there's no site information here. We've got no wireless network name, channel or signal, and it's all filled in here. What I recommend you do is add a few more devices in packet trays. So you can add some more laptops, a server, and the other thing you could do is change it around. So what you could do is put in the MAC address and change this radio button to down here to have a list of permitted MAC addresses that you permit on your network, if you want to really understand how this works. Obviously, MAC address filtering also works on other devices. You could try it out on a Cisco switch if you wanted, or Cisco wireless LAN controller. I just wanted to keep it simple for the A+ lab. Welcome to our lab, Configure a Firewall. So just pop up where I got this from, pfSense. You can actually install on their hardware, or you can install on a your own hardware, or a server of some sort. So if you go to 101labs.net and then resources, you'll see some more instructions. I've got this in a virtual machine. You could obviously run it in your own home PC, but it's best to run all this. I've got a bridged adapter set up. There's more videos on I've got a second network adapter, sorry, as also called for the pfSense network. If you go to the resources page on 101 Labs, then you'll see how I set all these kind of things up. Bridge adapter for my Ubuntu machine, and a second adapter on an internal network for pfSense. So make sure you pause the video and go back and see how I set that up. My LAN interface here you can see is 192.168.1.1. This is the interface that the pfSense will be installed on and contactable by. There's a default username is admin and password is pfSense. To log into pfSense you can do so via a browser window. Now you may have a different IP address on your system, so that's why I've told you to check that window there to see which address you connect to. But I'll go to the browser bar and put in the 192.168.1.1 address. Now you may need to add a security exception to your browser just so you can get to the website. I think I had to do it for this because it doesn't have a certificate. And you can see I've got my two interfaces on the right here. There's a name for the machine. The 192.168.1.1 is on the right there. You can see the version, Here's my interface, here's my WAN interface. That goes off to my home router actually. Status of the machine. Here's how you get to the dashboard, which is where I am now, or where we're looking at. Alright, so if you go to Firewalls, Rules, and then WAN, you can see, there we go, over here, Firewalls, Rules, and then you'll get some choices, and floating firewall rules, your wide area network rules. Same as on a router, you've got interfaces you can apply all this to. And then our local area network. By default at the top, we're allowing 443 and port 80 to access our router. So the asterisk means anything. And then we've got a couple of default rules to allow the LAN anywhere. These obviously can be changed when you log into the machine and start doing your own configurations. So I've got a mini network built inside VirtualBox, and what I'm going to do is actually test the rules. So this is my Ubuntu machine, and I've just opened a terminal window. You can type in a search box for terminal, and it will open up a terminal window. And I'm going to ping my firewall interface. So 192.168.1.1, and you can see the ping is working. This will carry on until I hold down the Control and the C key. Now next part is I want to block ICMP. I mean, this is just a very simple test. So what I'm going to do is add a rule to the top of the list. I can add it to the top or bottom. I want to add it to the top, otherwise one of the allow any rules will allow it to work. So I can have pass, block or reject, and it explains underneath what that means. I'm going to have a blocking rule. This is quite simple with the GUI, to be honest, compared to Cisco. The protocol, as you know from your study guide, ping uses ICMP. There's different ICMP packet types, but we're going to block anything. Now the source and destination I've left as any for the moment, and I'm going to add a description. Obviously, please play with this in your own time. Click on save and apply changes there. Alright, so changes have been applied. Firewall rules are now reloading in the background. So what I'll do is I'll do the same ping test again, and you can see the ping's blocked. This was just a quick introduction just to how to install and configure the first rule on the firewall, but please, use it in your own time and have a play with it. Alright, so we've come to the end of the lab by the looks of it. Thanks for watching. Welcome to our lab. Restrict access via access lists. So this is another syllabus topic. Access lists can be applied on a whole number of different devices, firewalls, wireless routers. We're going to apply one to a Cisco router. So this is our topology using Packet Tracer. We'll have a couple of PCs, a switch so we can connect our PCs to our router. Our router interface will be numbered 192.168.1.1, and we'll have .2 and .3. So I'll go to my desktop. I'm going to use an 1841 router. It doesn't really matter as long as it's got an Ethernet interface. Here goes out of screen, sorry. If I show you here, you can see we've got fast Ethernet 00 and 01. Yours might say gigabit Ethernet if you drag one of the more advanced routers or newer routers on. So just make a change accordingly. I'll just drag a couple of PCs, a top one, a bottom one, and then I'll use just any switch would do. I've got a 2960 here, and then I'll find the straight through cable, and it doesn't matter as long as it goes fast Ethernet from the PC to any fast Ethernet on the switch. We're not doing any configuration on the switch, so it doesn't matter. And then finally the switch here to the fast Ethernet 0/0. Alright, so we go to the next step of the lab. Now we need to do a configuration on the router here. So you can follow along, you can pause the video or just follow along with me. So obviously need to go to the command line interface. Enable to get out of user mode. Config T is configuration mode. Interface F 0/0, fast Ethernet 0/0. You can see the output's changed. IP address, whoops, 192.168.1.1, and our mask is 255.255.255.0. The other thing you have to do is now shut the interface so it comes up. There's more configuration we'll have to do, but we'll worry about that later. The PCs are easier. Our top PC will have 192.168.1.2, and our bottom PC (1.3), and it fills in the subnet address for us. Now the next thing to do is we've added our IP addresses, so we'll ping the router from both PCs. So the top PC here, I'll go to a command prompt and ping the router. That's all working, and then the bottom PC, the same thing. Alright, so we've both got connectivity to the router, which is fine. Now we need to block one of the devices from connecting to our PC. There's a whole raft of things you could do with an access list, but I'm going to keep it simple. Oh, by the way, I changed the host name in the lab. It doesn't really matter, but you can change the host name if you want to follow that step. So I'm going to configure an access list. I'm going to deny the host 192.168.1.2, which is the top PC, and then I'll apply the access list. You have to create an access list and then put it somewhere. So back over to the router. Exit out of interface configuration mode. So access-list, you have to give it a number. I won't go into the details of why, it doesn't really matter. And then permit or deny. Well, I'm going to deny a host instead of a network, and I'll just put the IP address in that I want to deny. The next thing is I need to apply this access list somewhere. So interface fast 0/0, IP access -group. I don't know why you can't put access list. It's just the way Cisco get you to do it. Number 1. And you've got to say inbound, so I'll just put in. So I've configured the access list to deny that host, and then I've said the IP access group, number 1, inbound. So it should deny any traffic coming from this host here. So I'm going to go back to the top PC. I'll press the up arrow because I'm lazy, and it looks like the destination host is unreachable. That basically is an ICMP message, which is indicating to me that there's a firewall or access list blocking, which we know is an access list. If I go to PC1 and press the up arrow, my ping's still working. So IP traffic still working from this device here. Now any traffic I send from PC0 would be blocked because it's got the IP address that's being blocked. If you want, you don't have to because it's not important. I can type end here, and then show IP access lists -lists 1, and you can see you've got the access list and there's 4 matches, which was our 4 ping packets that were denied. Welcome to the WPA2 lab. You can do a few different security types with this setup that we're going to do now, including no security and advanced security. We're using WPA2 with TKIP. WPA is pretty much defunct now. So in the diagram we've got a router, an access point and this laptop. In fact, the laptop there is, we'll just drag it onto the desktop. We'll have to add a card onto it so we can access the access point. By default, the laptops have just got the Ethernet card in. I'm sure the ones we buy in the shops have got the wireless built in now. So we'll connect to port 0 from the router to the access point, and then just go through the lab here. We need to add an IP address to the fast Ethernet on the router here. So the router prompt, interface fast Ethernet 0/0, IP address 192.168.1.1, default subnet mask, and then no shut it. So here's the settings we want: 101 labs, the passphrase. I'll have to keep going back because my memory doesn't store that amount of information, I'm afraid. Port 0 is just leave it as it is. Port 1, this is where we can enable all of our security. So remember, the 101 labs is the SSID. This is what will show up on your laptop if you scan. WPA2 will put in a PSK passphrase, and then we'll change to TKIP for the encryption type. These are all in the syllabus. Alright, so the passphrase is the numbers 1 through 9. I'll turn off the laptop here and then drag in a wireless card and then turn it on again. And then we'll go up to the config, wireless, and we'll connect using the correct type of security. SSID, you'd normally be able to scan for these, and there is a facility on the desktop for you to use some software for that. But PSK, passphrase 1 through 9, encryption type. Just go back and change that to the correct encryption type, otherwise it won't work. Static IP address will enter 192.168.1.2 because we haven't got any DHCP on this lab. Just we'll make it too complicated. The default gateway I'll add is the router interface facing us. Now you can see the connection has taken place between the laptop and the access point. Don't think the access point allows you to see current connections, it's not that advanced, but what I'll do is prove the connection by pinging from my PC to the router. I'll just fix that. I put the wrong cable type in. I'm sure you noticed, but I need a crossover when I'm connecting to an access point. You can see it went green straight away. So let's try that again. Hit the up arrow. Alright, that's all worked. The clue was the little red marker on the interface when you looked at the diagram. Alright, so we've gone through everything here. Thanks for watching, and I'll see you on the next lab. Welcome to our TACACS lab. Quite a simple lab. We'll have a multi-layer switch with a PC at one end and our TACACS server on the other end, which will authenticate the PC before it's allowed to connect to the multi-layer switch. Everything will be in the default VLAN and all in the same subnet. So I'll drag up a PC. I will drag up a multi-layer switch, a 3560 there. and then finally a server which we'll use for the TACACS. So straight cable PC to switch, as I'm sure you know, and then server to switch, same again. The interfaces don't matter as much as long as you remember which one you connected to on the server. In fact, you've only got one, so we'll add the IP address 10.111 to the PC. Default subnet mask gateway is 10.1.120 if my memory serves me correctly. And it does, I can see it there. We'll create a interface VLAN 1, a switch virtual interface. By default, all ports on the switch will be in this VLAN 1, the native VLAN. Alright, so into config mode, interface VLAN 1, add an IP address, the default subnet mask, and you must no shut it, otherwise it will stay down. Alright, line VTY 0 space 15, these are the lines that we can use to telnet between devices, or two devices. So line VTY 0 space 15, so there's 16 lines in total. Log in, and I'll need to set authentication. We could do a local username and password. Call it myauth. And then we'll have a configuration for the AAA using TACACS. Always AAA new dash model will get us our TACACS and radio configs. Username will be Cisco, password Cisco. Obviously it's far too easy to use on a live network, but we'll put an enable password on this device so that whoever logs in can get into enable mode. AAA, I think I misspelled authentication, so I'll get an error. Login myauth. So annoying because it doesn't tell you as you're going along. You have to do it all again. This is why the tab key is so handy. Login myauth. Oh I hope I've spotted that typo. My org group I've put. Maybe I was having a bad day. As long as it matches on the other side. TACACS server host and the IP address of our TACACS server. We'll have a key as my key. And then finally we'll have to go in and configure the IP address and then the security settings for the server. We have to go to AAA and then enable it. Switch, the client name is switch, client IP 10.1.120. Secret key is my key. We're going to use TACACS, not radius. So I'll add that. Username Cisco, password Cisco. and we'll add that. Some other configuration goes on the switch again. AAA authentication, authorization, sorry. Exec default, this is the rights that the person has. The group is TACACS Plus, and we'll use a local username and password that they can log into once they're authenticated. We'll add the debug AAA authentication. You actually don't do that in config mode. And finally, we'll telnet to the PC, the switch from the PC, and we should get authenticated off the server. The typo won't matter because that's just a group name for the switch, so don't worry too much about that. Alright, and I'm on the switch, got into enable mode. That's all worked fine. We'll just see if there's any debug messages appeared, and you can see we've got the AAA debug messages appeared on the switch here. Show AAA, just hit the question mark, user, and you got type all 3 commands in. I probably won't do it now, but you can try them all. You can see that I'm connected from the PC there, and I've all been authenticated. Welcome to our malware lab. Malware is an umbrella term for a number of malicious software variants. It includes viruses, ransomware, spyware, malware. You can read the rest. I'll just scan a bit too quick. We're going to go to Icarus Security, which we can just search for on the web, or you can pause the video and look at the link. You can search for Icarus Security, test virus. Basically, we don't want to put actual malware on our PC for obvious reasons. It's going to make our life a misery. So we'll go to Icarus Security. They've got it's an authorized piece of malware that should trigger your antivirus. And then if it doesn't, then you can start doing some troubleshooting as to your settings. So the way I've got my resolution doesn't help. It's the left-hand side. Please read everything it says, just so you've got some information. And then you can click on the link to download, and you should get a notification. You can see it's scanning for viruses for this zip file. Couldn't download, and then Windows Defender pops up a message on the right. So now you can go to your security center, click on full history, and you can see the virus name, the date, the time, severe threat. You can click to allow it if you wish. It's a harmless file, but it's designed to trigger. And then for more details, you can look at the, again, the learn more, the web file, the file name, the location, etc. So I just wanted to show you how the Defender would detect malware. Like I said, it's a tough one because we can't actually, you don't want to put actual malware onto your machine. Do this obviously on a virtual PC. I just wanted to go through another piece of software that I've used over the years that's worked really well for me. It's from malwarebytes.com. This does a scan for malware and viruses on your PCs. There's a free version. Again, I'm putting this onto my virtual machine, and I'll just run you through some of the steps. So you'll download it. It's the usual way of downloading software. Just be careful that you get the free version. I'm just about to accidentally download this twice, so just ignore my mistake there. Yeah, it started downloading, but I didn't notice. Alright, so whatever operating system you're using, or browser, you'll be able to open it up and then do an installation. I'll whiz through this. I generally skip any extra extensions unless it's something I particularly want. Now, the unfortunate thing that seems to happen is it turns off part of your Windows security. So when I went to do the lab a second time, my Windows Defender wasn't triggering the virus scan. You can see detection history, scanner, real-time protection. I'll turn these off. You just have to bear with me because Windows throws up a load of notices. All I'm really interested in doing is running a scan just to show you how it works. This is a clean virtual machine, so it shouldn't have anything that throws up a warning. Alright, so go ahead and run the scan. It will automatically schedule scans, as you can see, and then it runs through these 5 lists. You update your memory, your startup, registry and your file system. When it's finished, I just scroll quickly forward. You can view reports, schedule some scans, look at any other reports for the other scans you've done. Welcome to our Bitlocker lab. So there's many ways to get there, but I'm just going to type manage Bitlocker, or you could just write Bitlocker. Now I've got a spare volume I want to do the lab on, so I'm going to go down to my E drive. You could do it on your C drive if you're on a virtual machine. I'll click user password to unlock the drive, and you've got to read and follow the instructions. It's got an upper and lower case, numbers, spaces, symbols, etc. Re-enter the same password. I'm going to leave off the smart card. It's a bit too much for our purposes. And click on next. Now you've got a few choices. You can choose more than one, so please note, especially come exam time in case they ask. Microsoft USB, save to a file, print the recovery key. I'm going to use save to a file just to show you this option, and you can obviously save it off onto another device also. So this will let you decrypt should you need to. You can print the recovery key, put it somewhere safe. I think the USB drive is the most popular option. Alright, so I'll click on next. You can obviously please go through those yourself. There's a fast way and then a longer way for your entire drive. I'll just leave the default options. New encryption mode, best for fixed devices. And then when you're ready, you can click on Start Encrypting. There's nothing on my drive, so it happens really quickly, but it could take hours if it's an existing live drive. Alright, so I'm going to go to my disk. Here, disk management, sorry. And I just wanted to show you it's saying Bitlocker encrypted, just so you can relate that output if you ever get asked about it. Now what you can do if you so choose is turn Bitlocker off. There's a few options there: back up your recovery key, take your password off, add your smart card. I'm going to turn Bitlocker off for the purposes of the lab, and you can see you can re-enable it. Welcome to our video on the limited user account. You'll start off by hitting the Windows key and going to Settings. And down to Accounts. Family and Other People, you click on that. May say something different depending on your version of Windows. I should have shown you the lab actually, sorry. We're setting up a limited user account because normally your account on your PC will have administrator access, which is how most hacking attacks happen. About 80% of attacks happen that way. So we're going to create an account so you can log in with limited access, so there could be no changes and software can't be added or removed. You'd have to log in as the admin, which is easy to do. So we're going to create a account. We don't have this person's sign-in information. We're going to click on that. So it isn't someone else already on our network. I'm going to add a user without a Microsoft account because otherwise I would need another valid Microsoft account, which is just too much hassle. So I'll create a username of a cat. We'll create the password and put it in twice, and the usual hints for security. So we've got 3 of these to go through. I'll just type a random couple of letters because we're not actually going to log in with this account. So this will be the account you could use from day to day. So the account shows here, and then if you want to log in as this person, you just go down to the Windows key and click on the users, and you can see the accounts there ready to be logged into. Welcome to our Configure Layer 7 firewall. We'll go to meraki.cisco.com, where we can actually access a trial demo version. You click on Get a Demo. You can put in an email address and a password and that kind of stuff, and they'll email you a authentication link. You can request actually trialing the gear, but for most of us, obviously, that's not going to be feasible. So you can start the demo. You just need to put in whatever details here in the registration page. Now this is just going to be a bit of a tour really, and then we'll just probably add a line of configuration because it's such a complicated process, and you could go away and do a training course to actually learn how to install and manage and configure all of this. So I'll just put in my details here, make up a phone number. Now I found the registration links actually took a while to come through, so you might have to register and then wait to go do another lab, and then eventually it'll come through the email that you click on. I think you can access it instantly once you've logged in, but you get limited access to some of the features. Alright, so this is the page you're taken to. A dashboard is the best place to go, but I recommend you click on all the links to see what's available. I go to configure and then firewall for the appliance. Alright, the firewall opens. You can see we've got layer 3 rules here. Outbound rules, failover rules. Just click on, just press on the information radio button. It will tell you exactly what each line does. But layer 7 further down, you can say there's no layer 7 rules defined. This device does a whole ton of stuff. You can see there's NAT and IP source spoofing protection. But this is where we want to be. The port forwarding, the layer 7 rules. I'm just showing you all the stuff that's available down the bottom here. Click add the layer 7 rule. Now there's a whole bunch of stuff you can do here for layer 7, websites and services, file sharing, gaming, productivity, the mind actually boggles. But we'll find something that's going to work for us. We'll go to online backups, and what we'll do is stop any backups to Backblaze, which is an online service I use, because this actually runs 24/7 and it constantly backs up to the cloud server, so it's going to clog up a lot of your bandwidth. And the other thing we'll deny is, let's have a look, video and music, and we'll deny them surfing, let's see, YouTube, because we want to spoil all their fun. You can actually use the crosshairs to drag to different priorities if you want, because it will go from top to bottom. We'll deny a certain host name and I'll just say 101labs.net. So that's a website that's actually blocked. When you're happy with that, you can save changes. Now you'll go back over to clients through your dashboard and find there'll be a list of clients. If you can click on any of these. You might as well just click on the top one. You might have a different list of devices when you're doing your trial. But you can see this person's got a MacBook Air. There's a whole bunch of statistics, IP addresses, and you can see further down here there's device policies. You can block someone if you think their device has been stolen, and you can show details of their firewall rules. Layer 7 firewall rule shows you that the device is blocking the 3 things that we configured for layer 7. So just a little play. You can have some more time yourself, but this is the end of the lab. Thanks for watching. Welcome to the Enforce Strong Passwords lab. So you're going to learn how to, as the title suggests, enforce or force users to have strong passwords when the accounts are created. So you can have all the firewalls and virus scanners. All this protection is negated if your password is cracked. So this is where the strong passwords come in. It would be something difficult to guess using manual and automatic password cracking tools such as dictionary, adding numbers and simple characters. So we'll use our virtual PC. In the search bar, type secpol.msc. You normally actually, let me try that again. I just wanted you to see what comes up here. Alright, so we'll go to account policies and then password policy. Click here. You need to ensure that store passwords using reversible encryption is disabled. So this is exactly what we want. It's set like this automatically. Otherwise, the way to decrypt them would be stored locally on your machine, which is something you don't want. So your password must meet complexity requirements. I'm going to double click this. What I recommend you do is read through what actually happens when you enable this. You've probably seen these before when you've joined different websites, saying how many digits, uppercase and lowercase, and non-alphabetic, it has to be included, etc. And there's also the security policy on the Microsoft website. But this is pretty simple to enable. You just click on Enabled, Apply, and then OK. And now you can see it's enabled. Now, if you wish, you can actually run a test. We can click on the gearbox for the settings. We'll go to Accounts, Family and Other People, and we'll create a new account, add someone else to this PC. I'll click on don't have this person sign in, so we don't have to worry about getting a login information. So I'll add a user without a Microsoft account. It doesn't matter what you call it. Test secpol. I'm going to put password all in lowercase. And then unfortunately you have to go through this step. So security question, I'll just type in any random letters. So I'll fill in these 3 policies. So I've got these here. I've got my username and my password just as password. I'll click on next. Alright, so we've got the warning. It doesn't meet the password complexity requirements set by the administrator. get the requirements from your administrator, and then type a new password. So you've been blocked. That's the end of the lab. Thanks for watching. Welcome to the lab on failed attempts lockout, another syllabus item. Type secpol, secpol.msc, and we'll click on the icon that appears. Go to account policies and then account lockout policy, and you can see some options here. Account lockout thresholds, so double clicked on. So it's defaulted to 0 invalid login attempts, and then we'll make a change. 3 tends to be the number I see mostly. So I'll click on apply. You'll be given a notification that you may want to change the other 2 settings, which you can obviously do. And there's some suggested settings also. Lockout duration and reset the lockout counter. So I clicked on OK. Duration, I think we'll make a change. No. And I've dropped this back now to 1 minute. I'm not saying to set this for the policy, I'm just showing you how to change the policy, obviously. Click on OK. Now I'll go to the user icon here. I'll sign out. I'll deliberately put incorrect details when I try to log in under my correct username. I've got other security settings on here, I think. So I'll have some security questions come up. This might be the Microsoft tie-in to the Microsoft website. I've got these settings elsewhere for my account. So if you wait long enough, as per your setting, you should just be able to log back in. This time I'll put the correct password. And I'm into my account. Very quick lab here, disabling auto run. I wanted to cover it off because it's in the syllabus. Windows Auto Run is turned on by default. It allows programs to run from external devices as soon as they're attached. Because malware can exploit auto run, you may wish to disable it. Windows Autoplay is a feature of Auto Run. Prompts users to play music videos or display pictures. Auto Run is a broader setting that controls actions. I'm a little bit too quick there, but I'm sure you can pause the video. So click on Windows Settings, Devices, and then the Autoplay buttons here. If you wish, you can just use the search facility, Autoplay, so you can disable it completely, the toggle button, or you can choose one of the options. Note that they're different for the memory card and for the removable drive. I think there's Windows Media Player is only available on the bottom on there, and you can't see it up here. Check the others also. I'm just quickly clicking on them. Welcome to our lab. Disable the SSID. So wireless networks are vulnerable to hacking. One of the easiest ways to protect it is to prevent your SSID from being advertised. So this is your wireless network name, which I'm sure you know. So we're going to drag a wireless router to the canvas and a laptop, and then we can attach a wireless card to the laptop. We did this earlier. So I'll go to wireless devices, network devices, wireless devices. I'll drag this WRT300M, a wireless router, and then PCs, I'll just drag a laptop. Laptop, I'll turn off, drag the wireless, the Ethernet card off. and put a wireless card in there, turn it back on, and then after a few seconds it'll boot and connect to the default SSID of the router here. Alright, so on the PC laptop, we'll go to the wireless icon, and then we'll look to the wireless connection here to see what the SSID is that we connected to. Might have to click refresh. I know it's auto-filled. So this is the name of the SSID, the wireless network name. You can see the channel and the signal, which is less important. So the name for the wireless network is default. So if I click on the wireless router and go to the GUI and click on wireless, you can see this is the name here. So what we're going to do, and the SSID is being broadcast, is enabled here. So what we want to do is change the name. I'll change it to 101 Labs. I'll disable the SSID being broadcast. I'll go to the bottom. I'll click on Save Settings. Now when I go back to the canvas, you'll see the connection is no longer enabled. And you click on the back on the laptop. I'll click on refresh and it should populate any SSIDs that are present. In fact, what you could do, if you wanted, you can do this in your own time, is drag another wireless router with the name default, so you can see another SSID being advertised. I won't do it here. You can see there's no network name advertised. Now if you wish, you can do a little test on the lab. You can click on Enabled, click on Save. There's no authentication, so it'll automatically connect. And I didn't have to click refresh, it's populated it with the new SSID name. Welcome to our lab on WPA2 TKIP. TKIP and AES are two encryption types that are used on your Wi-Fi network. TKIP is actually an older encryption protocol introduced to replace WEP. No longer considered secure, it's now depreciated, but it's still in the syllabus. You can do this lab again and replace TKIP for AES. So we're going to have a laptop and a home wireless router in Packet Tracer. We've done this before, but I'm going to do it anyway. Turn the laptop off, drag off the Ethernet, drag in the wireless card, and turn it back on. On the router, select GUI, wireless, and wireless security. Here you can choose the security mode and set the encryption to TKIP and then select a passphrase. I'll just say password. Click on connect and then refresh to see your SSID being broadcast. The SSID name is default. You've got to save your settings. On the canvas you'll see that there's no connection. On the desktop, on the physical config wireless, we need to choose our authentication type. You want to choose WPA PSK. Down here, encryption type, we'll choose TKIP. Now there's no save button on here, but that's fine. Go to the wireless card and check the security type for your connection and that the signal is received. I think I left my default SSID. I haven't changed it. Yeah, the name's default. So this was from an earlier lab. I had it as 101labs.net. So you should see a connection appear, and then we'll go to our laptop. Desktop PC wireless. Connect, and you should see the connection appear, the security type, and the channel signal, and the SSID. As I said, you can repeat this lab with AES if you so wish. Welcome to our lab, a wireless access list. So every home wireless router allows you to filter basic traffic based on the port, time of day, etc. They also, many of them offer time-based access lists. So for example, you could prevent your children from accessing the internet during weekdays or later on in the evening. It's the same topology as before. We got a laptop and a home router. This wireless router here. Add a wireless card to the laptop like you did earlier. And then on the router, select access restrictions. You can leave the access policy as number 1. We'll give the policy a name block ping. Then we'll click on enabled and we'll set never. And then in the list of applications, we'll click ping to be added to the list of block protocols. So we'll do all this slowly. Over to access restrictions. We'll give it the name. Block underscore ping. Click on enabled. So we'll add a device. You can add MAC addresses if you want, because obviously the IP address changes. I'm going to add 192.168.0.2. We want it to be never allowed. This is where you can get caught out because they can actually, depending on how they word it, it can do the opposite of what you wanted. They're not very user-friendly. Alright, so this is a list of blocked applications. We're looking for ping. Obviously, if you're doing it for home, you'd be blocking web access and any port numbers for live chat, for example. So I'll just do ping and I'll click to the list here and then save settings. Now I need to add an IP address to my device, so I've got a static address here, but I'm going to add, click on wireless here, I'll add the IP address 192.0.2 on my wireless. If you go to setup, you can see your IP address is 192.168.0.1. So I should be able to now go to desktop, get rid of that, go to a command prompt. Okay, so destination host unreachable, which we know it's because of the access list added onto the wireless. Now what you can do if you want is disable the access list, save the changes, and then all things being equal, the ping should work. Very short lab, this one. I'll skip some of the steps, a home router and your PC. So we've done a lot of this stuff earlier, but what we want to do is go to administration and enable remote access. So instead of having to physically be at our network device, we can connect to it over our network, usually using a web browser. So I've already got this set up from an earlier lab. My wireless router, administration. Now, because this isn't an actual router, a lot of the options that we want, for example, to force HTTPS are disabled. I want to enable remote access, remote management. There's a password. I'm not sure what that would be, but you can choose your own anyway. Save changes. We know from earlier the IP address for this device is 192.168.0.1, and in an earlier lab I added an IP address to this machine, 192.168.0.2. So what we want to do is, now we've enabled it, you'll normally open a web browser, same for your home device. Add the IP address of your device in. You'll know that from your, either from the manual, or if you go to your ipconfig command, ipconfig all, probably you'll see what your default gateway is, which will be your home router. I think, is it admin? Yeah. So now I'm on my the graphical user interface using my web browser. I'll have a quick tour of a UTM appliance that I managed to download. I'm in my virtual machine. Click on import appliance, and I downloaded one. I'll give the details in a moment. It was my distributions. So they're called Corrigan Lite. You can Google that name, but basically it's a UTM that you can run on your own servers. I think they have their own boxes as well, actually. So just scroll down here, just click on import. I think there's some videos showing you how to import it also. So you could basically in your virtual machine run your UTM, and you can see it's appeared down the bottom here, it's powered off. So I'll click on it and start that appliance. There's a warning just come up I just need to get rid of. Alright, so I've gone to settings, which you can do by right clicking, and it's gone to internal network. I think I just had to restart the network card settings. You saw the setting there, internal network. Now this is just a little bit of a tour. You're not going to be an expert in this by any stretch of the imagination, and the instructions were awful. So this all booted up, and in the background it's got the website for the software if you ever want to download it. Alright, so I've gone to the URL that will be applied to that device on port 10443. I needed to add an exception to get it to open. This actually comes with the documentation, which was a bit of a pain to read, to be honest, but the IP address of this device, the virtual device, and then the port 10443, HTTPS, and finally it loaded. And the username and login actually comes with the instructions, admin, and I'll write it down here, Komodo. So there's a PDF that comes with the software if you really want to navigate through it and have a play. And you come up with this GUI that allows you to manage the device. You can see there's the Ethernet cable plugged into one of the ports there. console, power, USB, and on the left you've got all of your options that you can choose from and configure. So you see the hardware information. Down here you can see the IP address that's for the uplink. SSH access if you want to configure that for the device, and you can expand and contract all of the different settings here. Network status. Again, hopefully you'll be able to play with this. It's a shame they don't have a version on their website that you could just log into and use. The interface configuration for various ports, and we can see the net mask for our LAN port, which is the port that we connected to via our web browser. And then you can edit all of these different settings if you so wish. This is all your routing. You can see proxies, VPNs, firewalls, whole bunch of stuff. Hence the name. Static routing. You can add a new route if you want to have static routes on your device. You can set up DHCP, dynamic DNS, connect to a time server, spam training. Very useful for small to medium-sized businesses that just want everything run off one device. Now you can update the rules if you wanted to. I actually tried to do this. It was just quite complicated and fiddly, and then even harder to run a test because we're running off a virtual machine. But you do your firewall objects down here. Add any virtual IPs. Your proxy settings here, which I think is one of the items actually on the Network Plus syllabus. Proxy server, do check in case it changes. But anyway, that's how just a quick brief tour. Please do it in your own time. That's the end of the lab though. Thanks for watching. Welcome to our lab. Configure Windows Firewall. This could obviously be a whole course in its own right, configuring firewalls for any vendor or software or hardware. So we'll just do a simple rule, and then as always, please make your own rules up and have a play. So we've got two computers connected. They should be able to ping each other. I've got them running in a virtual machine. And properties network, I've got them on a NAT network, so they're both on the same network. So you should be able to ping from one to the other. Now don't worry if your IP addresses are different. That isn't the point of the lab. CMD. The point is that you can ping. So IP config. So this one is 10.02.11. This one's 10.02.13, so this will be the one that's going to be blocked. So I'll ping 10.02.13. So that works. So what I want to do now is go over to my machine where I'm going to have the firewall. As always, there's a number of ways to get to this. You could go through your settings or your control panel. Alright, so let me resize this, sorry. So what I want to do, have a look through all of these yourself, by the way. There's a whole bunch of things that you could be asked questions on. I'm only covering just one bit of it. So inbound rules, you can go over here and new rule, or right click, new rule. There's a whole bunch of things to choose from. You can test ports later on yourself and programs, etc. I'm going to click on custom rule. I'll choose all programs. Now what I want to do is choose a protocol type. Well, we're going to do ping because it's the easiest thing to test. And if you've read your theory, you'll know ping uses ICMP. We're not going to do an ICMP v6 ping. So I'll choose that. I'm not going to change anything else on the ports. Which local address should be any local address. Any remote address. So this is our remote host. So I'm going to click on the bottom button, click on Add. I'll put 10.0.2.11, which is my remote host over here. This one here. So I'll click on OK and then next. What do we want to do? Allow it, well, it's not going to work for our test or the middle one, so we'll choose block the connection. Leave these three as the default, the domain, the private and the public. Let's give it a name. Always choose a name that means something when you're looking through a list of your firewall rules, and then you can add a description if you want. And that's that finished. So you should now be able to see your firewall rule here. And you can scroll across to look at the summary. If you want, you can right click it and you can disable it, delete it, copy the rule, and you could copy it and rename it. Properties, you can make alterations in here, which we're not going to do. So the next thing we need to do is run a test. So I'll ping the remote host. So the ping worked. Up here you can see the ping worked. Now I've added the access list and the ping has been blocked. It's giving you a timeout. Welcome to our lab on disabling unused ports. So we'll learn how to do that very thing. So your network at work will have many available ports for employees and even visitors to connect to. These will connect to your workgroup switch, giving your user access to the network. So as the administrator, you want to protect any unused ports. So we're going to drag your 2960 switch onto the canvas. And we'll do a configuration on these switch ports to give you some added protection. So if somebody does plug in a device or even another switch, and they won't get access to the network. So we'll create a high VLAN number, which is going to be an unused VLAN. So we'll go to the enable mode. I'll type EN for short and then CompTIA for configuration T. And I'll just type VLAN 999. That'll create the VLAN number that we can put any unused ports into. And if you want to change that later on, if you want to have more ports free, then we can do that. We're going to make any unused ports access ports. We don't want any ports to auto-negotiate or possibly become a trunk. So we'll go interface range F0/1 to 10. This is a handy way to stop you having to do extra configuration. Switch ports mode, I'll do question mark. You can see we've got access, dynamic and trunk. Normally they're set to dynamic depending on your model. We don't want that. We don't want any danger of it becoming a trunk link because it could cause a major issue on your network. Manually placed all unused ports. I'll just fix that because we've already actually did that and there's an incorrect command on there. So follow what I do, not what you can see there, and just forgive me while I make a quick change. So the command we're looking for is switch port, not that command, sorry. Switch port access VLAN 999. So what this is doing, we created the VLAN. Then what we need to do is put all of these ports that we're configuring, fast Ethernet 1 to 10, into VLAN 999. So this VLAN won't be connecting to anything else on the network. It's a logical network in its own right. Now you could issue a shutdown on those ports if you want. I didn't do it, but you could just type shutdown, which manually closes them. And I'll type end and then I'll issue the show VLAN brief command. This will show you your VLAN numbers and which interfaces on this switch are entered into the VLAN. I'm going to discuss port forwarding now. Port forwarding enables you to specify which port NAT will use when traffic is coming into your network or leaving. So you've got this topology here, as you can see. And we've got a web server, so we don't just want any old port to be translated, because it's obviously going to be coming in on port 80 requesting the HTTP service. So if it got translated to a random port number, then the web traffic wouldn't be encapsulated correctly. So we'll connect our server, which I dragged, our packet tracer server, I dragged from the bottom there onto our canvas. We've got a router, and then I'm connected the fast Ethernet interfaces to the PC there. So the PC, you'll pretend, is the host on the internet coming in. Again, corrected on the fly. Sorry, I just noticed a small typo in the configuration there for the book. So I'll add a static IP address to the server, 172.16.1.2. Default gateway is the router IP address closest to me, closest to the host. Services, let's turn on HTTP, and there's a default website there that can be referenced. We go down to the configuration, the PC is 192.168.1.2. Default gateway is our closest host, or router interface, sorry, not a host. So now the host knows where to send the traffic. And then our router, we need to do our IP addresses and configure any NAT which is going to take place on the router. So the host name is router 0. I don't suppose it really matters because there's only one router in this lab. The IP address 172.16.1.1. So this is going to our server side, and then over to our host side 192.168.1.1. We need to no shut the interfaces as usual. Oh, looks like I forgot to issue the no shut command there, so we're going to have problems in a bit, but luckily, or hopefully I'll do a ping. Yeah, I can see we do the ping test here. This is why it's important to do it, because even though I keep telling you while I'm configuring these labs I can get distracted or just forget, being human. And if I waited until we did the NAT part of the configuration, then we might end up troubleshooting our NAT config, which there's nothing wrong with the NAT. So no shut it. You can see the command there says changed interface to up. And I've issued the ping there and it's worked this time. So over to the next bit of the config, if I scroll down. So our IP NAT inside source static, and you can see we're doing a static translation, a particular IP address to a particular port, and it gets NATed to a particular IP address and a particular port. IP NAT inside source, and it's a static. There's different commands we could choose here, but just static. And we're going to choose our inside address, no, TCP, sorry. Our inside address 172.16.1.2, which is our web server. What port do we want? Well, we know it's going to be port 80. And we're going to NAT it to normally be a routable address, but we're not going to use a routable address. 10002 port 80. I put a typo on that diagram, sorry, so I'll fix that when I come to do the diagram and print the book. But the configuration's perfectly fine anyway, so we can work from that. So IPNAT inside on our inside interface, IPNAT outside on our outside interface. And we can do our test in a moment. So let's go to our PC, open up our web browser, and we'll browse to our the address that would be advertised, 10002. Go, and that's worked. It's been NATed from our router to the non-routable address on the inside. You can do some show commands on the router if you want. You've already seen those. So that's the end of the lab. Thanks for watching.
Welcome to our lab, Securing Data with Encryption SSH. In this lab we'll learn about OpenSSH, a common tool for creating secure connections and tunnels to and from Linux servers. So the first thing is we'll install the OpenSSH SSH server, and then we'll go ahead and run some commands. So we'll copy the public key into authorized keys to allow yourself SSH access with the following command. Finally, get your machine's host keys with the following command. Save the bottom 3 lines somewhere. These are your host keys fingerprints in different formats, and you'll use one of them later. Now run the following commands. Top your password. This will cache your SSH private key to SSH agent, so you don't have to type the password again during this session while maintaining its security. Finally, connect with SSH localhost. You should be prompted to confirm a previously unknown host key. Compare this key with the 3 host keys you saved from task 1. One of them should be a match. If not, something's gone wrong. Assuming so, confirm the connection, and you should now be connected locally over SSH without having to type your password again. Run exit and then SSH localhost again, just to be sure you can connect with no prompts. Now run the following commands. And we have to type our password in again.
So let's look at security, in particular IP tables. We'll learn how to configure and view the rules for IP tables, which is the standard firewall for Linux. So we'll open up the terminal for our first task. We'll run sudo iptables-nl and we should receive some output similar to the below. If you do see any firewall rules or policies other than the default, except as shown as above, the filter table only, you'll need to start with a clean slate. You'll run the following commands to reset the filter table to a default state. If any of the rules were changed here, you can typically get back to your system's firewall rules by restarting the IP tables or firewall service. On Ubuntu, it shouldn't be necessary to do this. Now we'll experiment with firewall rules and ICMP. First, make sure that you can ping your local system. So this is your loopback address. I'm sure you're familiar with it. You should quickly get a response indicating success. Now add a firewall rule to filter the input chain to drop all ICMP, and then after that do another ping. So this time you'll have to wait several seconds for any output. Output should indicate that no response is received. As you would expect, your local firewall will simply drop the request, never sending a reply. This isn't the only way firewalls can block traffic. So we've got another input and then another ping test. So this time your response is destination port unreachable. Your machine has explicitly rejected the ping. As a special exercise, can you figure out what the following command here is, what flag is required? And then finally you can delete the rule. It's quite common to add rules to the input table, less common to do so on the output table. Doing so is a good security practice. We're going to add a reject rule, and then we're going to do another test. There's another exercise if you want to have a go, and then finally you can delete the rule. Welcome to our lab, UFW, Uncomplicated Firewall. We're going to learn how to manage UFW and a few more user-friendly ways to configure IP tables. So in this lab, we'll practice using UFW as an alternative way of managing our Linux firewall rules. Step 1, we need to make sure that UFW is enabled. Now by default it's not. This could change over time, but so do check your release. So sudo UFW enable. Let's confirm. Now let's take a peek at the firewall rules that have been set up. So if you did our earlier lab, you'll have a pretty good idea of the sparse rule sets that your OS has set up by default. If you enable UFW, it does make a lot of changes. The rules aren't terribly complex, but the way they're presented makes it pretty difficult for us to analyze. So you can see the output. You can modify it slightly with the following command. Syntax for adding rules is pretty simple. We'll go through a few commands. It's not obvious from the last command, but UFW has added two drop rules, TCP and UDP, for the user input chain. You can also add rules based on profiles, even accounting for those applications changing their listening ports. Finally, we'll do some housekeeping and clean up, and we're going to run a few sudo commands. Welcome to our lab installing Active Directory. So we'll learn how to install it. I've downloaded a version, I think it's a trial version of Windows Server 2012. I think really download that, the evaluation onto VMware or VirtualBox, because the steps will be slightly different with different versions. So you'll install that and be asked to set up an administrator account and all that kind of stuff. So I'm not covering how to install that Windows server. There's plenty of videos I think online for that. So you'll have your administrator account and then you'll log in, and then we'll change the Windows server name. We'll set a fixed IP address. So we'll go into Server Manager. That boots actually when the server boots. Now I'm going to keep swapping backwards and forwards between the written lab and the live server. You can send a Control Alt and Delete, I think it is, through your keyboard settings there. This is in VirtualBox. So you'll notice I'm logging in just to the administrator account. It doesn't say anything else. This will change later when we configure our domain controller. So the Server Manager boots is just down here, the little suitcase icon. Just ignore any warnings you get. This obviously isn't on a proper network, so it won't act the same as it would on a live network. So you can follow along or just sit back and watch and then follow along with my steps later on. I've got NIC teaming, so my Ethernet adapter's actually got a name instead of saying Ethernet. I did this for a Network Plus lab. So I've changed some of the icons, so I'll click on the computer name. I'll click on change. We did this before for our other work group. And as I said, I'm going to be showing you the steps because I've got screen captures also, which I hope makes it a bit easier to understand and follow along. So I'm typing DC1. So this would be domain controller 1, and then if you added another one, DC2, DC3, and so on. So you get a warning saying, well, needs to be restarted before any changes take effect. I'll leave the work group as work group. I'll restart my machine. I'll pause the video as that all happens, and then go back to my local server. I'll just click underneath the dashboard. So you can see my computer name has changed. Now we're going to change the IP address. Depending on how you've got this set up, if it's on a NAT network, then you'll need to change it to whatever it's enabled, but make it static. Click on the yours will probably say Ethernet. Mine says 101 team, as I said, because it's the I've got NIC teaming. So you'll probably be configuring one of your interfaces. Obviously, you can use ipconfig, and it will tell you your device. I think possibly ipconfig all, but it'll tell you where your IP address is allocated. Now I've actually set my network as a internal network, so it's down to me to configure my own IP address. So if you have the book, you'll just see a few little changes. It's nothing to worry about. There's a couple of ways to get to the same window as well, so forgive me if I'm right-clicking instead of double-clicking, etc. So these are the details I'm looking for. I'm going to hard set my IP address. I've clicked on the Ethernet card, or the equivalent. Mine says a 169 address, so it's auto-allocated its own address, which obviously won't work, not a routable address. So we're going to do 192.168.112.136. We'll set a default gateway that isn't actually on the network, of the same subnet but ended in .2. So you close the windows and click on Properties. I did a right click. So I unticked IPv6. And for IPv4, I want to use the following IP address. I've put it into Notepad just for my own convenience. So at the moment it's trying to get an address via DHCP. I set this in VirtualBox as a internal network. I don't really use VMware much, so they'll have an equivalent setting. If you already have an IP address, then you just manually enter one. You're just going to make sure the host on, if you're using a host on the other network for any testing, it needs to be in the same subnet. So there's my .2, and I'll use the same address for the DNS server as the default gateway. Now as I'm going through the steps, I'm actually replacing a lot of those images and zooming in, but you can see me doing on the actual equipment. So I think it was OK, you click on, and that's made the change to the IPv4 address. You can check with ipconfig. You just click on the Windows, right click on the Windows icon and go to Command Prompt and just check that your settings are correct. So into your local server, you'll see your IP address. I'll just shut this window down. You may need to reset the screen. There's a little icon on the top to reload the screen. Next is firewalls. Scroll along. Oops, yes, i.e. enhanced security configuration. We'll click on that. We don't want our firewall to block certain types of traffic, so we'll go off. Obviously, we're not working on a live network, so things would be very different on a live network. I'm going to click on Remote Desktop. You want to allow remote connections to this computer. So I'll click on the radio button, click on OK, apply and OK. Whenever you change something, as I mentioned a minute ago, you can click on the refresh button. Just up here, which is pretty standard icon for reloading, refreshing. You'll see remote desktop is now shown as enabled. I'll let you from another PC on the same subnet remote in using remote desktop. So I'm not going to go through those steps in the videos because the video is going to is already over 22 minutes, almost 22 minutes. So you can skip that step for now or go in later on and just remote in. So we're going to select automatic updates. So click on download updates, but let me choose just from the drop down window whether to install them. Tick on the 2 arrows. Now I'm not going to click on OK because I don't actually want to spend an hour waiting for updates to download, but this is a step you obviously would do if you were installing a new server. So you can see the windows here, adding the updates and then asking which you want to install or not. Obviously for security it's really important that you regularly take these steps. You'll need to reboot anytime you install new updates. I can skip that step. Okay, so we're going to go to our firewall. It says public on. You can click on the arrows to drop down to get more information. So you can see what's on for private networks and public networks. It's blocking all connections and blocking all. I'm just going back to the lab to confirm what settings I set up in the lab. Click on turn Windows Firewall on or off. Then we're going to turn off the private and have a turn on and notify for public. Again, this is only for the purposes of doing our lab, so I have to keep reminding people in case they're at work and been asked to configure a server. You wouldn't be following some of these steps for live server installs. So close that window down. You can pause the video. There's a little introduction as to what Active Directory is and a DNS server. Hopefully included any theory you're studying. So I'll click on Manage, Add Roles and Features. Read the notification again. I'm not going to read them all out to you on the video because you'll be following these steps yourself. Click on Next. I'm going to leave the role-based as role-based. You can see I've got my DC1 server here. Obviously, if there's more than one server, you'd have more than one to choose from, but I've just got this one that I want to configure. I want to enable Active Directory domain services. I think when I did this, I thought I'd clicked on it, but it didn't add the features. Yeah, that's right, I didn't click on add the features, but I'll go back and fix that in a bit. We want to enable DNS server, just have to click the back button. And this time I remembered to click on add features. It's just to a bit discombobulated and going backwards and forwards between the labs, and I'm also capturing screenshots to improve the lab document. So go back in and turn on the Active Directory domain services, and this time I remembered to click on Add Features. Get a warning message in a moment. Don't worry about it when you see one. So I clicked on Next. There's a tick button at the top you can enable to restart the destination server automatically if required. And click on Install. Tools menu, we're going to go to DNS. Pause the video again. We just want to look at the forward lookup zone, reverse lookup zone, and creating them. So Tools menu, DNS, and again, please pause the video, and if you haven't already, should have learned all this in whatever theory course you're taking. So I clicked on the DNS on the tools. The forward lookup zone is a little bit funny. It doesn't let you click on new zone straight away. I don't know why it didn't do it. But I went back to exactly the same button. And this time it's not grayed out. Go figure, as they say. So click on Next. So forgive me while I just grab a screen capture. So we want to go to primary zone and then click on Next. So name lab.local. Lowercase. It'll say, do you want to create a new file for this file name? We do. Do not allow dynamic updates is selected by default, I think. Yes, so that's fine, we can leave that. And then click on Next and then Finish. Now we'll create the reverse lookup zone. Same deal, we're going to right click on the reverse lookup zone. And true to form, it's grayed out, quite annoying, and now it appears. Don't know why that happens. But it's good this sort of stuff happens when you're watching, so you don't think you're going mad or you've missed anything out. Primary zone. IPv4 reverse lookup zone. You only need the first 3 octets of the IP address. So 192.168.112. Went over to Next. We'll leave do not allow dynamic updates. We don't need to change anything. Excuse me. You can see the summary of your configurations. So we'll finish that. Now you can right click on the reverse lookup zone that's created, click on all tasks and then reload. And true to form, doesn't work first time, at least it's consistently missing. And obviously we're going to click on yes. Alright, so we need to promote this server to a domain controller. There'll be a little warning triangle should have appeared in your server manager window. Here. You may have other warnings apart from this. So we'll click on add a new forest. The domain information lab.local. Put in a password, there's a suggested password at the bottom there. I'll pause the video because this took a while to take. So enter the password twice as usual. Don't worry about that warning message. NetBIOS domain name is lab or capitals. Leave the defaults here for database logs, etc. And you'll see a summary. Next. It's warning you there the server is going to reboot. You've got a few warnings. Again, this will take a while, so I'm going to pause the video while the changes happen. So here's just a heads up that when this is from the lag document, you'll be signed out and then you'll have a fully functional domain controller with a DNS server with Active Directory. And you should see that the login is changed to a domain name, which is lab / and then the administrator account. So that's what's happened. It looks like I'm being prompted to change my password, so I'll do that. And then we'll log in. Welcome to the lab. We're going to look at organizational units for Active Directory. We created a domain in the last lab. So we'll work with Active Directory at the domain lab local we created before. So I've got my Windows 2012 server. So our domain controller is now Active Directory server, as you can see from the image, and I'll just go to the server. Active Directory here, just move it. Should be covered in whatever theory course you're doing, but Active Directory is a database where all the system stores the information about built-in accounts, users, groups, organizational units, devices, and a lot more. You can definitely dip into, well, not even dip in, take the Microsoft server course. If you're interested, there's a MTA for beginners, Microsoft Technology Associate. They've scrapped the MCSA, the MCSE, so have a look at the Microsoft website to see what certifications they're offering if it's something you're interested in. So to access the Active Directory snap-in, click on Tools, and then Active Directory Users and Computers. So in the left pane, you'll see the different folders that represents the structure of the Active Directory users and computers. As the name itself suggests, we store all the users and computers information. If you go back to the Tools menu, you'll see that there's other Active Directory databases. Each and every one of these Active Directory databases has a different meaning and use. For now, we'll concentrate our attention on the Active Directory users and computers. So what is a built-in account? In Microsoft Windows, the built-in user account is the type of account that is created during the installation, so it's created by default. Example is all computers running Windows 7 have two built-in user accounts, the administrator and the guest account. So in Windows Server, you'll find more than two built-in accounts for obvious reasons, hopefully obvious if you've read the any of your theory. So backup operators, administrators, and there's a description here as well, which you can expand. I don't expect you need to know all of these, but it's worth knowing a few of them, I'm sure, especially the backups, the guests, the administrator. As an example, members of the administrator's built-in account have complete and unrestricted access to the computer and the domain. You can assign rights to these users in your organization if you know what to do, and then you'd have full rights over the whole domain. What I mean by that, is you can assign the administrator rights to any account. If you have a printer operator which is only to have access to the printer queue, then you can assign these rights to this user and it'd only be allowed to use the printer and nothing else. So these are just some examples. Sometimes the administrator needs to create a special group to have more control over the rights assigned to the members, which is the users of this group. Active Directory is a fantastic tool which helps an organization create their own organizational structure by knowing who is who and what they're allowed to do inside the organization. The same concept goes for computers. Now, not every computer has to be allowed to join the domain. The administrator can remove a client, delete it, or recreate it. So if you click on computers, you'll see that at the moment there's not a single computer joined into our domain. Under domain controllers, you'll see we'll find our domain controller, which is the only one that we have at the moment. The Foreign Security Principal, the FSP, this is an object created by the system to represent a security principle in a trusted external forest. These objects are created in the FSP container of the domain. They can be added to the domain local security groups and granted permissions. Foreign security principal objects can also represent special identities such as authenticated users, anonymous, logon, and enterprise domain controllers. The FSP for a special identity is created when the special identity is added to a group. This allows them to be granted permissions. Each FSP object is essentially a placeholder that holds the SID of the foreign object. Using this SID, Windows can resolve its friendly name using the trust relation when it's needed by tools like Active Directory and computers. I'll let you pause the video rather than reading it all for the SID. The user database keeps records of all the users of the domain as shown below. The administrator account is present everywhere, and there's some other users, for example the domain users. Each user has to at least be a member of the domain user group to be able to use the domain. So if you imagine this scenario, you've got a company with two different departments. You want to distinguish each department. For this reason, you'd create groups and organizational units for each department. And then inside these groups, you want to insert members and grant them different rights. So your hierarchy at Active Directory goes organizational units, group, and then users. You first create a new OU, and then inside the OU you create a group, and then inside this group you create your new users. So if you wanted to go ahead and do that, you right click on your local lab, you select New, Select, and then Organizational Unit. We'll give it the name USA in capitals. And we'll do the same, and the next one will be Europe. Next we create a new group, human resources inside the USA OU. So if I click on USA now, you can see my group. So some other groups to create, which I'll let you do. Under USA, we're going to create marketing. Under Europe, we want IT support and customer services. The next thing we want to do is create users. So we can right click on users, select new, and then we'll create a user as shown below. Ray Charles, R Charles at Lab Local. You click on next, you'll create a password for the user, and then it's up to you what you'll do as administrator. You'd normally send them the default password and then they have to change it. User cannot change it, password never expires, etc. Probably would never tick that, to be honest, but if you're doing a home lab, I'll leave that choice up to you, obviously. So Ray's been created. He's got no rights at the moment. We haven't allocated any. You can create some more users here, by the way. So now that you've created user accounts, like I said, there's one for Bill Gates and Ginny Rometty, Uma Thurman, whoever. And now that you've created the user accounts, you can proceed to add these users to their groups. So you can right click on Ray Charles because that's the first one we created, add to group, and then we're going to add to the human resources group. I'll let you create the other users and add them so you can just get used to the process. So in this lab you learn how to work with Active Directory users and Welcome to our lab, Domains for Active Directory. So we'll learn how to join a client to the domain that we created in the earlier lab, the lab local. I've got a Windows 10 PC and a Windows 2012 server. I'll just show you, I've got this set up in VirtualBox, and each machine, if you click on Settings, Network, I've got it set to an internal network. Now, what you could do is have a NAT network, so you get an IP address off your home router if you're at home, but we had to hard set the IP address of the server because it's issuing DNS information. So both are set to internal networks, so you basically have to go to the network card and add the IP address. So back over to the lab. You can pause this. Basically, I just want to explain what a domain controller server does in the context of Active Directory. So you can pause the video. I've decided not to read out all the theory parts that I've put in here for convenience, because you can read it for yourself. The benefits of a domain controller. So there's a few there. Again, this is generally covered in whatever theory book you're reading. So we're going to join a client to an Active Directory. Again, you can read this. If the user is found, he'll be granted access to the domain, otherwise denied. So we're going to use one of the users we created earlier. So if we go to our server, Active Directory users and computers, and we click on computers, this should be empty here for you. So basically only a user with the admin rights can join a new client to the domain and no one else. The administrator will prepare the domain to reflect your company policies, for example creating a login script, user machine to network to printers, mapping the folders, etc. So before we can proceed to join the new client's machines at our DC, we must make sure our DC is reachable through its DNS name and IP address. So since we created a new DNS server, we need to set this up before we can proceed further. If you go to the network setting on your server and set the IP address for the DNS server, I'm not sure if we did this earlier actually, it'll default to itself here, so we need to change it from the loopback address to its own IP address. So I'll get that open in the server. So let's change down here. My keyboard's playing up, sorry. You can, if you want, add an alternative DNS server. A lot of people use like a Google one, so you could do 8.8.8.8. I won't add it here because I'm on an internal network, so I've got no internet connectivity for this lab. Click on OK. Close. You may need to sometimes click on Disable, and then when you right click again, say Enable for that address to take. Alright, so I right clicked my card, I disabled, then right clicked and enabled. Over to my Windows 10 machine, I did a IP config command here just so you can see it. I added the IP address 192.168.112.131. It added the subnet mask for me. And then I went ahead to a command line and just did a ping to the DC, and I got 4 responses. So we've proved off our IP connectivity. So if we don't join the domain controller, it won't be because we don't have an IP connection. I say that because some people who are new to networking forget these steps. Even when I'm doing Cisco books and labs, people forget the basic bits. They're trying to ping when there's no cable attached, and we've all been there anyway. So you can do the ping. Now we'll proceed with the join of our first client machine inside the domain. Power on your Windows 10 client machine. Now you log in as administrator. My account actually has admin rights, so I should, all things being equal, the account on this machine is the administrator. I know I did an earlier lab where you could create a user account, but I'm guessing that you're still logged in as the administrator because you put together this machine yourself. So click on Start, Type Panel, we'll get our control panel open, and category, we're going to small icons. So I typed control panel down here, got the control panel open, category, small icons. Then we go to system. Now if you follow the labs on from the beginning, you'll have a computer name here. If you jumped in here just to do the Active Directory, you'll have a random name, and the work group will be Workgroup in capitals. So we want to change our settings. On the next screen we click on Change. We've done this before actually with our other lab joining the work group, which is why we've got this in here. We're going to change the name to PC1. We'll worry about the rest later. I'll click on OK and we'll restart this machine and then continue on with some more configurations. So you already know how to do this. We'll click on OK and then restart and then come back to the same place. Alright, so the machine rebooted. I went back to the control panel and system, and you can see now the computer name is PC1. So the next thing we need to do is go to our network card and change the settings for our DNS. There's a few ways to get here, as you know. So this is the IP address of our DC, our domain controller. So I'll click on OK and close. Again, you may need to disable and then enable the network card in order for that to take place. I find I don't normally need to do that. If you need to check, you could go to your ipconfig/all. Now we've got our control panel open still. So we're going to go back to our change setting. So we're going to go click on the radio button for domain and then type lab.local. Next we click on the more button just here. So here type lab.local and then click on OK. Then we'll click on OK. Alright, so I clicked on OK. There was a little bit of a problem. I had to restart DNS on the server. Not sure why that glitched up, but hopefully that won't happen to you. But if it does, then you can stop and restart your service or just recreate everything using a wizard on the server side. So I'll insert the administrator username and password. And then all things being equal, you should get the welcome message as you can see here. So you can click on OK, and then as per usual, you'll be prompted to restart your computer. And then you can press the Restart Now button. So I'll restart and then I'll pause the recording and go back over to the server. Just wait till this is rebooted. So I'm back over to my server. I'll go to Tools, Active Directory, Users and Computers. And you can see our PC1 has joined our domain. So over to the client machine. We'll switch account, should work. Of the user, and we're going to log in with the R. Charles account. I'll try and remember the password I put in. Hopefully this one will work, and then you should be prompted to change your password anyway. Okay, so I've been asked to change the password. So I'll go ahead and do that. Alright, my password's been changed. And I'm being signed in to the domain now as Ray Charles. Alright, you'll get some various messages appearing. Alright, so I'm in as the user. Ray Charles. What I could try and do go to the control panel, Alright, so I don't have the rights to do anything, which is what I wanted to happen. So I need to log in as the administrator or with administrator privileges, which could be upgraded on the server side, and it would then let me do that. But at the moment I could just surf the web and do whatever basic tasks are allowed under this account. Welcome to our lab on Home Folder Domain Controller for Active Directory. So we'll learn to create a home folder and share it for the user of the domain lab local. So this relies on the fact you've completed the earlier Active Directory labs. Just quickly, a home folder is a private network location where users can store personal files stored in a shared folder on a network server. When you create the home folder on the network server, users can access it from any computer on the network. Administrators can use this centralized storage area to easily back up important network files. Users from any version of Windows can access their home folders. So the first thing we're going to do is log into our domain controller. You've got an admin account. We're going to go to this PC and to our C drive. So this PC and then our C drive here. So we'll double click on the C drive. We're going to right click here and we're going to create a new folder. We'll give it the name Home. So right click and go to Properties, Sharing, and then we're going to click on Advanced Sharing. We're going to click on Share this folder. Go to Permissions. Now for everyone we want to click on Remove. Next we'll click on Add. I'll type domain users and then I want to click on check names. When I do that, it should underline it and it'll have found the group domain users, which is the one we want. For domain users, just for this lab, we're going to allow everything. So full control, change and read permissions. You might actually do that in the real world, but just for the lab we'll set it this way. Now we can see our network path 2/DC1/home. So we'll click on close and then we're going to go back to our server manager here. Tools, and we're going to go back to Active Directory users and computers. We're going to click on the users folder just down here. Now you can hold down the control key and select multiple users. I've got Ray Charles. In the earlier lab I asked you to create the other 3 users, 2 per domain. Oops, this is rebooting, so I'll continue in a second. Right, I just checked, and this is a trial version because I don't want to pay for it. I don't want you to pay for it of server, so it reboots every hour. I thought I'd actually had a power setting that I needed to change. And it might be a temperature issue because it's a virtual machine. So there we go. Just in case it happens to you. So I was just saying you were asked to create 4 users, 2 in Europe and 2 in USA. So what you do is you hold down the control button and select whichever users you want to add, but I've only got Ray Charles' account here. And then what you can do is right click and go to Properties. And we're looking for the Profile tab. There's lots here, but you'll see it if you take a look. So we're going to connect to, we need to choose a drive letter. I've got a feeling Z is used somewhere else, even though it's no longer connecting because of the way I've changed the work group. So maybe click the letter K for me. It might be different for you. Obviously, just bear in mind what you've configured when you've done practicing in your own time. And what we need to do is work out the path. So we chose our drive letter. He's chosen, we've chosen home here on the image. So we'll provide the path, which is basically // and the machine name / folder and then the username. I'll change it to what we did in the screenshot here. So if you want to follow along with me, I've got the /, sorry, not /, which for me is above my enter key. I misspoke earlier when I said /. Home, which is the folder we created earlier. Percentage, username in lowercase, the percentage before and a percentage after. So let's go back to our Windows machine. Now you'll need to log off and on, but it looks like I've been logged out anyway, so log back on. So we're going to click on the Windows Explorer icon down the bottom. I had to log out and in, and it asked me to turn on network sharing, so I did that as administrator. And you can see my H drive has appeared now, so I could upload files, folders, whatever I wanted inside this shared drive. Welcome to our lab. It's a logon script for Active Directory. So this is quite advanced really, I consider, for A+ level exams, but they do mention it in the syllabus, so I'll put it in, so we'll have a go through the lab together. You'll learn how to create a logon script for the user of the domain lab local. Please make sure you've done the previous Active Directory labs because they're kind of built in on one another. This won't work without the other labs being done. So you can use logon scripts to assign tasks that will be performed when a user logs onto a particular computer. They can carry out operating system commands, set system environment, variables, or call other scripts or executable programs. A few common scripts are mapping network drives, installing the default printer for the user, collecting system information, updating your virus and software. So there's two ways to do it. The first is done via the Profile tab on the User's dialog box in Active Directory, Users and Computers. The second is done via the Group Policy Objects, the GPO. Note that using the first method via the Profile tab of the User Properties will work for any Microsoft-based operating system, especially useful if you've got older clients such as Windows 95 or 98. I don't know if anyone's still running this, maybe in an office somewhere, or Windows NT, but just so you know. So these types of operating systems do not use group policies, therefore it's recommended you only use one method. So we'll add a new virtual disk to one of the machines. We'll shut down the domain controller and then add a disk. I think this was done in not a virtual box, this will be VMware, so your instructions will be different if you're using VirtualBox. There's plenty of videos on the internet for this, but storage, and then you'll just add, I can't do it because it's turned on at the moment, you'll add a new hard drive, a new hard disk. I think I've got one here, so I'll log in actually, and I'll check on the server. Yeah, I've got this disk here, volume E. I think I must have created this for another lab, maybe using the disk management. But otherwise, the easiest thing to do is go through, if you've got the lab and you're using VMware, follow the instructions, or if you're using VirtualBox, just click on, just search for how to add a new hard drive. I think we might have covered it in an earlier lab also. So you've installed your next hard disk, your virtual hard disk. You click on File and Storage Services, and then click on Disks. So I've got my two disks here, the original one that was installed, and then number one would be the new virtual hard disk. So click on the one that you want to make a change to, in our case is 1, and then right click, New Volume. So you right click, New Volume. I've already got a volume name, so I can't, excuse me, I can't do this on the server. I've already got an allocated letter. So the wizard will help you create a volume, assign a drive letter, and then format it. So you click on Next. Click on Next. The selected disk will be brought online and initialized as a GPT disk. To continue, click OK, or select a different disk. The size you can choose, you can leave it as a default. Click on Next. Now assign a drive letter. I've already did this in an earlier lab, so sorry, if I right click and go to Disk Management, I've got my E drive here, which so it's already happened. So they clicked on Z when we initially did the lab, but mine's an E, just so you know. But you can set it as the drive, the Z drive. So NTFS, and call it network share if you want. Click on Next. And then click on Create. Then you can go to File Explorer, and you'll see it labeled as network share. I went to mine, which is called New Volume, and under General Network Share. Not that it's essential for the lab, but I might as well do that while we're on this step. Double click Network Share Disk, and then inside we're going to create a new folder. But what you can do if you want is change drive letter and paths. I think my Z drive is free. That was on another lab I created a Z drive. Alright, so I've got my Z drive. We're going to go to File Explorer. So click on the File Explorer button, and then you'll be here. Double click on your network share, right click, New Folder, and the name of the folder is going to be user_shares. We'll go to the folder, we'll right click it and go to Properties. Click on the Sharing tab and then hit the Share button. We'll type everyone and then press Add. For the permission, we're going to give read and write, and then we'll click on Share. So click on Done. What I'll do is go back, just click on the File Explorer icon again. Now the default location for your logon scripts is the net login share, which by default is shared on all domain controllers in Active Directory Forest. It's located in the following folder: the system root, sysvol, and then the domain DNS name, and then scripts. So here's our lab local folder. Now the other way to get here, so you can actually click in this bar here, percentage system root with a capital S and R, backslash sysvol, backslash sysvol, backslash, press enter, and we arrive at the same place. We'll double click on the lab local. Now if we go into the scripts folder, we'll see that it's currently empty. So we know we've shared the user shares folder inside the Z drive. Now the administrators assigned this hard disk to the system, created a share for the users of the domain lab local. Now the administrator wants to make this network drive available for each user that logs in at the domain with their client machines. So we'll right click in here, then in New, Text Document. And we'll call this Login. We're going to click on View, File Name Extensions, and Hidden Items. And then we can see the .txt extension at the end of our file. We want to right click this file and then go to Rename. We don't want to change the name, we just want to change the extension to BAT, login.bat. So you see the icons changed. We want to right click again and go to Edit. So this is the code we want to use. You don't really need to worry too much about what it means. Alright, so at echo off in capitals, net use Z, so our Z drive, space, quotation marks, backslash DC1 backslash users underscore shares. So next we're going to go to right click, then properties. We're going to go to the Security tab and then press on Edit. Going to click on Add. I'll type domain users. Check names. It should underline if you've typed it incorrectly, and then click on OK. And these users will have allow read and execute and then read. So that's the default, which we'll click on Apply and then OK. We'll get a warning that you need to read. And then another warning, so we'll click on Yes. So I'm going to click on Tools. We'll go to Group Policy Management. On the lab local, we're going to right click and then create a GPO in this domain and link it here. Call it login script GPO. Click on OK. We're going to right click on the login script and we're going to rename. Sorry, we'll click on edit, not rename. So we'll click on user configuration, policies, window settings, scripts, and then we'll click on log on. Next we click on show files. Then we have to find our login path. We'll copy that and find my way back to the original folder. Right click and paste. You can check in the login properties to see if it's there or not. You click on Add and then you click on Browse, and you can see the excuse me, the login back script is there. So let's go to a client machine. It needs to be in the same network. There's Ray Charles. I'm trying to remember the login information. Alright, I'm expecting the Z drive to appear under here. I can see it's under my network drive, but it should appear as a volume up here as well. I did notice I did make a mistake. I typed users. It should be users shares, but when I actually created the folder, I created user shares. So I've changed the name. Troubleshoot performance problems. One of the most popular troubleshooting methodologies begins at the physical layer and moves up through the application layer in a bottom-up order. Usually when we can observe slow application loading time, slow transfer time, inability to connect to specific services, where you normally suspect some performance issues are actually occurring. Some cases that we encounter during performance analysis are DNS problems, incorrect subnet mask values, incorrect routing tables. Our first solution that can immediately spot the source of the problem and solve it is to take a baseline of normal network performance communications and compare with the faulty ones. High latency times can be caused by distance, queuing, delays along a path, processing delays, and so on. Open up Wireshark, capture a few minutes of traffic on your active network interface, and then save the file. I just opened up a web browser and hit a few websites, which I'm sure you can do.
For those venues that the financial.
Sorry, one of the videos was playing on the site I opened. So capture a few minutes of traffic, and then I think we have to do a stop, save the file, and then we'll continue with the lab. So we go to a main menu, View, Time Display Format, Second Since Previous Displayed Packet, as displayed here. Click on the column Time in the packet list pane in order to sort this column and note large gaps in time between packets in the trace file as displayed in the figure below. So just bear in mind this is a different capture than you'll have. Yours will be unique to your own home device. In the capture, the maximum gap is 0.97 seconds. It's important to remember that in the case of the trace file contains numerous conversations, we have to filter in the conversation before sorting the time column to ensure that we are comparing times within a single conversation. To do so, just select from the main menu, Analyze Conversation Filter as displayed in the figure below. I'll choose TCP. So now we can see only our TCP traffic. We can note the maximum gap is instead 0.99 on this capture because we've chosen the TCP. It's also possible to add a new column through the preference window where we can select an additional delta time. Another option is to inspect the frame content in the packet details pane as displayed in the figure below. In this case, we can see numerous time values inside the frame section. Although these values are not actual fields in the packet, Wireshark can find packets based on their values. Packet timestamps are provided by WinPCAP, LibCAP, PCAP, AirPCAP libraries at the time the packet is captured and saved within the trace file. The above mentioned libraries support microsecond resolution. Another possibility is to filter on the arrival time of packets. The arrival time value is based on the system time at the time the packet was captured. For example, we can use the following display filter to filter out packets arrived after 11:10:30 p.m. on March 26. Obviously, this is again different. This is when the lab was first written, so this filter won't work for you. You can alter it to whatever your local time is. Welcome to our lab on slow processing time. So when a host doesn't have sufficient processing power or memory, or an application doesn't respond in a timely manner, you'll see gaps in response time between requests and replies. These gaps may be accompanied by other evidence of the problem, such as TCP window size of 0 or a TCP size, a window size smaller than the TCP MSS value. Alternatively, application responses may indicate an overloaded condition. Consider reassembling streams to decipher any plaintext messages if they exist. The messages may clearly define the application problem. Capture Wireshark for a few minutes while you're navigating a web browser and then stop and save the file. In order to focus on the TCP round-trip latency time in the TCP handshakes, fill in the display toolbar with the filter TCP flags equals 0x12. As clear in the figure, the applied filter will display only the SYN ACK packets. From the Wireshark preference menu, select Protocol on the left tree menu and then TCP. Assure to have enabled the Calculate Conversation Timings as displayed in the figure below. From the preference window, add a column for time since the previous frame in this TCP stream. TCP time delta as displayed in the figure below. Sort this column by clicking on the column header to get a feel for the round-trip latency times of the TCP connections. The result is displayed in the figure below, where it's possible to observe that a few connections have a high round-trip latency, over 700 milliseconds. Again, this is on the capture done for this file. Yours will look different. After that, remove the previous filter from the display filter toolbar and double click again on the time delta header column in order to sort again the values of the time deltas. This enables you to see major delays between packets in each separate TCP stream and to consider and decide which stream do you want to troubleshoot and which don't you want to troubleshoot. When we have numerous interesting packets we want to focus on, also in a later stage, it's a good time to right click on these packets and select Mark Packet Toggle as displayed in the figure below. As a result, you can see all the marked packets in the packet list pane, but it's easy to return to in a later stage any of these packets using Edit, Find Next Marked Packet or Edit. We've done this in an earlier lab. Next, you can examine each packet with a large TCP delta time and apply a TCP conversation filter to see what's happening as displayed in the figure below.
Welcome to our lab on defragmenting your hard drive. I'll have to change that, sorry. The files on your hard drive become fragmented over time, and your desktop or laptop slows down because it has to check multiple places on your drive for these pieces. Now, conventional wisdom says that with modern computers we don't really need defragmentation because Windows automatically defragments mechanical drives, and it's not necessary with solid state drives. But it is in the syllabus, so let's have a look on how to do it if you have to, and especially if you're working on a customer site or dealing with a traditional hard drive. So you can go to the search bar in Windows 10 and click on defragment or optimize. Note any default settings that are in place. So I just said that Windows automatically does it, and you can see here on drivers have been optimized automatically and the frequency is weekly. Select any hard drive you wish to defragment and click on Analyze. Note that a solid state hard drive has the button grayed out, so you can't click on Analyze or Optimize. So I'll click on this drive I created in an earlier lab, and the operating system thinks that this is a hard disk drive, not a solid state, because it's running on a virtual machine, so that's fine. So you can click on Analyze. Not much is going to happen because this is a new virtual machine, but it could take longer obviously on an actual hard drive. OK, and the 0% fragmented. Now if you wish you can click on the Optimize. Again, not much is going to happen here because it's a VM. The only other thing to note here is the change settings. You would need to know you can change however you wish, daily, weekly, monthly. You can increase the task priority, which I'll let you do in your own time. But yeah, that's basically how to run the defragmentation and the analyzation on Windows 10.
I wanted to share with you this little known trick or facility. It's called God Mode by many, and it involves creating a folder onto your desktop in Windows. We're going to do it in Windows 10. So the first thing we'll do is right click on the desktop, create a new folder. Now, in fact, what I'll do first, just to save myself time, I've copied this text here. So God mode dot and then all of these values in the curly brackets. Easiest thing for you to do is just Google Windows God mode, and you can copy and paste the code rather than trying to type it out from what you can see on the screen. So I'll go new folder. Now it hasn't got a name yet, so I'm going to press Control and V, and you'll note you can't see at the moment here the God mode dot, which is fine, that's to be expected. I'll press Enter, and now you can see an icon has appeared. So you can obviously put this anywhere you want in a troubleshooting folder on your desktop, but what you'll note when you click on it, and it could be different for different versions of Windows obviously, there's a whole bunch of tools you can very quickly access here that you're going to be able to use for your troubleshooting. Note that some of them here for saying for Windows 7, don't know why, because this is a Windows 10 virtual machine. Manage web credentials, add clocks for different time zones. There's a whole bunch of facilities. Optimize for blindness, show hidden files and folders, which you covered in an earlier lab. So please, rather than me just clicking on them, activate the God mode, and then go through some of the settings, make a note. Not necessarily in the syllabus, not sure, but troubleshooting is, and this is a handy thing to have for your troubleshooting, especially we've got a whole section on troubleshooting here. We're going to look at program load times. It's mentioned in the A+ syllabus in a few areas. If you're troubleshooting speed issues on your operating system loading, knowing the time it takes programs to load at startup will really help you. Once you've got a list of processes slowing your machine down, you'll have the option to remove those programs from startup for a faster boot time. So the first thing we'll do is click on Task Manager after we right click our taskbar. So just here, and we've been here before, Task Manager. And it'll probably come as no surprise that we're looking for the Startup tab. So I just had to remove it because I added it when I was testing the lab. So you'll see the 4 tabs here, the name, publisher status, and startup impact. And what you can do is right click anywhere here, and you can see the other options, disk IO at startup, CPU, running now, etc. We want CPU at startup, and if you want you can click on this column to see your lowest to highest CPU in milliseconds. The biggest culprits, I don't have it on this machine, are usually Chrome, the web browser, and then you can see Microsoft OneDrive here is using a lot of resources. So this is going to slow your boot time considerably. Depending on, obviously if you're at work, you need to find out if you're allowed to and if it's a vital service or not. But if you wanted to fix the slow startup, then you could right click whatever program you wish, click on disable, and then you'll see the status is disabled. Now when you next time you boot the machine, the Microsoft OneDrive or whatever you've disabled won't operate. The other thing, I'm sure it's pretty obvious, but you can drag any of these columns to fit your particular requirements. We're going to look at rolling back device drivers for no other reason than it's included in the troubleshooting section of the syllabus. We normally update drivers. It can be done automatically in Windows, but we do it in order to improve performance and stability, fixes bugs, introduces any new features. Sometimes if we do update a driver, it causes issues requiring you to have to revert back to the last known good driver. So this feature in Windows is called the Rollback Driver, done via the Device Manager. A few ways to get there. I'm just going to type Device Manager into the search bar. Let me just find my machine, sorry. So I click on Device Manager. You've got a whole list of devices here. Normally the one that's updated most frequently is our display adapter. Now the problem I've got here is this is my virtual machine, so there's no new drivers. I could possibly try and do a search and update some drivers, but what I'll do instead is pull up my actual live machine, because I know I've got a card here, the NV, and I don't know how you pronounce it, NVIDIA GeoForce. Forgive me if there's another way to pronounce that. So I know this driver's been updated recently. I've got some of the bits and bobs that have updated, but I'll right click anyway. You can obviously update, disable, uninstall, scan for hardware changes. We want to go to properties, and you would normally check your date and then also the version. So you can see the numbering system they have here. You would check, and if there's a new version released, it would have some release notes, and you would check whether or not you were going to upgrade. And then obviously if you're going to downgrade, you downgrade to the previous one you had. So what you would obviously do if you wanted to update, it would search for the update. There's software that can scan your machine, and also I think it's called Driver Agent,
and you can check for all your drivers. And the one you want to do if you're going to do the rollback is the rollback. You might have to do this in safe mode. And then it will say, are you sure you want to roll back to the previously installed driver software? You would click on yes. Now, this is my home computer, and I'm not going to do that because it could just cause me a lot of headaches with my display, more than I already have. So you would click yes, and then the next thing you would do would be restart your machine, and it would boot with the new driver, log back in, right click, and check the driver version.
Welcome to our lab on the Safe Boot. So it's an important troubleshooting tool. It starts the Windows in a basic state using a limited set of files and drivers. So if you boot into safe mode and the problem doesn't reoccur, it means your default settings and basic device drivers aren't causing the issue. So it's going to point you to something else that wasn't booted in safe mode. There's two versions. Safe mode and safe mode with networking. Networking adds a network driver and services you would need to access the internet and other computers. Right, there's 7 or 8 ways to boot into safe mode, and there's some differences with Windows 7, 8 and 10. So please do your own investigations. I'm just going to cover Windows 10, and I'll use the one method where you go to the search bar and type msconfig. So we've got a few tabs here. The one we're interested in is boot. I think we've covered this before when we were looking at options to boot into different operating systems. We don't need the advanced options this time. We just need to tick on safe boot. You've got other options as well, which we're not concerned with for this lab. If we just go down here, you can also look this up yourself, but minimal start safe mode with the absolute minimum of drivers, but you've got the graphical user interface. The alternate shell, this starts with safe mode with the command prompt. You've got to have advanced command line interface understanding in order to boot, because you've got no graphical user interface and you can't use your mouse. It won't boot the mouse drivers. So this would be advanced knowledge. Active Directory repair starts safe mode with access to machine specific information. A network starts the safe mode with the necessary services and drivers for networking with the standard GUI. So I'm going to leave it at minimal. I'm going to click apply and OK, and then I'm going to restart. And just one thing to notice is this is a virtual machine, so I'm going to be a little bit stuck because I don't actually have any hardware cards like my new sound cards and video cards and that kind of stuff, which could cause problems. So but note the background, which will it should boot into a black screen. Alright, so you can see it's booted and the desktop background has gone, and also I've got safe mode top left, top right, bottom left and bottom right. So you can see you're in safe mode. Your screen may well change as well if you're actually using your own home PC or work PC or whatever. The resolution may change. It may not. Things may not be as visible as they were before, especially if you've set things up on a new video card and you've booted and you've only got your generic desktop drivers. So you can do whatever troubleshooting you want. If it still doesn't boot, then you may have to boot into the command line or boot without networking, and then you need to disable it. So we go back to msconfig. If I reboot the machine now, it's going to boot back into safe mode, so I need to untick that, apply OK, and then click on restart. Troubleshooting incorrect net masks, but probably not what you think it's going to be, because on your point-to-point connections, you'll often find that even if you put the incorrect subnet mask in, your connections will work. So I'm going to do something that would be an advanced problem, but still caused by incorrect subnet masks. Not quite what you think, but I found a lot of my students encountered this problem and they were completely stumped as to what caused it, because they were looking at a routing problem when in fact it was just an incorrect configuration problem due to incorrect net mask. So we'll get a couple of routers up and just connect them with a fast Ethernet cable. So we'll config this one and call it hostname R0. So this is our left-hand router, and we'll configure the fast Ethernet interface 192.168.1.5. So this is a point-to-point link with a 30-bit mask. If you've learned your subnetting, which I hope you have, this is the second available subnet when you're using a 30-bit mask. The first subnet would be 0, second one 4, next one 8, and so on. So it goes up in increments of 4. So I'll add the address this side. This is the last host available on the subnet. So you see we're putting the correct mask in, but the incorrect net mask will be happening somewhere else. So we'll configure our OSPF. Router OSPF1, just follow along with me. Network 192.168.1.0. Then our wildcard mask, we've already configured OSPF before, area 0. So we're configuring the net mask, a wildcard mask to match our subnet mask. Network 192.168.1.0, 0.0.0.3, area 0. So we've configured our routing and we think everything's working fine. But we find our OSPF neighbor relationship doesn't appear. We normally get some sort of informational message. Show IP OSPF neighbor. Okay, now people start scratching their head. They're looking at their OSPF configurations. They're looking at the IP masks, show IP protocols. Well, they're thinking, hang on, this is all working fine. I can see my router ID. So this is where people start going in circles, doing ping tests, etc., etc. Well, I'll show you now in Notepad what actually happened. So 192.168.1.0, 0.0.0.3. So this is our wildcard mask that matches the subnet. This configuration will match network number 0, host numbers 1 and 2, and broadcast address of 3. Well, we don't have that on our point-to-point link. We're using the second subnet, and you could be using the third, fourth, fifth, whatever. So this is what we need to advertise, 192.168.1.4, because that's network 4 and hosts 5 to 6, which is what we have in our connection. And you imagine we've got loads and loads of point-to-point links with a /30 mask, so you need to work out the correct net mask. Alright, so you can type out the command again. You can, to be quick, you can usually highlight it and then just type the command out again with no in front. So no network, and then we'll type out the correct network. And then when we configure it on the other side, we should hopefully see the informational message. Remove the incorrect network. We could leave it on, but we want to keep the configuration tidy. So it's network 1.4, and then that will advertise the hosts also. So just wait a moment and hopefully the information message will pop up. OSPF's loading to done, neighbor 1.5 on the fast Ethernet. Show IP OSPF neighbor, and we've got a neighbor relationship. Show IP protocols will show us the correct configuration. Alright, that's the end of the lab. Thanks for watching. We're going to learn how to restart services because it's one of the syllabus items somewhere here. Service is an application type that runs in the system background without user interface, similar to the Unix daemon process. Services provide core operating system features such as web serving, event logging, file serving, etc. Most of them we have no interaction with as the user session, and they have no user interface. It's important to note if you do stop or start or restart a service, any dependent services are also affected, which I'll show you in a minute. If you start a service, it doesn't automatically restart its dependent services, so you could be causing yourself quite a few problems if you don't know what you're doing. I'll just fix the command here because this was from an old lab. It's services.msc. There are other ways to get here, but for this lab we'll do it this way. So you can see the name, description's handy if it's something that's a little bit obscure. So what we'll do is DHCP clients. Now I won't actually stop this, but what I want to do is show you, if I click on the stop button, it's saying when the client stops other services. So these are dependent services: Win HTTP web proxy, network list service, network location. So I don't want to stop these services, and it wouldn't work anyway. So we'll go to something that's inoffensive, like our printer drivers, our print spooler. That's what we're looking for. So there's a few ways to do this. The first thing, you can see it's running. The startup type is automatic. I'll just explain that. So the service spool prints jobs, handles interaction with the printer. There's some other stuff there which you can read. So if I wanted to, I could just press the stop button here. Don't get any warnings, and you can see it's no longer shown as running. And then I could press the start service, and it starts. I can also right click and stop and start, restart. I can even restart it if I wish. I could double click, and this is a bit better for me because I can't increase the size of the window, but I can see the rest of the description here. And I can change the startup type. So automatic will start automatically, obviously. A delayed start, it can start manually, so that's me having to do it, or I could disable it if it's causing me problems. And we talked about safe boots in the previous lab to this. The other thing I can do is stop it here, and obviously this button will appear. Start, I could stop, pause, resume.
Hello all, and welcome back to 101 Labs. Today we'll be looking at conducting an evil twin attack with Airgeddon. Airgeddon is a Wi-Fi auditing script. It is very useful as it uses a lot of tools in the one script. This means that the script will launch the tools for us using our given settings, as opposed to us having to set up each of the tools separately ourselves. For this lab, you'll need Kali Linux and an external wireless card. To perform this lab, you'll need an external wireless card which can be connected to your virtual machine through USB. This wireless card should also have the ability to be put into monitor mode, which allows it to monitor all traffic on a Wi-Fi network. The wireless card I am using for this lab is the following. You can view what I'm using here. So, let's begin. The first step is to open Kali Linux in your virtual machine and then open Terminal. This is the GitHub page for the Ergeddon script. To download the script on your Kali machine, simply type the following: sudo git clone this. A prompt may pop up telling you that X amount of space would be used to download the script. Simply type Y and the script will download. Once the script is downloaded, type ls into the terminal. You should see a file called Ergeddon. Type cd Ergeddon to change the directory to this file. Type ls again and you should see a file called ergeddon.sh. Type /ergeddon.sh to run the script. Now that may sound like a lot, but it's actually really easy. So if we go ls to view all files on our desktop, we can see Ergeddon there at the top. If we change the directory to that directory, we're now in that directory, and then type ls, we can see ergeddon.sh. So all we need to do is type /ergeddon.sh and press enter. Perfect, we're now in the script. The script will run a number of checks to determine if you have the correct tools installed. Simply follow the on-screen prompts. It will also give you the option to install any tools which you are missing. You should press Y when given this option to get the full capacity of Ergeddon tools. So let's do that now. As you can see here, let's check if you have installed what the script needs. It's just going to check what tools you have installed. So press enter. Great, so I have nearly all the tools installed. So if you have a number of errors here which indicate that the tools aren't installed, you can simply press Y here to install the tools. I don't need SSL strip, so I'm going to press no. The script will then check for internet access, looking for a newer version. So just press enter again. Perfect. So this screen is now going to ask us which interface we want to use. WLAN 0 is the one that we want to use. This is the wireless card that I have connected through USB. So if we press 2 and hit enter, we're now presented with the main screen. Once at the main screen, the first step is to place our card into monitor mode by pressing option 2. So 2, enter. Perfect, our card is now in monitor mode. With the initial setup behind us, we can now begin the attack. So choose option 7 for Evil Twin Attacks menu. So 7, enter. For this lab, we'll be creating a captive portal to capture the Wi-Fi password of our chosen network. Choose option 9. So 9, enter. Ergeddon will now explore for nearby Wi-Fi targets for us to exploit. So if we press enter and enter again, this window will then pop up looking for different Wi-Fi networks. So if you leave this window run for about a minute, it should pick up all the Wi-Fi networks near you. When you've found your target Wi-Fi network, press Ctrl+C to end the discovery. So I have found mine. You will then be presented with a screen which displays all discovered Wi-Fi networks. Choose your network by typing the number beside it into the terminal and press enter. The next screen will ask you how you want to de-authenticate people from the network. We will be choosing option 1. Do not enable DOS pursuit mode, as the card I am using doesn't support it. Do spoof your MAC address on the next screen, as this is good practice. This will provide a fake MAC address in the router logs. So we'll be choosing option 1. We don't want to enable DOS mode, and we do want to spoof our MAC address. We do not have a captured handshake file, so choose the No option when asked for this. Press Enter when asked to provide a value for timeout to accept the default value of 20. Press Enter again, and Airgedden will be kicking host from the target Wi-Fi network in order to obtain a handshake. So we'll return here. No, we don't have a handshake file. We want to accept the default and enter to begin our DAuth attack. So what this is doing is kicking people who are connected to the Wi-Fi off the Wi-Fi and then capturing their request to reconnect to the Wi-Fi. Okay, so we've captured the handshake and we will save it at the default path. We want to accept the default path for storing the captured handshake file. Great. So press Enter a few times on the next prompts to accept the default settings. The next screen will ask you what language you want the captive portal to be in. Choose option 1 for English. Press Enter again and the attack will begin. So let's look at how that works now. So you'll press 1 for English and Enter to begin the attack. A number of pop-ups will open on your screen. It is important that you do not close any of them and let the script do its work. So if we return to the terminal, we can open all of these pop-ups. Okay, so now the attack is running. So what's happening is Airgedden is kicking all of the hosts connected to the Wi-Fi off of the Wi-Fi. It is then asking for the users to enter their Wi-Fi password into the captive portal that we have created. It will then convert that Wi-Fi password into the same format as the captured handshake file. And if the two match, it will then grant access. And we will also be able to know what the password is. So what does that look like? To see how it looks like, get another device which is connected to the same network and attempt to connect to the internet. You will notice you will be unable to do so. If you look for Wi-Fi networks, you may also see two networks with the same name, one with security and one without security. Our evil twin is the network with no security. Connect to this network if your device didn't automatically and attempt to connect to the internet. You'll be presented with a screen asking for your Wi-Fi password in order to gain internet access. Enter your password and return to the script. You will see that the script will have captured the password you entered in plain text. Press Enter on the terminal screen to end the attack. So I'm going to grab my mobile and attempt to enter a password here. So right now, this script is asking me to enter a password. If we open all the pop-ups again, you can watch this screen and see the password that I will enter. Okay, so there's been one attempt to enter a password, and the last password entered was password 123. And this is the IP address of that client. Once the password is captured, we can return to this screen and press Enter to stop the attack. Any captured passwords will be saved to a file in the default location. If you are wondering what the captive portal looked like on a mobile device, this is how it looked. So we can see the Wi-Fi name here, and it is asking us for our password. When we enter our password, we are shown the following. The password is correct, the connection will be established in a few moments. This will then stop the attack in the Airgedden script and will show us the password that was entered. So this brings us to the end of the lab. We now know how to conduct evil twin attacks. Hello and welcome to another 101 lab. In this lab, we'll be automating SQL injection using SQL Map. SQL Map is an open source tool used as part of a penetration test to detect and exploit injection flaws. SQL Map is very useful as it saves time by automating the process of detecting and exploiting SQL injection. I'll be using Kali Linux for this lab. SQL Map comes pre-installed on Kali. We will begin this lab by viewing the help screen for this tool by opening a terminal and typing the following: sqlmap-h. So I'm using the GitHub version, so I've downloaded it and there's a directory in my root folder. So in order to use this tool, I have to use Python 3, sqlmap.py, and then the commands that I want to use. So in this case, -h. And this gives us an idea of how this tool is used. I'll be deploying this tool against a TryHackMe server, which has been designed for the purpose of scanning in order to practice this technique. You can deploy the same server at the following link so that you can follow along with this lab. To begin, deploy the server at the link above and connect to the network using OpenVPN. If you are unsure how to do this, please watch the lab on the OpenVPN tool. Once we are on the network, we can visit the web application by typing the IP address of the server into our browser. You will be presented with a web page containing a number of labs with different SQL injection vulnerabilities. We will be focusing on the first one for this lab, so click on Go to Challenge. So as you can see here, I'm connected to the network on OpenVPN, and this is what it looks like when you're connected. So we want to press Go to Challenge on the first one. You'll be navigated to a login page which is vulnerable to SQL injection. We can test its vulnerability to SQL injection by inputting the following into the profile ID text box. 1 or 1 is equal to 1 dash dash space dash. So if we input this here, and then fill in anything in the password field, press login. Okay, we can see we're logged in as employee ID 10, and that's the flag for the TryHackMe system. So we know it's vulnerable to SQL injection, so we can log out now again. We will then be logged into the application, and you can see the flag for this challenge here. So we know this login form is vulnerable to SQL injection, but we want to know how to automatically test this using SQL map. To do this, copy the link for the login page, then open a terminal in Kali and type the following. Note, if you download SQL map from the GitHub page, like I did, you will need to navigate to the directory and use Python to start the tool. However, if you're using the version which comes pre-installed with Kali, you can use the tool without Python. So that's the syntax with Python, and this is the syntax without Python. So let's break this command down just before we run it. -u tells SQL map the target URL. -p tells the tool which parameter in the URL we want to test for SQL injection. -- level equals 3 will tell the tool to use more detailed and comprehensive SQL injection techniques. -- risk equals 3 will tell the tool not to be subtle about its SQL injection attempt, as we've no firewalls or intrusion detection systems to worry about here. Once this command is run, you will notice SQL map attempting a huge amount of SQL injection techniques against the target. So we can copy this, go to our terminal, paste it in, and we need to just make sure the syntax is right. Whenever you're copying something from Word, we typically need to change these quotation marks because they don't really copy over exactly as they should. The same with this long dash, that should be 2 dashes. And finally, we just need to make sure the IP address that we have is correct also. Okay, so then we can hit enter and the attack will begin. So as you can see, SQL map is running a huge amount of different SQL injection techniques against our target. Okay, so we'll get a number of recommendations from the tool SQL map here. So it's recommending that we only perform basic union tests if there is not at least one other potential technique found. So I'm going to select no, I don't want to reduce the number of union tests as I want to perform a full comprehensive test on this site. Okay, so the tool has found that first of all, we got a redirect for 302 and we didn't want to follow as we're focusing on the login page. It thinks that it is injectable, so it's going to run some more tests. It found that the backend database could be SQLite, so we skipped tests for any other database other than SQLite because we only want to test the database that we have. And we do want to test extensively for all tests to do with SQLite. And now we have been given this option here. It says injection not exploitable with null values. Do you want to try random integer value for option union char? So we want to do as many tests as we can on this site as we know it is injectable. Nice. So we found that the get parameter profile ID is vulnerable, and we can say no, we don't want to keep testing for other vulnerabilities because we know there aren't any more. They're just profile ID is vulnerable. So SQL map will then give us a brief summary of what we found down here. When the tool is finished, we can see that SQL map discovered that the parameter profile ID is vulnerable. We are also presented with information about the backend database version, allowing us to craft more specific and detailed SQL injection techniques for further exploitation. So if we return here, we can see the backend database is SQLite, and that will allow us to craft specific packets or specific injection exploits in order to take advantage of this information. So that's a rundown of SQL map and how to automate SQL injection. And that brings us to the end of this lab. Hello and welcome to another 101 lab. In this lab, we'll be looking at an introduction to Python scripting. Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. Its high level built-in data structures combined with dynamic typing and dynamic binding make it very attractive for rapid application development, as well as for use as a scripting or glue language to connect existing components together. Now don't worry if that sounds a bit too technical, we'll get into it and break it down. In this lab, we'll be looking at some fundamental concepts around scripting with Python. Python is a good coding language to learn as its syntax is very simple and straightforward. Python is also very versatile and has the ability to import massive amounts of code from libraries, shortening the workload on developers. To begin, we will make a very simple first script. Open a terminal in Kali and create a new document. Open this document and type the following. Print hello everybody. Save this file as the following. Script.py. So let's do that. Okay, so if we now type, or even we can copy and paste this, print hello everybody. We can press Ctrl S to save. Save this file as the following, script.py. Then make this file executable by typing the following, chmod +x script.py. Finally, we can execute this script by typing python3 script.py. This will print hello all to the console. So let's do that now. So if we type ls, we can see our script.py file right here. If we now type ch, now mine is already executable because I already did this, but normally this would be not highlighted in green, it would be in white text. And when you type chmod +x script, just like it is there, or script.py, it would then turn green, indicating it is executable. So we can skip that step as I've already done it. Then we can type python3 script.py. Okay, and you can see it printed hello everybody to the screen. Just note that instead of double quotes, it should be single quotes used here. So I'll update this document to reflect that. So okay, we've created our first script, which printed hello everybody to our console here. Okay, so we are now familiar with how to create and run Python scripts. For the rest of the tasks, you can use the same script and delete the contents of it each time. This will prevent us having to create new scripts and then make them executable and then execute them all the time. We will now look at mathematical operators. These allow us to add, subtract, etc. in our scripts. Here's a list of the different operators available in Python and their syntax. So addition is plus, subtraction is the dash or minus, multiplication is the star above the 8 key, division is slash, modulus is percentage, exponent is 2 stars, and floor division is 2 slashes. Don't worry about the last three, we won't be covering them here, but just so you know what they are. So if we wanted to perform simple multiplication over sum, we could type 5 star 5 and this would multiply 5 by 5 and give us the result of 25. There are also comparison operators available to us, as in any coding language. These are the following. So greater than, less than, equal to is two equal signs, it's important to note this. Not equal to is an exclamation mark followed by an equal sign. Greater than or equal to is the arrow and then the equal sign. And less than or equal to is this arrow and then the equal sign. Now we will look at variables. Variables are how Python stores information. There are a number of different variables in Python. They are listed here. String, which is used to define text, an integer, which is used to define whole numbers, for example the number 12, float, which is used to define decimal numbers, example 3.2, boolean, which is used to define true or false. It can only be one or the other, so boolean can actually only hold true or false, that they're the only two options it can be. And then list, used to store a series of data types in a collection. Variables are used in a very simple way in Python. We can create a variable and print its contents very simply in Python. So let's just take a break there and just note that I don't expect you, or nobody expects you even for the exam, to learn off every bit of information here, but it's useful to have and you can refer back to it while we are going through this next bit. Open your script and delete all of its contents. Then type the following. Number equals 5, print number. So let's copy this, go to our script, select all, delete all of it, and then Ctrl V to paste in. And make sure everything here is lowercase. So Ctrl S to save, and then Python 3 script, we can see that it prints the number 5. So there should be no quotation marks here. I'll update that in the script so that you don't accidentally put them in. So it's simply print and then the name of the variable, which in this case is number. And number is equal to 5, and that's why 5 prints to the console. Now save the script and execute it. You will see the number 5 returned in the console. To receive input from the user when executing a script, we can use the following: input. So if we want to ask a user to enter a number, compare the number to another number, and then print the answer to the screen, we can type the following: number equals input, enter a number, then print number. So if we copy this again, these need to be single quotes. An oversight on my part, Control S, enter a number, let's say 15, enter, and it will print the number we entered, 15. So this is not comparing a number, it's simply printing the number that the user enters. Save your script and execute it. Enter a number when asked, and you will see that it is printed back to you in the console. Now that we have some of the basic concepts established, we will look at if statements. This is one of the most useful tools when it comes to Python scripting. An if statement looks like the following: if x equals y, do this, else do something else. If x is equal to y, the first do this command will run. If it is not equal, the second do something else will be run instead. Let's use this knowledge to create a more comprehensive script. Open your script file, delete the contents of the file, and then type the following. So number equals int, input, enter a number. If number is less than 5, print number is less than 5. Else if number is greater than 5 or equal to 5, print number is greater than or equal to 5. Else print error. So let's copy this script. Go back to our Python script here. Paste in the new script. Now we'll have to perform some indenting here. Indenting is when, if we have an if statement, the stuff within that if statement will just be a tab key away. So just this print here is under this if statement, so it will be one tab key in. The same as this else if statement, the print is one tab key in, and the same with this else statement. So finally then, just make sure that all of these are lowercase. And the prints should also be lowercase. Okay, Control S to save. So let's just run through this quickly. So we're assigning a variable number. Number is going to be the input that the user enters. We're going to use an if statement to compare the variable number to the number 5. If the number is less than 5, we're going to print the number followed by is less than 5. If it's greater than or equal to 5, we're going to print the number the user entered followed by is greater than or equal to 5. And if something goes wrong and the application crashes altogether, we're going to print error. Again, these need to be single quotes. I will update the script to ensure that they are single quotes when you are doing this lab. Okay, so Control S to save that. Return to our console, run the script. We can see enter a number. Let's enter 2. Hit enter. 2 is less than 5. If we run the script again, let's type 8. Hit enter. 8 is greater than or equal to 5. Perfect. So our script is running as it should. Save your new script and execute it. Notice the different responses printed to the console depending on the number you enter. Okay, so that's a brief introduction to some basic commands in Python. We'll be covering more in Python in the next lab. And that brings us to the end of this lab. Hello and welcome to another one-on-one lab. In this lab, we'll be looking at an introduction to scripting with PowerShell. PowerShell is a task automation and configuration management framework from Microsoft. It consists of a command line shell and the associated scripting language. I'll be using Windows Machine for this lab. In this lab, we'll be covering some basics surrounding PowerShell. PowerShell commands are called CMDlets and are written in .NET. The output of these CMDlets are objects. This means that we can perform actions on the output object by running CMDlets. The typical CMDlet is constructed using a verb-noun format. For example, the getHelp command is used to get help about a particular CMDlet. Some of the most common verbs used include the following: get to get something, start to run something, out to output something, stop to stop something that is running, set to define something, new to create something, and that's them. You can launch PowerShell by searching for the following on your Windows machine. PowerShell. Let's look at some of the most basic PowerShell commands. Keep in mind that throughout this lab, you can use get help at any time to get some information about a command. You can also use the -examples flag, which would return some examples of how this command is used. This is what that would look like. Get help, get command, -examples. So let's run this now in PowerShell. So we can open PowerShell by simply searching for it, hitting enter, and we now have a PowerShell shell. So if we copy this, go to PowerShell, paste it in, hit enter, you can see that it provides us help with regards to the get command. And it will also provide us with some examples. The get command can be used to get all of the CMDlets installed. We can use this command to search for a particular CMDlet for a specific verb or noun by typing the following: get command, verb or noun. So let's do this now for the start. Okay, so you can see the result there. So that will get all of the CMDlets which begin with start and then anything after start. Okay, so now let's have a quick look at variables. Variables should start with a $sign in PowerShell. The following is an example of a variable in PowerShell. $location equals get-location. This command will create a variable called location and assign it the output of getLocation CMDlet. This variable will now contain the current location, according to the Windows operating system. To call the variable, we simply type the following, $location. So that's just a quick simple example of how a variable is created and called within PowerShell. We will now look at writing our first PowerShell script. Before we are able to execute any scripts, we will first need to change the execution policy on our Windows machine. It is recommended to do this in a Windows virtual machine or another machine which is not your main or host operating system. Changing the execution policy will allow your machine to execute any PowerShell script. If you download a PowerShell file containing a virus, this could be disastrous for your PC. To change the execution policy, open PowerShell and type the following commands one after the other. Get execution policy. So let's open PowerShell and type these now. Okay, so if we begin with get execution policy, we can see that we have our execution policy as remote signed. That's the one we want, but I will continue with these commands just so you get an idea of how they are used. So we want to set execution unrestricted. We want to type yes in the prompt to confirm that we want to make this change. I currently don't have access in my machine, so to do this you will actually need an administrator shell, which will need to be launched as run as administrator with this button here. Just confirm that we want to start it. Okay, we now have an administrator shell. So again, if we run get we can see remote signed, so let's change that. Type yes to confirm we want to do that, and then again let's type get execution policy. We can see unrestricted. Perfect, that's exactly what we want. Your execution policy should now be set to unrestricted and we can proceed with the lab. Open a new file in Notepad and type the following: $info equals, and then in quotes, hello, exclamation mark, and then on a new line, write -host $info. Save this script to your desktop with the name script.ps1. Now open PowerShell if you haven't already by searching for PowerShell, then call the script with the following command, and in quotes, c desktop/script.ps1. Now this may differ for you if your drive, for example, is called something other than C, and you're simply specifying the path to where script.ps1 is stalled. So let's create this now. So if we open Notepad and we copy this, go to Notepad, paste it in, and then we press Ctrl S to save. We can go to desktop and type script.ps1. Perfect, so we now have script.ps1 saved. So now if we go to our PowerShell terminal, we can type and space and then in quotes C desktop / script.ps1, close the quotes and hit enter. So make sure when copying from PDFs that you will need to replace those quotation marks, as PowerShell will not be able to read them properly otherwise. So if we now attempt to run the script, you can see that hello is written to the host, which is what we specified in our script to do. So our script is running correctly. Notice how hello ! Is printed to the console. Okay, we have executed our first script in PowerShell. Perfect. So that's a quick introduction to PowerShell and how scripts work and how they are constructed. And that brings us to the end of this lab.